with Professor Kuo for about sport nutrition, right? And until 4:15, but Professor Kuo just until he finished. And this for the agenda from 9 to 11 is Professor Kuo. After that is from Dr. Siti Musliha from UPSI, Malaysia. And the third agenda is Professor Roni Lesmana from UNPAD, Pajajaran. And fourth is from Polandia with assessor Professor Mikhail Starczewski. And the last is from Kanoya, Japan, Professor Ryuna Kehara. Okay, we're going to the first agenda with Professor Kuo. Before that, for the participant, need to turn on your camera and please turn off your microphone during lecture. And question can be asked by chat menu. And the link of certificate I will give after finish all lecture. And here is Professor Kuo. He's distinguished professor from Sports Science, University of Taipei, and PhD in University of Texas at Austin. And his corpus H index is 29. The document is 230 and citation is 3,382. And his research specialization is about human performance and sport nutrition, also human metabolism and aging. Professor Kuo, are you ready? So the screen is yours now.
Okay, thank you for your introduction. Okay, let me share my screen first. Okay, thank you very much for inviting me to give the lecture today. The topic today I was choosing is the sports nutrition, improving immunity and aging. And one of the reasons that I choose this topic is because we understand that the current situation in human life is suffered by the COVID-19, right?
Yes.
And you also see that some people dying because of the infection, and particularly older people, right? The younger people were mostly fine. And also I'm bringing this opportunity to just to let everybody know that the immunity not only important for defense, but also important for your performance and survival, and whether or not you are going to age. So that is the main content today. Okay, so if you have a good immunity, then you will be able to make your body younger. Okay, next. I would like to bring the important question today. The first question is, how exercise training make you stronger and living longer? Okay, so now we already have good experience that when you do exercise training, you feel fatigue, you feel pain, but if you have enough rest, you are becoming stronger and you are living longer as well. And what is the reason behind this? Today, I'm going to give you the fundamental background actually the biological background, and also I would give you the knowledge that the immune system plays important role. Second question. Is human body a perfect design of life? Okay. Okay, that really depending on how you define perfect. Okay. Some people define whether you are perfect based on how long you can survive under healthy conditions, right? And this is largely associated with the immune system. Okay, and I would that is one of the reasons that I'm going to talk about the immune system. The third, so everybody asks the question why we can't live forever. Okay, and from here I can give you a very short answer. One of the reasons is because the immune system is unable to keep up as we are growing bigger and bigger. And I would mention that with some of scientific evidence later. Okay, another question is, what is the role of immune system in survival fitness? And can we manipulate immune system to make you perform well and living longer? Okay, so this is not only the question, important question for if you are athlete or the normal individual want to make yourself stronger. This is question for everybody if you are thinking about to live longer. Okay, so let's get into the lecture content. Okay, the first content is role of bone marrow derived immune cell on aging. Okay, so from here, you can directly know that the immune cell is produced in bone marrow. Okay, so bone is very important tissues. Okay, you look at your body and you found that bone is everywhere. Okay, and you can see that in your head you have skull, right? The skull is bone, and in your leg you have the bone, right? And we tend to think that the bone is simply supporting organ to your body. That is not completely correct. In fact, the most important role of bone is to produce the stem cell and then produce immune cell. And that has very important ramification for sustaining your life for a long time. Okay, and I would also talk about exercise, mobilize bone marrow stem cell into blood and tissues. Okay, so you know that all over your body you have tissues, and those tissues need bone marrow cell, and exercise can induce those bone marrow cells from bone and get into blood and share with the tissues. Okay, and that will causes the cell renewal by nutritional, especially under normal nutritional support. Okay, you know the cell renewal, you want to build a cell, the cell need to have a carbon source, you need to have the nitrogen source, and therefore you can build a cell, right? So cell building requires nutrition. Okay, so that is the reason that the exercise it's going to renew your cell, and the nutrition is also important. So we need to talk about the nutrition with exercise together. Okay, so here, before we get into the exercise part, I would like to give you the fundamental mechanism, some of the fundamental knowledge that how a human body is operated. The first thing is we need to aware that human is multicellular. Okay, so if you count how many cells in your body is 100 trillions of cells. Okay. Okay. And this is the distribution of cell number and mass of different cell type in human body. Okay. You'll be surprised to see this, because if you look at the human body, okay, those trillions of cells, then you see most of the cell are what? Bacteria. Okay. So the human body are made mostly by bacteria, more than 50% in cell number. Okay. So this is the cell number. But you know, the rest part of the cell that we study for human only account for smaller percentage, less than 50%. Okay. So you can see that in human cell, most of the cell are what? The red part. If you just don't talk about the bacteria, right? And you only talk about the bigger cell in human body, most of the cell are the red, right? The red is erythrocyte, that is red blood cell, right? And the other cell only count very small part, right? Okay, so this is the in terms of the cell number. Okay, but if you look at the cell mass, okay, what is the heaviest cell in your body? You can see that muscle cell, although it's very small in cell number, but the percentage in mass account for approximately 30%, right? And the bacteria account for only very small amount, 0.2 kilogram, right? And muscle account for 20 kilogram. And the other cell account for 10% in weight. Adipocyte account for 13% in weight. And the blood erythrocyte account for only 3 kilograms of the body. So you can see that in a human body, we have a combination of all kinds of cell type. And if you ask the question, what is the half-life of your body? What is the half-life of all cells in human body? Half-life means the longevity of the cell. Okay, first, what is the longevity for bacteria in human body? Less than 1 day. Okay, and you can see this is more than 50% of your cell in the body is bacteria. Okay, how about here? If you look at a human cell, what is the longevity for erythrocyte? This is the red part. For bacteria, I'm sorry, for the red blood cell. The answer, everybody know the answer is 4 months, right? So red blood cell longevity only 3 to 4 months. Okay. How about muscle? Muscle has much longer longevity. It's 15 years. Okay, 15 years. Okay, and here is the breakdown of the human cell. We exclude the bacteria. We only talk about the total amount of the cell in human body, the cell number. Okay. Okay, if you look at here, the red part is red blood cell, erythrocyte. Okay, what is the second largest cell? Platelet is also very big in number, right? And it's also very short-lived. How about bone marrow cells? Depending on what type, the bone marrow cell has many types. It's also very short. It's less than 1 month. Okay. And how about the hepatocyte, your liver? The average life is about 50 days. Okay. Bronchial endothelial cells, the lung cells, about several months. Okay, and the vascular endothelial cell is also quite big compared with the other cell, and the longevity only 2 weeks. Okay, neuron has long longevity. Okay, very long. Muscle has long longevity, but it only accounts for very small number of the cells, although it looks very big mass. Okay, so from here you understand that most of the cells in your body are short-lived, has the lifespan mostly less than months. Okay, so then you understand one fact. Most of the cell age rapidly, and when they are aged, that must be removed from your body, right? So most of the cell has the longevity less than months. How about the longevity of a human body? What is the record for human longevity? The record right now in Indonesia is 140 years. Okay. And that is significantly longer than most of the centenarian in human society. They are mostly 120 years, right? And the average lifespan in human is right now is about 80. Okay, so why the cell dies so quickly and the human longevity can sustain for 100 years? The reason is because when the cell dies, it can be renewed, right? So you should regard the human body as a society of different cells, and those cells, they are dying and regenerate all the time, right? So if you look at yourself at this moment, you have the cell that is very old, and you have cell that is very young since you are baby. Okay, when you are baby, you start to have the cell death and cell regeneration. And the reason you have the growing body weight since you are embryo, since you are very young, is because the growth rate of the new cell in your body is faster than the rate of cell death. And that is the reason you are growing and until you are very, very big. Okay. So right now, I would like to talk about the main content today, the rationale linking exercise, immunity, and nutrition. Okay. So here, again, the average cell age, not how long you live, determine use level and fitness of a human body. Okay. So this means if you are 70 kilograms and I'm also 70 kilograms of the body, that means we have the same number of the cell population. Okay. And what determines whether you are stronger than me is the average cell age. Okay. So if you and me has the same body weight, but your cell age, the average cell age is lower than me, then you are stronger than me. Okay. The reason is because the aged cells is going to give you a lot of information. So you have the pain all the time, all over your body. If you have relatively higher cell age in your body. Okay. The second, if you can control cell death and cell regeneration to maintain a static functional weight, then use is sustainable. Okay. So on another word, you can control the cell death and cell regeneration of your body, then you can live forever. Okay. But one of the reasons you cannot live in forever is because of the immunity is declining as you growing bigger and bigger. Okay. So that's why we need to talk about immunity today. Okay. And the third, I also want to talk about this. Exercise will eliminate the aged cell population in a Darwinian nature selection fashion, and that is mediated by brief information. Okay, so after exercise, you have small period of pain in your body. You feel fatigue, right, after exercise. Don't worry about that because that is the period when you have the information. Okay, information is the behavior of immunity. Your immune system start to function. Okay, the function of immune system is to recognize aged unhealthy cells and eliminate those unhealthy cells and triggers the cell regeneration. So that's why you have the information. That is the time you need to eliminate your aged cell and to regenerate your cell. Okay, regenerate the new cell of your body, and exercise help you to do that. So that's why exercise bring you a small period of pain, but later with good recovery, with post-exercise cell regeneration, then you become stronger. Okay, so post-exercise cell regeneration, you also need to have various fast digestible nutrients, because you understand cell regeneration means you need to grow a lot of new cell to replenish your tissues. Okay, you have a lot of cell death in your tissues that also need to regenerate the same cell number and that requires nutrition. So now you bring exercise, immunity, nutrition, and aging together into one context. Okay, so let's talk about the multicellularity, immunity, and bone. Again, you know, in your body and my body, most of the cells are short-lived, okay? And cell aging, cell death, and cell regeneration are continuously occurring. Okay, so let's say you have a new baby, okay? And you ask the question whether the new baby has the aged cell. The answer is yes, okay? You don't feel surprised. The young baby is young, right? The baby are small, they are young, right? And I have to tell you the truth that those young babies start to have the cell death all the time. And how many cell deaths? It's approximately, depending on the body weight, it's approximately 100 million of the cell deaths per day in a young baby, okay? So you have the cell aging. When cell got aged, start to die, right? And then you have the cell regeneration. So one of the reasons that baby are maintaining good health, looks young, the skin looks very nice, is because the cell regeneration is faster than cell death and cell aging. Okay, so in your body also the same. Okay, the body weight of a human is determined by a balance of cell death and cell regeneration. So you know, in your body and my body, we have the cell death and the cell regeneration. If the cell regeneration is faster than cell death, then you have growing body weight. And can you grow forever? The answer is no, because when you grow bigger and bigger and bigger, the immune system would be diluted. Okay, and that is causing aging. Okay, so the last remark is most important for today. Immune system is responsible for senescent cell clearance. Okay, as I mentioned that in your body and my body, we have the aged cell and we have cell death. And who is going to clean? Who is going to recognize the aged cell and eliminate those cells? Who are doing the job? Immune system. Okay, immune system are doing the job. So you need to have the immune system flowing around your body and look at whoever are unhealthy and they are aged and they will be killed by immune system. And then you start to have the cell regeneration. Okay, so when you have the cell regeneration, you have the short period of pain, and that is what we call inflammation. Okay, then let's ask the question, what causes cell aging? We call senescence. Okay, so you need to memorize this term. Senescence means the cell getting aged. You know, normal cell can replicate, but as the cell got very, very old, you cannot replicate. And that is what we call the senescence. Okay, so what causes cell aging, cell senescence in the human life? First, of course, you know, time, right? Time and growth, right? You're growing bigger and bigger, and you are accumulating a huge number of cells. And those cells has a lot of aged cell and young cell. So growth is bringing, it's accumulating the absolute amount of the aged cell number. Okay, another thing is infection, radiation. Okay, infection, for example, if you got long pneumonia like COVID-19 and you have cold, and that is going to cause the cell age. Particularly the pneumonia is causing the aging, cell aging in the alveolar, in the lung cell, and eventually those cells will be recognized by immune system, and the immune system would kill those unhealthy cells, and you will recover after pneumonia, and you becoming normal. Okay, you don't look old, right? So infection will cause a brief period of the cell aging, but because you have the immune system, then after the illness, when you recover, you don't look old. Okay. Radiation would also kills a lot of cells, causes cell aging, and that is happen all the time. If you're living on Earth, you have the sunlight, right? The sunlight is going to kill it's going to have the radiation. And those radiation is going to kill your the skin cell, causing skin cell aging, right? And the nuclear power, okay, you know, nuclear power is also give you the radiation. So when you build a nuclear power plant, you're better off to put it somewhere far from your population. Okay, so that is the reason we don't want to have the nuclear plant in our neighborhood. Okay, so let's talk about the cellular level, the aging at cellular level. Okay, if you look at this cell, one of the reasons the cell would age is because if you look at the picture right here, you see when cells are small, you have the same size of the nucleus, right? The nucleus has the DNA. Okay, the DNA can express a lot of mRNA and produce protein, right? And as the cell get aged, cell get bigger, the nuclear number remain unchanged. And you see when cell got really big, the nuclear number, nuclear size, the size of the nucleus remain the same, right? But the nucleus needs to provide service for the larger cell size. Then what happened is all the mRNA and protein concentration decline, right? So you cannot do the service for the bigger cell size. Then the cell got senescent and aged. So if you ask the question, what is the reason for cell get aged? The answer is clear. That is the cell size getting bigger. Okay, it's like the balloon. Okay, if you are blowing a balloon, the balloon will be bigger and bigger. And can you do it can you do it forever? The answer is quite clear. If you keep doing that, the balloon is going to have the explosion, right? So it's the same thing, that the cells are growing bigger and bigger and bigger, and eventually you will collapse. So growth is one of the cause. Growth, it requires time, right? Is the fundamental reason of the cell aging. Okay, so let's look at do we have the mechanism to eliminate the aging cell? The answer is yes. If you look at here, this is classical experiment. It's very simple experiment. If you take out the red blood cell in your body, right? And you will know that what is the longevity of the red blood cell in your body? 4 months, right? Okay, so you take out the blood in your body, then you look at your blood. You have the old cell, you have the young cell, right? And the old cell will be eliminated by immune system. How do they demonstrate this? It's very simple. They isolate the neutrophil and the monocyte. We call it phagocyte. Okay, so if you put the blood cell, you fractionate it with the centrifuge, right? So you are going to have the small size of the cell, and you have a bigger size of the erythrocyte, the red blood cell, and you mix with the phagocyte. You can start to see that the phagocyte, the young cell, will be killed by phagocyte only 5% per hour. But if you look at the old cell, it will be killed 35% per cell if you incubate the old cell in erythrocytes. So it's 7 times difference, right? So the phagocyte will kill young cells, certainly, very small amount. But the phagocyte would also kill the age cell and selectively larger effort. So the phagocyte prefer unhealthy cell, right? So you always have the unhealthy cell in your body, but you do not worry about that because you have the immunity, right? The immunity is going to eliminate those unhealthy cells. And that's why we can sustain youth. We look young, okay? But do you like to have very strong phagocyte? Keep in mind, the phagocyte will also kill the young cell. So the answer is you don't want to have a lot of phagocyte in your body because it would also kill some of the young cells, despite very small amount. Okay, so if you look at the picture right here, when the cells are small, right, those phagocyte, they are not going to kill those cells, but it will selectively kill those the late age of the senescent cell. Okay. Okay. Then I'm going to give you a very important knowledge right now, and they explain why we cannot live forever. Okay. The reason is right here. If you exhausting immune resource, it will accelerate the aging and decrease immune power. Okay, keep in mind that the immune cells are produced from the bone marrow derived stem cell in the bone. Okay, so if you do not have enough bone relative to the body, keep in mind the bone is the bone marrow cell producing organ. Okay, so if you do not have enough bone relative to the body, then you cannot do the service for every single cell in your body, right? You need to have the bone marrow cell, you need to have the immune cell to do the service for the entire body. Okay, and because the bone marrow has the immune cell, the bone marrow cell has the stem cell, right? And the immune cell and stem cell are produced in the bone. So as you growing bigger and bigger, the bone will grow bigger and bigger as well. But the body size will get bigger, much faster growth rate than the bone. So that is the reason. If you are growing bigger and bigger, you are accumulating too many senescent cells in the tissues, right? So the relative percentage of the stem cell, let's assume the relative percentage of the stem cell are remain the same. But if you have a bigger population, so the absolute amount of the senescent cell in your body are becoming very big. And if you don't have the corresponding size growth of your bone, then you are going to accumulate a lot of senescent cells. Okay, so what can cause this happening? Growth. That's one thing. And if you are inhibiting cell proliferation by chemotherapy and radiation, it's going to cause the aging of your body faster. So that's why if you look at the cancer patient, if they have the chemotherapy, you can see they are aging very fast. Okay, so you don't want to have the patient doing chemotherapy unless they are necessary. Okay, and another thing is persistent challenge. What is the persistent challenge? Chronic inflammation. Okay, for example, you are always under the challenge by something. Okay, so that is called the chronic inflammation. We know the inflammation mostly are short time, and that is good. You have a short time of the inflammation after exercise, then you can kill the unhealthy cell and you have the renewed cell population of your body. But if you are continuously doing that, then it's no good. Okay, so let's look at the bone is the organ for tissues regeneration, right? So that's we have already mentioned. If you can always regenerate your cells in your body by will, then you can live forever, right? And the critical organ in your body is the bone. Okay, you can see here. The bone can produce something called HSC. HSC represents hematopoiesis stem cell. Okay, and those stem cells is able to produce all sort of the immune cell right here, right? And immune cell will kill the unhealthy cell. Then you start to need the cell regeneration, okay? And those HSC can also produce the tissue stem cell. For example, the muscle, myocyte, blood vessel, adipose tissues, all sort of the cell in your body, even bone, right? Okay, so you have the cell regeneration and you have eliminated the H cell. So what is the reason you cannot live forever, right? Okay, let me show you the reason right here. Okay, this is the evidence we have shown, just published this year, 2021. We published in Aging. Okay, so the experiment is like this. We have a lot of animal. Those animal, we start to grow the animal when they are young, and we feeding those animal for their entire life. So they live in comfortable environment for the entire life. And then when they are young, the average age of the animal is 24 months, okay? And when they are young, when they are age 6 months, they start to have the animal, they start to have aging animal, okay? Then we pull those animal and So we have the longevity data for the all animal, right? And the longevity data, so we classify those genetically identical animal into 5 groups according to their lifespan. So the shortest longevity 1 represent the shortest lived animal, and longevity 5 represent the longest longevity right here. Okay, and if you look at their body composition, the only one thing that matters is the bone mass in percentage. Okay, the bone mass in percentage is not the bone mass. Okay, it's not the bone mass in kilogram. Okay, it's the bone mass relative to the body. Okay, and you start to see the short-lived group is the black one, right? At 6 months of the age, it already have relatively lower percent bone mass relative to the entire body. So this means if you have a relatively small amount of the bone against the entire body, okay, to do the service, the bone required to do the service for renew the entire tissues of the body. So if this is low, then you are going to die early, right? And relatively long-lived animal, you see they have relative higher percent bone mass for the entire life, right? Unfortunately, if you look at the blue line and the yellow line, as they are growing bigger and bigger, the relative percentage of the bone is also declining. Okay, if you look at the blue line right here and the yellow line right here, you can start to see that the time when the body weight are growing to the peak is the time when the percent bone mass are declining. So here give you the idea that if you are growing bigger and bigger, the bone marrow producing organ is relatively diluted to do the service for the entire body. And that is the reason we are accumulating the senescent cell in your body. And if you are growing bigger, then the endurance performance is going to be lower and lower compared to those who do not have the fast growing body. Okay, and one of the reasons is because you have relatively more senescent cell in your body if you are growing fast. Okay, so one good news about this is exercise can recruit the bone marrow cell from the bone into circulation. Okay, let's look at, this is the data for the CD34 cell, which is representing the bone marrow cell in your blood. Okay, and you can see that pre-post exercise, after exercise, you have the bone marrow cell in your blood almost doubled, right? And however, this increase is very short period. It dropped back in 10 minutes, right? Okay, this is aerobic exercise. Okay, and keep in mind that WR is the work rate. 70% of your peak work rate is high intensity, right? So this is only high intensity cycling give you this phenomena.
Prof, I'm not hear your voice. Okay.
Thank you. So, sorry. Okay, so this is the bone marrow cells. Okay, when you have an aerobic exercise, you have the bone marrow cell increased, pre and post. You see this is increased, right? And it's doubled. But if this is high intensity exercise, 70% of the peak work rate, you have the increase. But if you exercise a 30% work rate, you do not have the increase, right? So when you have the bone marrow cell increase, then you start to have the renewal of your body. But this is very short period increase. If you are doing resistant exercise, then you also have the increase, okay, 60%, 70%, and 80%, right? And that explains why the muscle cells, the muscle tissues can grow bigger compared with the aerobic exercise. Because when you are renewing your muscle tissues, the muscle tissues has bigger growth potential, right? So higher intensity is going to damage your muscle, right? And low intensity aerobic exercise has smaller amount of the cell damage, and that is recruit the bone marrow cell into the blood, and therefore you can renew your body. Okay, if you are able to make your tissues younger, then your tissues are going to grow. Okay, so that's why aerobic exercise and resistance exercise give you different growth potential of your muscle tissues. Okay, so now you understand why exercise can make you young, right? Okay, so that's ask the question whether those bone marrow cells are getting into the tissues and renew your body. Okay, you know the bone marrow cell has two classes. One is immune cell, responsible for elimination of the senescent cell. And the bone marrow cells can also differentiate it into immune cells, and those are into the stem cells. And those stem cells is able to replenish the tissues with the new birth of the cells. Okay, so you need to have the bone marrow cell. Then you ask the question whether bone marrow cell are getting to the muscle tissues. Okay, so this is the question. Are circulating bone marrow stem cell, we call CD34 positive cell, seated into the challenged muscle for tissues renewal after exercise? Then we have conducted experiment in 2020 and it's published in 2021. Okay, this is Tanya. Titian knows Tanya. Her paper just published.
That's good.
Okay, you can see that pre and post exercise, the stem cell also increased, almost doubled, 24 hours after exercise. If you look at 24 hours exercise, it's doubled. But if you look at immediately after exercise, it's not increased. Okay, so it's doubled. It takes a long time to get the CD34 cell seated in your exercise muscle and start to renew. Okay, so the rest is very important. Okay, and those bone marrow cells, when they are getting to the tissues, and those CD4 tissues, CD4 cells, bone marrow cell, can differentiate it into the blood vessels. We call it vascular endothelial cells. Those cells going to develop into the blood vessels, the capillary, right? You know the exercise is going to destroy some of the capillary, and the capillary can be renewed by vascular endothelial cells. And exercise can also cause the CD34 cell go into the muscle, becoming the satellite cell. We call PEG7 cell. Okay, So you can see the bone marrow cell looks like this. This is the bone, right? And you release the bone marrow cell by the blood vessel. And you can see these are the CD34 cell right here, okay? And but you want to keep in mind that the satellite cell, PEG7 cell, and endothelial cells, they are interchangeable, okay? So that means the stem cell go to the vascular endothelial cell. If they are enough, and you don't have enough in the muscle cell for regeneration, you can always bring those vascular endothelial cells to replenish the muscle cell. Peyton, how long do I have?
Still have 1 hour, or do you have any something else to
Okay.
do?
Yeah, so I'm going to try to finish early and leave the time for everybody, because last time we have so many questions. So I'm assuming that we are going to have a lot of questions. So I will try to finish early, and because this lecture is probably more deep for the audience. So I'm assuming that we are going to have more questions. Okay. So when you start to have the cell renewal, what kind of the nutrient is required? So let's go to your muscle, okay? After exercise, the muscle has the cell death, and you will be cleaned by your immune cell. And 24 hours later, your muscles start to have the cell regeneration from the endothelial progenitor cell, from the satellite cell. And what kind of the nutrition requires for the cell proliferation? The two answers, one is amino acid, another is glucose. Which one are more important? The answer is on the title of this paper. Amino acid rather than glucose account for the majority of cell mass in proliferating mammalian cells. Okay, so when you have exercise, so that is the reason after exercise, before and after exercise, you want to provide amino acid. And you also want to provide glucose, although this is not the major rule. Okay, you want to provide 50% amino acid, 50% glucose. Then you can have the replenishment of the mammalian cell. We are mammal, right? So we have mammalian cells, right? Okay. So this is resistance exercise. Okay, you can see this is the muscle cross section. Okay, and if you look at this, the muscle cross section, this is the cell, muscle cells, and you can see the muscle cells are very big, right? And you can see the small cells surrounding the muscle cell are the blood vessel and satellite cells. And the brown color represent the cell they are aged. So you can see that the muscle fiber does not look aged, but the surrounding cell, small cell in the muscle, they have 50% of the cell they are aged. Okay, and if you look further, what kind of the cell is this aged cell? You can see it's localized in the blood vessel, right? So that means despite the muscle tissues can live for, can have the longevity 50 years, 15 years, 15 years. But the endothelial cell, the longevity are very short, only 2 weeks. So in age, we have no surprise, those cells are aged faster than the myofiber. But what happened after exercise in those aged cells? Look at here, okay? This is when the young man does not exercise. It has about 220 aged cells in the muscle tissues. But immediately after exercise, the aged cell decline. So that means you have a lot of aged cells die after challenge. So this is sort of like the Darwinian nature selection. When you challenge, the younger cell can survive, right? But when the cell got aged, they cannot sustain challenge, and they are eliminated by this immune cells. We'll talk about immune cell later. Okay. 48 hours, the tissues remain younger. Okay, and this is resistance exercise. So you understand that if you do resistant exercise, you can keep the muscle younger for 48 hours. Okay, so this is very good for you. Okay, and one of the reasons is because you start to have the leukocyte aggregate into the muscle. This is what happened into the muscle later. You see, a lot of cells, immune cell accumulated here, and it's going to eating a lot of senescent cell. So the senescent cell, when they meet the immune cell, they got killed, right? And immediately after exercise, you already see a lot of immune cells in the muscle tissues, and they are stay there for a long period, especially when you have low protein. Okay, if you don't have enough protein, then the cell renewal takes longer period, right? But if you have the high protein, then the renewal process can be faster, so the muscle recover faster. So this is the reason that if you have high protein, you do not have much leukocyte aggregate in the muscle. Okay, so always have the high protein after exercise. You don't need to be a lot, right? 20% is considered high protein. 20% of the meal, of your meal has the protein, is already high protein. So you don't have a lot of protein. 20% is enough. And that is because you want to have the fast cell renewal. And we asked the question, what kind of the leukocyte? We found that it's CD68, that is phagocyte. Okay, so when you have the high protein after resistant exercise, the leukocyte becoming increased, but not as high as when you have the high protein, right? Okay. So if you can renew your cell faster by giving high nitrogen source, then you don't need to have the immune cell infiltrated into your muscle for long period. Okay, keep in mind that the leukocyte infiltration into muscle is inflammation, right? Inflammation brings pain and fatigue. So if you don't want to have the long time pain and fatigue, then you give protein immediately after exercise. Okay, how about the old people? The study we show is from 21 years young men. Okay, how about old people? The old people is the same. Okay, if you look at this is the cross-section muscle. One thing that is very interesting is if you look at the cells surrounding the myofiber, a lot of adipocyte, and they are account for the senescent cell number accumulation. But if you have exercise after exercise, 5 months of the resistant training with low calorie intake, you also see the average age the cell is going to decrease 5 months later. Okay, and this paper published at the same years as our paper. Okay, so this gives us the idea whether you are young and old, exercise challenge is going to eliminate the senescent cell in the muscle. And you understand the muscle account for 30% of the body weight of your entire human, right? So if you got your muscle renewed, then you are relatively younger, even though you and me has the same age, right? So if let's say you are 30 years of age, I'm 30 years of age, then we have the same body weight, but your senescent cell in your muscle are lower than me, then you are younger than me. Okay. So what is, I have the conflict of interest statement. We are studying some of the things that can stimulate the immune system, and that is coming from ginseng. Okay. You know, everybody know that ginseng is, many people are used the ginseng for 1,000 years, right, in human society. And that's why we are interested to look at what is the component of the ginseng that is influence your immune system. And we have done that literature search, and the component, I can give you the secret, is the RG1, right? So we patent this from ginseng about the methodology. So we call it senolytic ergogenic supplement. Senolytic means the senescent cell killing supplement. Okay, so if you eat this will help you to kill the senescent cell. Ergogenic means improve your performance. Okay, so if you can kill the senescent cells in your muscle, your performance will get improved. Okay, so you can run longer. Okay, so let's look at this reduced senescent cell aging. We are running exercise. Okay, this is conducted by Dr. Wu Junfu. He's a Chinese guy who are also the good friend of Titin. Okay, Titin, you know Junfu, right?
Yes, from China, right?
Yeah, from China. He
Yeah.
went back to China and he's now associate professor in China.
Wow, cool.
Communicate with him.
Yes, I need to
okay,
contact him.
Yes, and this is actually his study. So when he was the graduate student at UT, and he has done aerobic exercise for the human subject, and what at the moderate level, 70% VO2 max, and he asked the question whether 70% VO2 max can lower the senescent cell number. So he get a muscle cross section before, immediately after exercise, and 3 hours after exercise. And what he found is, no, the senescent cell number doesn't decrease. So if you look at the brown spot right here, it's still there, right? But when he used the same exercise, when he provide the RG1 from the ginseng, immediately after exercise, you do not see the senescent cell in this particular individual. And 3 hours later, also very low. So the muscle looks quite clean, right? So he discovered that if you are eating the ginseng component called RG1 before exercise, then you exercise, you bring the RG1 into the muscle, and the RG1 is going to help you to eliminate the senescent cell. Okay, if you look at here, the senescent cell, the senescent marker mRNA, P16 is the senescent marker. If you compare with the placebo and RG1, you can see the RG1 is about 30% lower compared with the placebo. Okay, and this is resistant exercise. This is the result from Tanya, and this is the result from Junfu. So altogether, that this gives us a very important idea that the immune system is involved with the senescent cell clearance. And based on the evidence that if you have the RG1 to stimulate your immune system, then you have a more senescent cell decline. Okay, let's look at the MPO. Okay, MPO, if you look at MPO is the marker for the muscle inflammation, because the only cell expressed the MPO is phagocyte, right? And phagocytes go around your body. Okay, so if you look at all over your body, you can see the phagocyte is everywhere, right? And phagocyte is very important because the phagocyte is sitting in your muscle tissues, in your lung, in your everywhere. Is look around the senescent cell and it will kill the senescent cell, right? But if you look at the muscle MPO, you can see that after exercise, especially when you have the RG1, when you have the immunostimulant, the MPO is dropped. So that also means your muscle does not require a lot of phagocyte, right? So you spare the phagocyte for the rest part of your body. Keep in mind, the muscle account for 30% of your body weight, right? And if the muscle does not require a lot of phagocyte, then you have a more phagocyte in your body. Then the phagocyte can clear the unhealthy cell in your lung, right? We have mentioned that one of the reasons the lung got aged is because the infection, right? Infection, if you have a COVID-19, then the lung got infected. And if you have a more phagocyte that spare out for your lung, then you can clear those unhealthy cells quickly, right? So exercise can keep you younger. One of the reasons is because the exercise make your muscle young, okay? And the muscle does not need a lot of phagocyte. And those phagocytes can make the lung younger, right? So you don't feel, so for those young people, if they have a lower body weight, when they have the COVID-19 infection, that doesn't feel nothing, right? So that is the main reason that you want to keep your size small, and also you don't want to remain physically inactive. Okay, so this is the relationship between the inflammation marker and the senescent cell marker in the muscle tissues. You can see this is very large correlation in the muscle, and we have to repeat this experiment many times. Okay. Okay, let's get into our take-home message. Okay, the first, you want to aware that the human body is made by aged, unhealthy cell and healthy cell. Okay, and the bone marrow supply immune cell for clearing unhealthy cells. In human body, the unhealthy cell is not just dying and living there. It is going to be very bad if the unhealthy cell, when they die in your muscle and cannot be removed. It's like the garbage, right? If you have the garbage in your home and nobody pick up the garbage, then 10 days later, your home is going to have a lot of garbage, then you cannot live in good quality, right? So the cells in your tissues, if they are unhealthy, if they are if they can be removed by the immune cell, then the tissues can not only maintain younger, but also have much less inflammation, and they live well. Okay, so that is because you have the information, you have the immune cell to clear unhealthy cell. And the bone marrow also provides a stem cell for regenerating tissues. Okay, and the bone to body ratio is representing the relative bone marrow cell abundance. If you have a bone marrow cell, then the bone is bigger. Okay, because the bone production, the bone growth is also rely on bone marrow cells. So the bone to body ratio is crucial for constant renewal, which decreases as we age. So you want to regard the bone as the bone marrow cell producing organ. Okay. Age cell, or we call senescent cell. So this is those cells that cannot replicate. The age cell increase bone marrow, the baseline inflammation. They sit in there and they are causing inflammation, and you cannot remove them. Okay, so you need to have the enough immune cell to remove those age cells. They occupy the bone marrow cell and leave little for others, because the age cell, if we have a lot of age cell in your tissues all over your body, then you need a lot of phagocyte, right? And if you have the infection, let's say if you have 100 kilograms of your body, then you can expect a lot of senescent cell accumulated in this kind of body. Then your bone is going to be very exhausted because they are producing immune cells, phagocyte, and they are used by all tissues. And when you have the infection, you need the phagocyte for your lung, then you can have the problem, because the phagocytes are very busy for other things, and you cannot cure your lung problem. So that is the reason why obese people, aged people, they tend to have longer recovery time after the COVID-19 infection. Okay, so here I would like to bring you a good news. That is, exercise can eliminate senescent cell and double tissue stem cell and decrease the baseline inflammation, so the phagocyte won't trap into the muscle, and thus spare immune resource against the infection. And this process is mediated by a brief period of inflammation. Okay, so you don't want to regard as inflammation as bad. Inflammation, prolonged inflammation is certainly bad, but brief inflammation only bring you very short period of pain and fatigue. Don't worry about pain and fatigue. Okay, so post-exercise protein supplementation accelerate resolution of inflammation. So immediately after exercise, you want to have a protein. Okay, but you don't want to have the protein all the time. The reason is because if you have the protein all the time, your body will grow bigger and bigger, because protein are promoting growth. Okay, so you don't want to have the tempeh if you don't have exercise. You know tempeh, right? Tempeh is also good food that give you the protein, right? But you want to have the tempeh after exercise. But if you don't have the exercise, you don't want to eat tempeh, right? Okay, immune stimulation by RG1 before exercise will enhance exercise-induced senescent cell clearance. So if you have anything that has that can stimulate your immune system, you can try to look at those natural compounds. I think that Indonesia, you have a lot of natural compounds that can be discovered. They can stimulate your immune system. So those are one of the research direction that can be done in Indonesia. Okay, so let's come back to what is the sports nutrition strategy for youth and immunity? Okay, you want to use exercise to mobilize the bone marrow cell, the phagocyte stem cell into the circulation and eventually to the tissues. Okay, then you start to have the cell renewal, right? And you want to stimulate those bone marrow derived immune cell in challenged tissues to enhance the senescent cell clearance. So exercise will bring those things into the muscle and you will clean the muscle. And you want to provide a fast digestible nitrogen and carbon source for cell regeneration and decreasing senescent cell burden to spare more immune power for the defense to the rest part of your body. So this is how you should do to boost your immune system. So thank you for your listening, and this is the time for the Q&A.
Okay, thank you very much, Professor Kuo, for your excellent presentation. And it's very important for us to know about the related your study with sports science. And actually, this is have one question about the nutrition during competition. What is the best nutrition? So like a protein or maybe glucose, but this during competition. And after this, here have your lovely student Ali. That last time you're looking for Ali, and now he came back here.
Hi, Ali, my son.
Yeah.
Hello, sir.
Good to see you here.
Yeah, me too.
If you go to Taiwan, I will be your host.
I saw. Sure for that. Yeah, I think I have some question as well, but according to Titin said that there is question, right, about the during competition sport nutrition. So I will ask to you after the question.
Okay. Okay. Can I just give the very short response to Ali? Actually, Ali has studied the formula of the protein when he is doing the research. And if you look at can you see the screen?
Yeah.
Okay, the screen gives you the idea that amino acid rather than glucose account for the majority of cell mass in proliferating mammalian cells. Okay, so for athlete, post-exercise, because if you are athlete, the exercise intensity tend to be very large, right? And after exercise, you're going to have a lot of cell death in your muscle and sometimes in your blood vessel as well. So if you are really good athlete, you have preliminary, you have a semifinal, and you have final, right? And if you ask the question, what is the time between the semifinal and final in Olympic game? They are mostly very short period. So that means you need to really know how to recover, okay? And you want to have the information go away after the first competition. And from here, you can immediately know that you need to have the cell proliferation, and that requires amino acid and glucose. Okay, this is for important information for recovery, especially for those athletes who want to get gold medal. Okay, and what else? This RG1. Okay. If you give the RG1 before exercise, 1 hour before exercise, I haven't told you that this study by Junfu. Junfu show you that if you have the RG1 before exercise, immediately after exercise, you can see the senescent cell is disappearing, right? But this is actually occurred during exercise. Okay, so the garbage removal is already occurring during the muscle contraction. So when you exercise, the tissues get aged, but those aged cell is already being removed by the immune cell. And the reason that is removed by the immune cell is because we give the immune stimulation before you exercise. So if you have the RG1 and then you exercise, then the high intensity endurance performance can be increased by 16%, which is very high because the endurance, if you look at the elite athlete, 5% difference in endurance performance is already very big. Okay, it make the top 1 and top 8. The difference between top 1 and top 8 is less than 5%. Okay, so the 16% difference in endurance performance is large. So I believe in some of the plant in Indonesia might have also produced the RG1. So that is something you can explore. Okay, Titin.
Okay, thank you, Professor Kuo. Okay, now turn Ali. You want asking something?
Ali,
Okay,
yes, please.
your turn.
Because I think we are now 258 people in this meeting, and personally, I think you have give us an insightful talk, Professor. So from today your presentation, I've got a new insight that you told us the bone marrow. The bone marrow is quite crucial for the longevity, and still remember your statement that the best indicator for every treatment or every activity or anything that we can do is based on our survival. And it is really interesting to know that the resistant exercise is better than aerobic exercise on the beneficial effect on the clearance of aging cell. So my question is not about during competition, or it is about the sport for all for the fitness. What is your best recommendation for the best resistant exercise program? Because we all know that based on your talk previously, like I follow your talk, you also mentioned that the HIIT also is good when we are wishing to have a fat loss. And now we know that the resistant exercise training also good for the bone marrow loss. And that is first question. Second question is about the protein intake after exercise. I read some reference told even ACSM recommendation. They recommend us to not drinking water with calorie. I mean, like the beverage, sport beverage, if we do less than 60 minutes exercise. So meanwhile, you told us that the best sport beverage is contain 50% of protein and 50% of carbohydrate. So yeah, what is the best based on your advice, Lause?
Okay, that is very good question. Obviously, you already understand the content. Okay, so I'm take this opportunity to ask the question about the sports for all. I think this is very good concept. I'm glad that Artie bring this up. Okay, most of the people care about whether we can live for a long time to experience our life, right? And in order to experience our life for the longest time, we also need health, right? Okay, and that is the reason we need to have the exercise. And because now you understand that the exercise is able to eliminate the unhealthy cell, the senescent cell in your body, and that will make you younger, right? And now you know that we have two types of exercise. One is aerobic exercise, and another one is resistance exercise. Okay, and you have seen the evidence that the resistance exercise is going to eliminate the unhealthy cell, the senescent cell in the muscle tissues. But you want to keep in mind that resistance exercise does not challenge your lung. Okay, so if you look at the lung, then the most of the bone marrow cell is actually consumed by lung. Okay, so if you renew your muscle, then the muscle get younger, muscle can grow bigger. But in order to challenge your pulmonary system, your lung, then you need to have aerobic exercise as well. Okay, so one of the reasons that aerobic exercise does not increase the muscle mass as good as the resistance exercise is because the aerobic exercise also challenge the lung tissues, and the lung is the major site to let me see. Lung is the major site for the bone marrow cell, and one of the reasons that the lung has consuming a lot of bone marrow cell is because we are breathing 24 hours, but we are not exercising 24 hours, right? So when we are breathing we are taking air 24 hours, then the lung got challenged all the time. So that's why pneumonia is very serious problem for human, right? So and also when the ventilation happen in your lung, that is going to challenge your lung further. And the lung, when lung got damaged, the immune cell will get into the lung, and then it will fix the problem in the lung. The lung will be renewed, but the muscle will not be as new as the resistance exercise. So the people start to find that the mixed exercise, aerobic exercise and resistance exercise. For example, Monday, Wednesday, and Friday, you can do aerobic exercise. And Tuesday, Thursday, you can do resistance exercise. Okay, and you also from here, you can see the best way to recruit the bone marrow cell into your circulation and home into your body is actually high intensity. So Adi has talked about the high intensity exercise. You can see this is the fundamental basis of that. You can see 70% work rate give you the increase of the bone marrow cells by aerobic exercise. And 30% bone marrow cell do not give you this kind of effect. So if you ask someone to walk and just mild running, it doesn't really help you to renew your lung and your muscle, right? And from here, you can also learn that if you want to have the bone marrow cell get into the circulation, you know, high intensity exercise give you more damage, right? And resistant exercise give you much more damage compared with the aerobic exercise. So you have this phenomena, the 80% 1 RM give you a lot of damage, and the bone marrow cell are throwing to your circulation up to 6 hours, right? So you see aerobic exercise increase and then disappear in 10 minutes, but resistant exercise cause high damage, increase for 6 hours and come back for long period. But the problem is if you have this kind of exercise, 80% exercise, you have longer period of inflammation to renew your muscle tissues. So you need to suffer pain. You need to enjoy pain for longer period. So that is something. So my suggestion is if you have a higher muscle damage, you definitely need to have the high protein. So Ali recommend 50% protein, 50% glucose. That is only under this condition. Very, very high challenge. For most of you, actually my recommendation is 20% of the protein is already enough. You want to make the carbohydrate as the majority. And the reason you want to have the high carbohydrate as the majority of your food component is because the carbohydrate can induce insulin secretion. Okay, if you induce insulin secretion, then you have an antibody effect. Ali knows this very well. He's the expert. So if you have the question, the rest of the question, I will leave you to Ali. Thank you.
Is it okay, Mr. Ali?
Yes, yes.
Yeah,
Ali, okay.
it's
Yeah.
good. So, but I
Good.
think I need your confirmation about the low intensity aerobic exercise. Because based on me and my colleague from UPM Malaysia discussion, she and me end up in the conclusion for the low intensity aerobic exercise is actually giving us a chance to especially the how to say that the peripheral blood vessel to be full by the blood. So I mean, addition with your answer from my questions that every type of exercise actually we do need to perform in a week, so we can get more and more beneficial effect from its own exercise. Am I right, Lasse?
Yes, this is true. If you compare high intensity aerobic exercise and low intensity aerobic exercise, they both has their advantage. Okay, and if you talk about the cell renewal and gaining the bone marrow cell, it's only high intensity work. Low intensity obviously doesn't work. If you look at the evidence, it's quite clear. Okay, but if you do low intensity aerobic exercise, the advantage is very safe. Okay, that is especially important for clinical patient. Okay, for clinical patient, if you just ask the question about the mortality, if you don't move, then the mortality is high. And if you are moving, then the mortality is lower, right? So I would say low intensity aerobic exercise, if you can do long enough, what I mean long enough is more than 1 hour. Okay, so low, moderate exercise, 70% VO2 max, you can do about 2 hours. Then you can accumulate enough damage to trigger the bone marrow cell renewal. But the drawback for the long duration, moderate level aerobic exercise is too boring. Okay, so one of my students, he is actually the director for rehabilitation program. He's the medical doctor, and now he's the director of the rehabilitation division. And he mentioned to me that he started to get patients from
maybe have a connection. Prof. Kuo?
Miss
Connection
Titin,
problem.
yeah, Miss Titin, I think our professor, he got a error in the connection,
Yes.
like connection problem. So yeah, probably we should wait.
Mhm.
I apologize because my computer ran out of power. So I just
Battery, yeah.
yeah, sorry. Okay, now it's good. Okay. So my student who are doing the rehabilitation for diabetes patient, and he found that two way of exercise. One is the patient sitting on the bicycle and exercise for 1 hour at low intensity, and some patient they are riding on the bicycle, and if you give the high resistance, the resistance got very high, then the patient can only exercise for a few seconds, then stop, and then rest for another 10 seconds, and then do it again, and then stop and do it again. And eventually he found that the later intermittent type is much easier for the patient to stay in the rehabilitation program. So if you have the long period of aerobic exercise, then 2 days, 3 days later, the patient is going to leave because it's too boring. So that is what happened in the clinical side. So I'm encouraging you can try out the high intensity intermittent exercise, even for those people who are very weak. Okay, they just do their best for a few seconds and then stop. No big deal, right? And then do it again for probably 30 times, 60 times, then you can go home. Okay. I need to leave in 5 minutes. Titin.
Okay.
Yeah, good to see you, Ali.
Oh, sir. Anyway, I think in this occasion, I would like to tell you that I am expecting.
Good. I hope if you go to Taiwan, don't worry about the living place. Okay?
Sure.
We have a living place for you, free.
Thank you.
Thank you, Professor Guo, for your time. And okay, here I have a recognition certificate from my dean. Thank you very much as speaker in the World Class Professor Program 2021. And hopefully you can come here after pandemic finished and can directly to teach my for student in sports science. Thank you, Prof. Ko. If you have any else activity, thank you very much. And see you next activity again. Bye-bye. And now we're going to next agenda is with the girl, still young, but she have so many publication and he got a ranking H index in Scopus 5 H index. Oh, that's that. And he is Dr. Siti Musliha Mat Rashid, PhD. So from University Pendidikan Sultan Idris. And here's the CV of her. So the institution is from Faculty of Sports Science and Coaching in UPSI. And the education background, PhD in Sports Science, University Sultan Zainal Abidin, 2019. So we are same, already finished at 2019. And her recognition service is Sports Science level 1 and level 2. Best Paper Award in Statistics 2013, also Best Paper Award in Sports Science 2017, Best Innovation Award 2017, and Best Research Group Award 2017 too. And her research specialization is about talent identification on sport. Dr. Siti Musliha, are you here?
Yes, I'm here.
Okay, now the screen is yours. You can
Okay.
share directly in there.
All right. So I will present my slide. Can you hear me? Is it
Yes.
okay?
Yes. Okay.
Okay. All right. Thank you so much for your introduction, Associate Professor Dr. Sri Sumar Diningsih. All right. Okay. Selamat siang. Okay, Profesor Madya, Doktor, ibu-ibu, bapa-bapa, pelajar-pelajar yang dikasihi, semoga semua baik-baik ya. Alright, so okay. So my name is Siti Musliha and currently I'm senior lecturer in University Pendidikan Sultan Idris. Okay. I will share my slide, but maybe we can about less than 2 minutes. I want to know better everyone. So I put a link, a Padlet link in the chat box. So feel free to put your selfie picture in the Padlet. All right, and put some detail on you so we can know better lah. Okay. All right. So I will share my slide first. Wait. Okay. What's that? All right. Okay. See. Can everybody see my slide?
Yes.
All right, thank you. Wait, I have to. Okay. Okay. This is the title I choose for program today. Writing articles related to sports science for international journal. Okay. If anything you didn't hear me, you can see me or any lagging, just interrupt me and tell me, okay? Okay. Okay, the content today, we have a guideline in writing a scientific paper, and we share a little bit about how to transform a completed study into a journal and article. And then we focus on quantitative study. Okay, currently I'm more get involved in quantitative study, and let me ingatkan, okay, there is no one correct method for writing a scientific paper, okay, but there are some general guidelines. Okay, I didn't say that what I mentioned after this, that is the only way. There may be a few ways, but this is just to share what we can do, and hopefully everybody can get some output from the sharing today. Okay, is it okay? I use bahasa Malaysia, bahasa Indonesia, and bahasa
No
Inggeris.
problem, don't worry.
Yeah, serumpun, right?
Yeah.
Okay.
So you can use Japanese.
Okay. So this is a few what an editor says when they review paper, especially in international journal. Okay, sometimes the submission of paper which are clearly out of scope, there is a very, very big mistake. Okay, we must make sure that one journal that we choose, there are scope, okay, the scope of the study that we must fulfill. Okay, we must fulfill. That is the rule number one. Okay, let's say that one journal, they focus on the psychology. So your article, you want to submit, make sure it under the scope. Okay, if you go through with this something like out of the scope, nutrition or physiology, there's something like out of the scope, that is the main reason your article will be rejected. Okay, without further ado, okay, they don't need to read anything about your full article. They can reject it. It's like that. Okay. Failure to format the paper according to guide for authors. Okay, make sure every website journal that you explore, there are guide for authors. Okay, I never saw a journal without guide for authors. Okay, if one student come and tell you, doctor, there is no guide for authors, then something wrong with the student. Okay, all right. Inappropriate or not suggested reviews sometimes. Okay, the journal requests a few reviewers from you. Make sure the reviewers is appropriate for your study. All right. Either you want to choose your friend or your somebody you know, it's okay, as long as that person is appropriate with your study. Okay. Inadequate response to reviewers. This is the difficult part, to attract the reviewers. It's a very challenging, but you can do it. All right. Inaccurate standard of English, that is a common problem we face. Okay, me also, I'm not good in English. However, we try to find someone who can help us. It's very helpful. Okay, and make sure the editor is come from obviously they very fluent, very good in English. So you cannot simply okay, ambil mudah lah dengan English punya grammar. Basically, kalau yang basic grammar tu, you can use Google Translate. It's not 100% the best, but sometimes it's helpful. So why not just get some help from Google Translate? Okay, and then Resubmission of rejected manuscript without revision. Okay, I don't understand if you have been get back your article and you are advised to do the revision, and then you say that no need lah, no need revision, but you resubmit, and then you will be rejected. Okay, if you don't want to revise following their what they already comment, so don't need to submit lah. Okay, don't waste your time. It's simple like that. Okay, make sure you revise, approve, improve your article, and then you resubmit. Okay, after that, if they want to reject also, it's okay lah. Find the other journal. It's just okay. That is the experience. I think everybody, lecturer, professor, or Professor Mada, they face the experience of rejected. It's just okay. 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 If there are lecturer or professor who never been rejected, I would really like to know. Alright, question to answer before you write. Okay, this is before you writing the article. Okay, ask yourself. Okay, not others. Ask yourself: is it new and interesting? Is it hot topic? Is it provided solution? And are you ready to publish at this point? Okay, let's say you just finished the color data collection. Okay, 1,000 respondent, and then you think about writing article. No need lah. Okay, you have to do the many process. Okay, analyze the data, got the result, discuss the finding, got the overview of the study. Then you can say, yes, I'm ready to writing the article. Okay, make sure that. All right, ask yourself. Okay, the process of article writing, I can say it is just like a perlombaan kereta. When you successfully submit, it's not accepted or it's not published, but if you success to submit, you feel like, wow, I was successful. Even after that you got many comment, it's okay lah. Oh, it's okay. But to submit also is one of the best achievement in your life. Okay, and you must also have the deadline. Okay, make sure you have deadline. Don't say that article writing is a hobby. It's not a hobby that when you have time, you will write. When then you stop, and then when you have time, you continue. No. Okay. Okay. Make a timeline. Okay, you have satu target. Okay, satu target. 1 year. Okay, you will have 2 paper. So when you finish the 2 paper, okay, if you plan to submit this year, you have to ready the paper at yearly of the year, because it will take some time to resubmit maybe, and then to publish. So during the timeline, you have the guide when you will do finish your article. Okay, don't make it as a hobby. Okay, outline of academic article. This is the basic content in your article writing. Dia macam syarat sah dia lah kan, nak submit ni. Kalau nikah tu ada syarat sah dia, this is the syarat sah untuk submit article. If you don't fulfill one of the requirement, you don't need to submit lah. Okay, you know already you will be rejected. So make sure you have all the requirement. You have the title, you have the abstract, introduction, material, result, discussion, conclusion, and the references. That are the perkara wajib lah, okay, dalam artikel jurnal. Okay, let's start writing article. Okay, sekarang kita baru nak mula menulis ni. Before you start, the first thing you have in your mind is don't panic. Okay, once you have the due date from the TDPI, okay, next week we will collect the data and please submit all the article. Or don't panic. Okay, you have the timeline, so please be aware. Okay, mental condition is a very important to writing the thesis. Okay, tell your husband, okay, I will not cook for this way. Okay, I takkan masak. Okay, minggu ni because I will write a thesis, a paper. Okay, don't disturb me. So that one if you're married. Okay, if you're single, I can help you more. All right. So we go through for the title first. Title. Okay, this is an opportunity to attract the reader's attention. This is the first thing reviewer will read. Your title. Your title, it must attract your the editor. Okay, so it's very crucial part. It's a short form, but it's a very important. Okay, keep it informative and concise. Avoid technical jargon and abbreviation. Okay, technical jargon just like you use some word that kalau orang yang bukan bidang kan, orang bukan bidang baca dan dia tak faham. Okay, walaupun the editor adalah orang sport science, okay, we talk about sport science, and try to choose word that not only orang sport science faham. Okay, make it general. Okay, kalau kita tunjuk dekat adik yang sekolah menengah pun dia faham, walaupun dia tak pernah belajar benda tu. Just something like that. Don't do, and please avoid use the abbreviation also. Okay, singkatan-singkatan tu, it's not allowed in the article journal. Right. Around 15 to 20 words, but it also depends on the article. Sometimes it can be 11, less than 11, sometimes less than 14. So refer to the guide for author in the journal you will publish. Okay. For the first draft, I advise you to put in less than 15, and 20 also sometimes is quite banyak lah. Okay. So that bila dah dapat tahu jurnal yang kita nak hantar tu, tiba-tiba nak kurangkan kan, jadi pening juga kan. So make it careful. Catch the reader attention, all main variables are stated. Okay, if your article writing, you will include variables such as fitness and psychology maybe. Okay, fitness and psychology, so mention the variable in your title, so that editor will get the overview of your study. Okay, that's very helpful, and that's actually the one that you should put in the title. Okay, if you use body weight, standing broad jump, C&R, vertical jump, so no need lah to put everything in the title. Just put it as a big variable. Okay, fitness and psychology. So under psychology, there are factors you will study. That's it. And try to avoid the location of the study as well. Okay, let's say you put at Sekolah Kebangsaan Proton City, Perak. So no need lah. Okay, just put it the effectiveness of sport massage to prevent injury among children. Okay, that will already story all about your article. It's already to make it so editor will look at it more professional. Gitu. Alright, abstract. Okay, after the title, we have the, of course, author's name and affiliate. I'm not focus on that. Okay, after the title, we have the abstract. Should stand alone means you cannot simply okay campur abstract and intro. Abstract must be stand alone. Okay, dia tak kawan dengan siapa-siapa, dia adalah dia. So make it stand alone. Okay, consider it the advertisement. Okay, itu adalah cara kita mengiklankan keseluruhan, the whole story of our article. Okay, bila orang baca kita punya abstract, dia boleh nampak A to Z what we do from intro until conclusion. Be aware of that. Okay, must be accurate and specific, clear abstract. that is the very first also editor will read. So if they don't understand what your abstract actually, kita takut kan hari tu dia macam kemurungan, and then tanpa membaca sepenuhnya your article, then dia akan reject. Okay, and because the editor is a human, okay, human yang ada hati, ada perasaan, yang mentalnya kita kena jaga, and then kita kena be careful about that. Okay, jangan sampai abstract je and then the rest dia dah tak baca, sayanglah kan. Okay, follow words limitation 200 ke 250. Untuk first try, cuba jadikan dia antara 200 ke 250. Sometimes bila kita dah buat sampai 500 kan, 500 tiba-tiba jurnal yang kita nak hantar tu dia nak 250. Sakitnya nak kurang kali 250 perkataan tu. Tuhan je yang tahu. Okay, so make it biasanya 250 word. At least kalau kena kurangkan 10-20 word tu tak adalah sakit sangat kan. Okay, this is apa yang kena ada lah dalam abstract tu. The whole story daripada intro dia punya problem, daripada problem tu apa kita punya aims kan, di study aim nak buat apa, kemudian metodologi, dalam tu lah nak cerita partisipan, dalam tu lah nak cerita dia punya instrumen, dalam tu lah nak cerita dia punya data analisisnya, kemudian resultnya dan conclusionnya. Sangat mencabarlah abstract ni kan. Kalau kita convert daripada thesis tu, kan apa yang kita buat dalam 200 ke 300 page tu, kita nak convert kepada 250 word tu, sangatlah mencabar. Alright, but it's okay. Bukan tak boleh, boleh. Okay. Introduction. Okay, lepas abstract kita akan ada intro, draw audience in. Okay, audience lah. Kita kena tahulah siapa kita punya audience tu. Okay, cikgu ke ataupun athlete. So make clear about that. Okay, when we writing the introduction, we must make sure it was under the scope. Jangan melalu-lalu benda yang tak sepatutnya semata-mata untuk panjangkan kita punya intro. Itu cara yang salah lah. Okay. Okay, flow and content. Okay, flow and content yang ni dia punya general yang kena ada dalam introduction. Okay, ada general introduction, ada definition untuk main variable. Okay, dalam satu kajian tu kalau dalam sport science kita ada banyak variable kan. Tactical, technical, fitness, physiology, psikologi, banyaklah, nutritionnya dengan healthnya kan. So kita fokuskan kepada variable yang kita dalam kajian sahaja. Dia bukan macam thesis, okay, dissertation tu kan, dissertation kita cerita semua benda and then kita narrow down kan. That's why kita satu cabaran lah kan, kalau dalam intro thesis kita tu 10 page, nak convert kepada 1 page, itu satu cabaran yang besar. So you should know what you have to put in your introduction. And the review of related studies, okay. Kalau dalam thesis tu, your literature review. Okay, the literature review tu kalau sampai 100 page, okay, nak convertkan dia kepada intro yang sedikit tu, sangatlah mencabar. So janganlah copy paste daripada thesis tu masuk ke artikel journal. That is not the appropriate way you do. Okay, you have to synthesize your literature review and then put it in the short, in the summary form. That's the process. And then you must put the problem statement, purpose of the study and the hypothesis. That will be the paragraph yang terakhir lah. Okay, when you mention, okay, based on the problem statement, we came up with this study and then this study aims to what, and then to answer the question and then full stop. Okay, don't describe anymore anything about your study after that paragraph. Okay, that's for introduction. Okay. Okay, let me focus on the literature review that you have to put in the introduction. Okay, use related one that can be cited in the discussion section later. Okay, you must understand that the previous study that you put in the introduction, will be used in the discussion part. Okay, so make sure what you put in the introduction, it will support or contradict with your finding in the discussion. So not all the citation you will use. Okay, review the studies succinctly, make it simple. Kalau tanya macam mana tu nak buat simple tu, okay, dia kena banyak baca. Okay, kena banyak baca lah kan, and then try to list down first what the article finding actually. Okay, kalau kita belajar kan nak buat table, letakkan nama author dia, letak variable dia apa, finding dia apa, and then kalau ada recommendation, and then daripada table tu kita boleh summarize kan. Avoid Johnson and Bell 2018 stated that that is common way in Malaysia. I don't know Indonesia. Okay, that is the most popular statement to people, student we use, not student, me also before. Alright, so please avoid the sermon. Okay, make it more synthesize your review article, make it simple. Okay, you can kumpulkan dulu mana finding yang hampir sama, okay, letakkan satu group. Okay, ke mana finding yang 2-3 artikel yang finding dia sama, and then daripada situ kita boleh synthesize. Okay, direct to the point. Yes, of course, direct to the point. Kalau kita melalut memang dia akan jadi panjang dan jumpalah benda-benda yang tak sepatutnya. So direct to the point, what actually you want to story. Okay, describe the limitation, how they were improved by the subsequent study. Alright, this is the way to how we found the gap. Okay, let's say you read one article A, okay, based on the finding, for example, athlete performance in soccer. Okay, athlete performance in soccer. Okay, author A said that, okay, fitness and psychology is the most significant variable to enhance the soccer player. Right. Article author B said that tactical. Okay, in his finding, he said that tactical is the most important variable to enhance soccer performance. Okay, in author C said that nutrition is the best, is the most important variable to enhance soccer performance. And author D said that psychology is the first main thing we must consider to enhance the soccer player performance. From there, when we synthesize the literature, we can see the gap there. Okay, one say like this, and then we put something like, okay, we from all the previous study, we will use, okay, fitness and psychology for our study. Okay, or we combine fitness and tactical in our study. So mention what you do, continue, bersambungan. Okay, berterusan daripada gap ke atas tu, and then kita kata from all the review, we came out with this study. And then review, discuss the limitation of related study, ceritakan juga limitasi dia, and synthesize the finding. Synthesize the finding is a crucial process, but it's something that we must do to submit an article. Okay, and then after introduction, we will talk about methodology. Okay, methodology, the section you must include. Okay, the subsection, participant, material or instrument, procedure, and data analysis. Okay, you cannot skip any of them. If someone, if your student maybe come, doctor, my study don't have instrument, doctor. No, you cannot say that. How come your study don't have instrument? How come you measure your variable? So make them understand. You must have the instrument, you must have the material. Okay. We will go through one by one after this. So what we have to take note here, okay, should include subheading. Okay. If 2.1 methodology, then 2.1 participant, 2.2 material and instrument, 2.3 procedure, 2.4 is data analysis. Okay, but it depends on the format for certain journal. Maybe they have their ways, so just follow them. But for draft your article first, okay, I suggest you to put as a subheading. It's very helpful to see how was your progress in writing. Okay, and then write clearly. Of course, must write clearly enough to be understood by non-technical reader. Okay, don't expect that the editor is an expert, is a very memang dalam bidang tu. Bayangkan, okay? Bayangkan penulisan kita tu adalah untuk adik kita faham. Something like that. Don't try to use a bombastic word that akhirnya semua orang tak faham. It's a very dangerous. Okay. Simple English is also, it's just okay. As long as people understand. It's just okay. Okay. Past tense, of course, it must be past tense. If you use present tense, you will be simply rejected. Okay, it's a very basic. If you use present tense, ask yourself, how come you get the result even if you didn't make it first? Of course, it's a past tense. It's a very simple basic grammar. I hope everybody can aware about this. Okay. Readers, future researchers should be able to replicate. Okay, one of the characteristics that study you want to publish, you want to submit for publication. Make sure what you are going to share with people can replicate it. People can follow again what you publish. Make sure of that. Okay, ask yourself. Okay, ask your supervisor and ask all your co-authors. All right. Provide clear instruction from start to finish. Okay. Of course, there is a flow. Make it clear about the instruction from start to finish. Okay. Now, okay, we go to participant. You must write who, where, and how were they selected. It's a very important. If your sample you use athlete soccer, okay, soccer player, okay, berapa umur dia? Okay, macam mana pilih dia? Kita tak pilih satu Indonesia, kita pilih satu negeri saja. Okay, mention that if you have the reason yang tertentu kena tertanya-tanya, okay, tertanya-tanya siapa ni, who is really the participant. Okay, tell them male or female. That is a very basic thing that you must tell in your writing. Okay, basic demographic, gender and age. Of course, don't make the auditor ask himself, is it male or female? Just put it clearly. Male soccer player, age 21. Okay, mean and standard deviation. Commonly biasanya lah untuk umur ni kita akan bagi tahulah mean dengan standard deviation umur tu. Bila range umur tu, contohnya kalau kita pakai atlet bola sepak yang berumur 17 ke 21 tahun, okay, mean umur berapa and then standard deviation berapa. Okay, so daripada situ editor boleh imagine lah, okay, the sample is from, okay, let's say the mean adalah 19.5 plus minus 2.5 years. Okay, so editor can imagine your sample is about 17 until 21 years old, something like that. So you give a yearly picture on what your sample actually. Okay, insert institutions ethical approval here. If you use sample human sample, so of course we have the ethical approval, so put it here. Okay, don't put the surat kelulusan just put the number of the surat kelulusan. Okay, then material. Okay, describe all the materials to collect the data. Okay, questionnaire. Sometimes maybe we use a questionnaire, especially when we involve psychology component. Okay, we want to measure the stress, maybe we want to measure the motivation, maybe. Okay, we need the questionnaire. Questionnaire also is a instrument. Cite the source of reference. Okay, questionnaire is an instrument yang ada tuan dia. Dia ada owner dia. Once kita pinjam barang orang kan. Pandai-pandailah cite tuan dia, takkan nak pinjam saja kan. Please make sure you cite the owner of the questionnaire unless you develop the questionnaire by your own self. Okay, but study membangunkan soal sidik tu bukan benda yang mudah lah. So biasanya kita pakai instrumen yang dah sedia ada and then kita just adapt daripada questionnaire tu. So make sure you cite the owner of the questionnaire lah. Don't forget the owner, nanti owner tu marah. Apparatus, physical tools. Okay, kalau melibatkan kajian lapangan, akan ada berat tinggi dan sebagainya. Okay, tools tu mungkin kita pakai standing, weighting scale, kita pakai sediometer maybe, kita pakai vertex, kita pakai C-enrich box. So just mention the apparatus in your methodology. Don't make the editor terfikir-fikir kan, apalah alat yang dia pakai ni. So ceritakan dekat situ Okay, only special apparatus for measurement cite the source of reference. Okay, better is sangat-sangat bagus bila kita boleh citekan jenis instrumen tu, sebab banyak-banyak instrumen dekat dunia ni dan yang mana satu kita pakai, kita bagi tahulah. Okay, ada example dekat situ. Kalau sediometer, letak kada kurungan Seca model 217 Hamburg, Germany. It's a very good, you put it in your writing, article writing. Okay, next procedure. Okay, how was the study conducted? Macam mana pengumpulan data tu berlaku? Okay, kita minta kelulusan siapa dulu, and then kita buatkan pengukuran anthropometric dulu, and then barulah kita mula dengan fitness test. That's the step-by-step procedure we have to mention to tell the editor. Okay, bayangkan editor tu zero knowledge about the procedure. Don't expect that the editor know. Even they know, but you just imagine that they don't know anything about your research. Manner of data collected. Okay, data statistical. Okay, you must have the data analysis. Okay, depend on your objective that you mentioned before. Okay, let's say you say that this study aims to differentiate athlete performance between soccer and rugby player. So what analysis you will do? T-test. So put there, the data analysis you use is t-test. Okay, let's say your objective is to investigate the correlation between body composition and cardiovascular. So what a data analysis you will use? If you say ANOVA, then it will simply wrong, okay? Okay, ANOVA didn't give you the correlation between two variables. If you say the objective is to find out the correlation, so the data analysis you will use is correlation test. Okay, if you want to, your objective to compare the fitness performance among school A, B, and C, what we will use? Data analysis we will use. So you said ANOVA. So tell the ANOVA there. Okay, and then you can tell also the software you use. Okay, commonly we use SPSS, there are XLStat, Minitab, many tools in the world. You can choose one. That one yang mana kita paling familiar, and just use it. It doesn't wrong. Don't say that SPSS is more accurate than Minitab. No. Okay, it's just a tool. Okay, either you use SLStat, you use SPSS, you will get the same answer. Okay, if you found out using SPSS is significant, then using Minitab also you will find out the significant. Okay? The difference may be 0.00001. Of course, we are not perfect, so there is simply error there, but it still gives the same answer. Don't worry. Okay, data in the text, figure and table are presented as mean and standard deviation. That paling malas lah kan nak letak kan. Paling-paling tu pun dia punya deskriptif tu letaklah mean dan standard deviation. Nanti kita akan tengok Alright. Result. Okay, after the methodology, kita dah cerita semua tu. And then data dah ada, kita akan masukkan result. Okay. Organize around table, figure. Present tabular results selectively in tab, wording must be in past tense. Make sure it's past tense. It's very simple. If you ignore that, the editor will get angry and they will reject your article. Okay, no interpretation, just the facts. Okay, result is the result only, not discussion. Okay, discussion tu dekat section yang after that, after this. Result is the result. What you found out from the result, you have to put it in the result section. Just story about your result only. Tell the table, the figure, just it. Okay, table should stand on their own. Okay, jangan nak campur-campur table. Okay, report descriptive stats first, then inferential stats. Okay, maksudnya kita akan masukkan descriptive dulu. Okay, basically mean and standard deviation. Okay, walaupun dia tak ada dalam objektif kajian kita, biasanya kita akan masukkan deskriptif dulu. Katakanlah kalau paper tu okay, investigate the correlation between body composition and cardiovascular among athlete soccer. Alright, so firstly kita akan letakkan dulu deskriptif body composition dengan cardiovascular athlete soccer dalam satu table, then put in the result first, and then we go to the inferential yang kita buat t-test ke correlation ke ANOVA lepas tu kan, ataupun kita buat yang advanced sikit, buat cluster analysis, discriminant analysis, principal component analysis, that one after that. So make sure descriptive first. This descriptive ni macam pengenalan data kita tu. Okay, sebelum nak berkenalan lebih rapat tu, kita kenal dulu dia punya mean dan standard deviation. Gitu. Okay, result 3 or 4 data sets per figure. Okay, make it clear, nampak cantik, nampak professional. Jangan banyak sangat. Unless memang diperlukan banyak, and then perlulah, tak banyak. Tapi kalau kita boleh adjust dia, 3 or 4 data per figure is good enough. Okay, color only when necessary. Okay, dia tak sama macam kita buat dissertation, macam thesis kan, kita nak colourful, kita nak banyak nampak kan. Tapi in academic writing, the less you use color is more better. Okay, personally I used to less the color. Sometimes we just try very hard to put this black and white only. Okay, color needs to be visible and distinguishable. Make sure the resolution is good enough. Jangan pecah-pecah. Benda-benda yang macam tu pun boleh menyebabkan artikel kita tu di reject. Okay, do not selectively adjust. Ada cara dia, ada cara dia untuk pastikan picture kita, graph kita tu cantik. So just find out the way how to make it better. Okay. Do not selectively adjust any image to enhance visualization of result. Okay, gambar tu kecil, tapi sebab nak tambahkan jadi banyak kan, banyak page, kita besar kan. Jadilah pecah-pecah macam tu. Tak bagus lah. Okay, try to find out the best way to impress the auditor. Okay, do not include long boring table. Of course, the editor is a human. Right, so I have a few example, maybe there another more example, just 2 or more example I put here, so that to explain about first to impress, okay, to impress the auditor. Okay, to impress the auditor. All right. So I mentioned about color just now. Okay, the first picture, first graph. Okay, we can see cantik lah kan, warna-warni kehidupan sangat. And then actually the color is not functional. Okay. Can you see that? Okay, without the color, you also can know that the first one is strongly disagree, neutral agree, and strongly agree. So jangan terlalu gigih untuk colorfulkan dia. Okay, alright. So you can put it as the second picture. It's just nice, it's just simple, but it tells the whole story about the picture. It's just okay, black and white. Is people can see it more professional. Okay, this is when you use questionnaire. Okay, questionnaire, you have the number of respondent to answer agree, disagree, and so on. So how to present your data? Just put it in black and white. Just okay. Okay. Okay, the previous example, there are only one male, so it's just okay. But in the case you use male and female, okay, you say that, okay, so I have to put it color. Okay, I can accept the reason, but you have another choice actually. You can use the pattern field in the Excel. Okay, there are many functions in the Excel table, Excel graph. It's a very function that you can use. Okay, make it simple but professional. Okay, all right. This is one of the way you can use to visualize your picture, your graph. Okay, sorry. Okay, your graph. Okay. So I prefer to use symbol like this. Okay, pattern field, and then you can put a star, something like you can differentiate. Okay, kalau dua-dua hitam sangat pun nanti tak nampak pula. So make it satu tu macam putih sikit, yang satu tu macam gelap sikit, so nampaklah beza kat situ kan. Lagi-lagi journal tu kalau yang jenis gambar dia kita kompres lagi kecil kan lagi tak nampak pula. Tapi gambar tu kita boleh besarkan. Macam-macam kita boleh adjust kat situ. Okay, nak cantikkan. Dia satu proses jugalah. Jangan main copy paste and then biar je macam tu. Okay. Alright. So another thing you have to consider also the tempat perpuluhan. Okay, tempat perpuluhan is a very very basic tapi kesan dia sangat besar. Okay, biasa tak kan kalau jumpa artikel jurnal, dia standardize sampai 3 tempat perpuluhan. Okay, you must understand that your result is come from your procedure. Okay, procedure dua ada instrument. Okay, let's say body weight. You kata dekat procedure tadi you pakai digital scale. Okay, pakai digital scale and you recorded the data to the nearest 0.01 kg. 2 tempat perpuluhan kan? Kalau yang pakai digital tu. So tapi bila buat result letak 3 perpuluhan means that you are more accurate than the instrument, okay? So it must follow your instrument. Okay? If you say that you use the penimbang berat yang lama sikit tu kan, yang ada 1 perpuluhan je tu, 0.1 kg, then make sure you just put 1 perpuluhan, it just okay. 12.1 kg. Like that. Okay, standing height you say that you use the stadiometer. Okay, stadiometer you recorded to the nearest 0.1 cm. Okay, 1 tempat perpuluhan. Tapi bila dekat result you put 3 perpuluhan. How come you simply make it? You cannot, okay? Alright. Just put 1 tempat perpuluhan lah. Okay, buanglah 000 tu. Dia akan jadi bundarkan lah. Sama kot Malaysia, Indonesia kita bundarkan dia ke yang paling hampir. Alright, standing long jump. Okay, standing long jump, kalau pakai standing broad jump mat tu kan, yang berat tu kan, Dia kan dalam kita rekod dia dalam integer. 10 cm, 20 cm, 30 cm. Dia tak ada 10.5 cm. Okay, tak ada Tak tahulah kalau study broadjump dekat Malaysia ni dia tak ada. Dia dalam centimeter je. Dia nombor integer. So make sure when you write the result, just nombor integer. Okay. Nombor integer. And then Hamilton. Okay, Hamilton ni adalah ujian baling dan tangkap. Okay, baling dan tangkap, kita rekod dia dalam bentuk integer lah. Okay, 5 balingan ataupun 6 balingan, 7 balingan. Dia tak ada 7.5 balingan, dia tak ada katakan dia 7 balingan separuh, dia tak ada macam tu. So Hamilton make it integer number. 20 meter run. Okay, kalau dalam prosedur tu kita kata kita pakai stopwatch. Okay, stopwatch and kita rekod kepada 0.01 second. Okay, 0.01 second. So make sure it was 2 tempat perpuluhan lah. So don't simply standardize everything in 3 tempat perpuluhan. It's not good. Okay. That's your editor can see how's your kefahaman tentang apa yang kajian yang kita buat. So be careful. I think it's a very basic thing that we must consider when we write the result. Okay. This one for result. And then the thing that you must avoid. Okay, in journal article, individual score and row score typically are not included. Okay, don't mention about one particular respondent in your article. Okay, siap sebut nama lagi kan, saudari ni. No need lah. Okay, no need. You just tell the result for all the population in your study. That's it. Okay. Don't cut and paste data from SPSS output. Okay, kalau di Malaysia ni famous sangat pakai SPSS. So tahu kan dia punya output tu macam mana, and the student simply, not student only, me also pernah melakukannya, and then kita buatkan dia lebih baik lah. Okay, alright. Just simply copy paste from the SPSS and put in your article. Okay, you must, kalau kata doktor macam mana doktor, dah dibagi dah PDF kan. So buatlah dalam Excel. Buat dalam Excel balik nak buat macam mana. Buat dalam Excel, okay, letaklah baru dah cantik dalam tu. Kita nak edit pun senang kan. Kita nak edit kan, nak kecilkan ke, nak besarkan word ke, nak center ke, nak justify ke, nak ke tepi ke tengah kan, semua senang. So itu pun proses, jangan skip lah. Tak ada jalan shortcut lah orang kata kan, shortcut kita nak publish ni. Don't present same data in both table or figure. Okay, janganlah letak figure lepas tu letak table kat bawah, figure lagi, table lagi. That's very unprofessional. So take note Okay, jangan buat macam tu. Don't discuss your result that is done in the discussion section, of course. Okay, discussion tu ada section dia sendiri. Result is result. Jangan letak satu table and then discuss, and then table lain result and discussion, result and discussion. Tak tahulah kalau ada journal yang macam tu, but most of the journal I found, basically we tell about the result first, and after that we talk about discussion. Untuk first drive kan tak tahu lagi nak submit ke journal mana, so make sure you susun macam tu lah. Okay, letakkan result dulu and then discussion kemudian. Jadi nanti bila nak masukkan ke template journal yang nak dihantar tu, tak adalah sakit kepala kan, nak pindah-pindah pula. Okay. Okay, discussion. It is the most important section of your article. Here you get the chance to sell your data. Yeah, the most important section and the most killer section. Okay, kalau kita ada team kan, satu team tu, kita leader and then ada co-author, and then co-author yang buat discussion tu, we know how suffer they are to make the discussion. So rajin-rajinlah bertanya kawan tu. Kalau buat discussion kan memang sakit, tapi kena buat juga. Okay, make the discussion corresponding to the result, but do not reiterate the result. No need lah to repeat your result anymore. Just discuss your finding. Okay, put everything what the previous study that you mentioned in the introduction, which sebab masa intro tu kita belum tak tahu result lagi. Kita just cerita secara general. Okay, bila masuk discussion, kita dah tahu result, and then kita kena bincangkan apa yang kontra, apa yang inline, apa yang support, apa yang berlawanan. Itu yang kita kena ceritakan dalam discussion. Okay? Do not ignore what in disagreement with yours. Janganlah cerita yang menyokong je. Kalau yang kontra sikit dengan kita terbuang. No need lah. You have to make it interesting, okay? Bila kita discuss apa yang support kita punya study, apa yang berlawanan dengan kita punya finding, it's very interesting. Janganlah buang, okay? Artikel yang kontradik dengan finding kita ni semua kita buang. Right? No need lah. Okay. Reminder, evidence pro and cons, strength limitation of your study, implication of finding. Okay, other finding of your study. Okay, that one I already explained before. That one you must understand why discussion. Okay. Kalau saya lah, kita pun dulu pernah jadi student kan, pernah tak tahu kan macam mana nak buat, tak tahulah discussion ni. Stress kan? Okay. Tapi it's a process. Kalau kita PhD, kita melalui proses tu, and the future kita kan mengajar orang lain pula. So make sure kita melalui proses tu dahulu. Walaupun sakit, it's just okay. Okay, conclusion. Okay, tell us how your work advance in the field from the present knowledge. Okay, conclusion dia tak panjang pun. Dia sikit je, satu paragraf pendek je. Tapi janganlah ambil sebiji dalam abstract kita tu letak dekat conclusion. Itu nampak sangat tak professional. So, tapi jangan pula kita ulang balik yang result kita tu. Make sure dalam conclusion tu kita menjawab research question dalam kita punya intro tadi. Okay? Kalau kita research question tu adakah terdapat perbezaan yang signifikan antara prestasi atlet soccer dan rugby? This question. Yeah, there is a significant difference between rugby player and soccer player. Okay, there are this one. And letakkanlah dia punya implication tu. Masukkan sikit dia punya implication, tapi tak perlu kita discuss panjang-panjang dah, kita dah cerita banyak dah kat atas tu. Conclusion is just a simple conclusion. You have to understand. Janganlah conclusion tu sampai 1 page. No need lah, okay? Alright. Without clear conclusion, reader will find it difficult to judge the work. Okay, of course lah. Okay, atas tu cerita benda lain, and then last conclusion dia benda lain, and then editor pun reject. Okay, alright. So make it flow tu cantik lah kan, daripada intro, objektif kita macam ni. Jangan intro tu cerita masalah lain, masalah taktikal. Tapi variabelnya psikologi, tiba-tiba conclusionnya fitness. Apa ni kan? So hati-hati. Kita baca, kita tuan punya paper tu, kita faham lah. Kadang-kadang kita faham kan, kita salah tapi malah nak baiki kan. So jangan submit lah kalau macam tu. Okay? Alright. So reference. Okay, cite the main scientific publication on which your work is based. Reference ni sangatlah mencabar jugalah. Okay, sangat mencabar. Dia ada banyak format kan, APA lah, Chicago lah, Harvard lah, apa benda tu kan. So make sure you pastikan apa jenis reference yang kita nak pakai. Jangan main letak je APA, semua APA kan, boleh copy daripada Google Scholar tu. Senang kerja. No, okay. In reality, more mistake are found in the references than any other part of the manuscript. Okay, ada banyak lah cerita-cerita yang paper-paper yang direject disebabkan oleh reference. Tak ada possible lah, janganlah kata alah editor tak tengok pun reference. No, dia akan check daripada A to Z. Okay, kalau format pun tak betul, lagilah Lepas tu apa yang reference site dekat atas tak ada dekat reference, reference yang ada dekat bawah tak ada dekat citation atas, lagilah dia bengang kan. Nak marah sangat, reject terus. Bukan suruh revise, reject terus. Tak boleh lah. So technical ni kita make sure dia perfect lah. Orang kata it is one of the most annoying problem and causes great headache among editors. Kalau saya pun dalam team tu kan, 5-6 orang buat paper, reference ni saya bagi orang lain. Okay, buatlah ni. Sorry to say lah. Memang kita kadang-kadang pun malas kan. Okay, kita cari mangsa-mangsa kita. Okay, saya dah buat ni, kamu buat yang ni. So itulah kegunaan co-author. Alright, references, and I think I finished already. Okay, 5 minutes more to 12. Okay, I targeted to finish about 1 hour, and then we open for some question and answer. If any question, don't forget my Padlet, please put your picture, show your introduction. Okay, sambil-sambil tadi kan ada sembang-sembang tadi, sebab yang dekat kamera pun bukan ramai pun kan. So hopefully I can see all the face who I saw today. So any question I open, boleh tanya. Ada soalan tak?
Wow, very interesting topic, Kak. So this is very important for students to writing manuscript to publish. And please, if any question, you can raise your hand to directly asking to Dr. Siti Musliha. So I call you Miss or Mrs.
Oh, Mrs. Okay. Kak saja, it's just okay. So I'm not. I contact with Titin. Titin call me Kak. Kak, it's okay. Just call me Kakak.
Okay, Kak. Kak Siti.
Okay.
Kak Siti.
Kak Siti. Okay.
Yang jadi permasalahan soal.
Boleh.
Where is the student?
Okay, ada soalan?
Yeah. I got so many rejected for 2 years.
Okay.
I mean, I have experience for writing paper. So first is have revision major, and then I revise again. For 2 years, I follow that comment from reviewer. But after that, the editor said to reject my paper. I already follow for the comment of reviewer. So what should I do?
Okay, can I know when the reason why they rejected the is it they bagi tahu apa dia punya reason kenapa di reject? Ada tak dia bagi tahu berkenaan tu? Kenapa?
Tak kasih tahu, hanya following following that comment from reviewer first, that I just make a simple statistic, use party test, and then the reviewer want to weigh ANOVA to do that, and then I do the two-way ANOVA, and then the reviewer say one ANCOVA. Okay.
Oh, I see.
Yeah, it's about the statistic issue, and I already following that reviewer said. But the last for 2 years, I'm following that one, then rejected. And my professor, oh really? We got rejected? Just,
yeah, it's like separuh nyawaku pergi.
Yeah, oh my God. To spend just for one paper writing.
Okay.
So what should I do for that one?
Okay. Because if the problem of statistic, because you already finished with the ANOVA, so if I'm one of the review, so maybe we suggest you to revise again your objective, okay, your body of the content. We will not advise you to change the statistic, but in this case, the reviewer advise you to change into ANCOVA, then we have to follow. Okay. Once you already follow what they want and you submit, and then they rejected without any concrete reason.
Yeah, any confirmation.
So then we take it as yelah, dengan macam klise kan, tapi redha and pasrah. Because I'm not sure why, because they didn't put the sebab dia kenapa. Tapi muka barangkaliannya mungkinlah saya rasa menarik juga kan masalah ni. Kalau kata masalah dia out of the scope, awal-awal lagi tu dia dah reject lah kan.
Ya,
Kan,
betul.
kan kalau out of the scope.
Buang.
Tapi kalau masalah grammar biasanya dia akan bagi kita masa lah untuk kita proofread kan.
Yes.
So dia akan advise kita untuk proofread. In this case, I'm not sure. And we also don't know. Sometimes the same editor or another editor was yang baca kita punya artikel tu. Okay, maybe kalau editor yang berlainan mungkin yang t-test tu dah betul, tapi bila Alcover tu dia salah kan, tiba dia reject. Kan? So I'm not sure why, but I think you already have the comment. Okay, you have the comment, then you can improve from the comment and then submit to another journal which more suitable. I understand it's a long process. It's about 2 years, right? Oh, it's 2 years. Okay, 2 tahun kan nak menanti, akhirnya reject, memang sakit lah. Okay.
Sakitnya tak berdarah.
So kita harapkan paper tu bertambah baik. Okay, bertambah baik dan di publish pun dalam condition yang A level lah kita kan, yang sangat-sangat bagus lah. So saya percaya paper tu dah banyak penambahbaikan. So kita harap dia publish lah. Kita mampu berdoa sahaja. InsyaAllah.
Yeah, already published now, but in national, in Taiwan National, in Journal of Physiology. Yeah.
That's
And
good.
thank you, Dr. Siti. And this is if any question from Dr. Asep about how many minimal reference can be allowed for our journal, for the journal, international journal. How many minimum reference? Yes.
Okay. Most of the journal they didn't put secara rigid lah. Okay, satu artikel tu kena 20 artikel, 30 artikel, okay. Tapi based on kalau my experience, okay, actually kita dengan team satu member ni, we try to make it 30. Okay, 30 reference. Itu kita kata tak sikit sangat, tak banyak sangat. So make it 30, almost 30 reference. Kita kata itu adalah safe lah. Okay, safe kan. Kalau kata 10 tu sikit lah sangat kan. Tengok-tengok ada 10 je nak publish. Itu kan effect juga dia punya auditor. So my answer, I would advise you to put it about 30. Tapi kalau dia kata nak, saya rasa 30 tu dah banyak lah. Okay, dah banyak. Okay, any other question maybe?
So for student, you can raise your hand and ask him directly. This is Professor Aziz Hakim from UNESA, Surabaya. So UNES is in the Central Java and UNESA is in the East Java. And for 6 hours from here. Okay. So he asking about the topic. So what is the interesting topic for accepted in the international journal?
All right. So usually we can see the topic in the archive. Okay, we have the journal that we want to publish. Okay, we see the title, and I think this title is our study is under the scope of the title. Okay, usually we will see the archive. We can see the title that has been published. And sometimes, okay, kita kadang-kadang kita dah siap dah paper ni, kan? Kita dah siap paper, barulah kita nak publish. Okay, usually kita boleh carikan keyword kita punya artikel tu dekat Google Scholar ke dekat Scopus, kita tengok bila yang publication tu ada untuk 20, 21 macam tu kan. Itu satu way lah. Okay, kalau kita buat dulu. Okay, kalau kita dah siap artikel, kemudian baru nak publish. Okay, and then daripada situ kita jumpalah jurnal-jurnal yang bersesuaian, yang latest, yang ada berkaitan dengan kita punya study. Okay, tapi kalau kita mula dengan kita nak cari dulu topik yang menarik, I suggest you, okay, cari jurnal-jurnal yang high impact lah. Okay, kalau sport science ni Journal of Sport Science, cuba tengok dia punya publication 20, 21, 2020. Okay, kalau nak tanya saya spesifik tajuk yang menarik, dia banyak lah kan, banyak. Cuma kita boleh pelbagaikan, kita boleh okay. Okay, can we stop for just now?
Okay.
Okay, it's already Zuhur in Malaysia.
Oh,
Okay.
here also. Okay.
Okay.
Kan sekarang baru orang yang dengan gejala, katanya yang terkait COVID itu diumumkan.
Okay.
Okay, I continue. Alright. So in these cases, we want to find out the interesting topic. Okay, based on our pembacaan lah, kita banyak melihat kepada artikel 2021 tahun 2021 2020. Kalau kajian kita more to physical activity, so maybe the physical activity currently more people more investigate on elderly maybe, and also orang yang kurang upaya, something like that, or selain daripada atlet kan, selalu kita sport science ni atlet. So there are more population that we can explore more. Okay, interesting topic. Okay, I think that's harap menjawab lah soalan tadi. Okay.
Okay. Okay. Is it okay, Professor Aziz?
Professor Aziz, where
Yeah.
are you?
Here is at Papua right now.
Terima kasih, Prof. Terima kasih. Maaf, di sini berisik.
Okay. And then this have one more question from Mr. Suyatno.
Okay.
Mr. Suyatno, you raise hand. Maybe you can open your mouth.
Yeah, Mr.
Ask-
Suyat.
Unmute, yeah. Oh,
Hmm.
okay. So, and then this have one more question from Kusuma Ai. Ai itu kayak kakak ya. Ai kakak
Okay.
untuk perempuan.
I see.
Bule. How to say bule in Malaysia?
Bullet, not sure.
Bule is your. Oh, okay, no problem. I don't know how to say in
Okay.
Malaysia.
Alright.
Okay, bule. So she asking about how to know the target journal. So when to want to submit in the Q1, Q2, or Q3 or Q4, how we make decision, which of our manuscript this is okay for that journal.
Okay. Okay. The same question I asked my supervisor before. Okay. To know either your article journal is appropriate, suitable for Q1, Q2, or Q3. Okay. Firstly, based on your reading, okay, you can compare the Q1 article and your article. Is it suit to publish in Q1? And another thing, what I can do, I will refer to the expert. Okay, someone who more experience on that. We try to they will suggest us. Okay, because the experience, we don't have the experience, we have the expert. They know better. Okay, they know better. It doesn't mean that you have to first Q1 and then if you rejected, you come up with the Q2 and the Q3 and Q4. It's not a short process to wait for the comment or revision or something like that. So try to ask the expert what exactly the suitable one, journal that's suitable for your article. Okay, unless, okay, what we can do is we try to read the same journal from the article you want to publish. Okay, is it sweet or not? Okay, there are no syarat yang khas. Okay, kalau 10 page, okay, Q1. No, sometimes we can see the Q1 there are 2 or 3 pages also. So why it become like that? The expert know better. So we can know from there. But to submit Q1 first and then try Q2, Q3, I'm not galakkan lah kaedah tu. Tapi kalau bisa menunggu gitu, is okay, boleh mencuba ya. Kalau ada rezeki dapat Q1, mana tahu. Alright, harap menjawab soalan tadi. Ada lagi ke soalan?
Okay. In my experience also, so when I got rejected in the national, but I tried to Q2, but accepted.
Okay, you see?
So it depends on the topic and maybe the reviewer or the editor. This is the topic is suitable with the journal or not, or this is interesting with the journal or not. So if they're interesting, they will accept it.
Yeah, kan. We think that is good enough to publish in publication. But sometimes we say that it just biasa je kan artikel ni, tapi bila try submit ke QQ tu tiba-tiba dapat kan, lepas. It's
Yeah.
okay.
So just try to make it like as you want.
Yes.
Okay. Any else question? Mr. Henry Asmara, you want to ask question? Okay, and that's it. Mr. Suyatno, are you there? You raise your hand. Maybe you are asking something. Okay, so the problem is in my case of my student, here always forget to writing the methodology. I think it's important, the methodology. So the methodology only a short, maybe just half of page and no information about that, the procedure, instrument, just analysis is about that. So I think it's the problem. So what do you think about that? Okay, and here have anyone question about from Reza Aziz? Is there any application to improve the quality of writing?
Of course, there are many. Okay, there are many application, especially Mendeley. Okay, Mendeley is very helpful. Okay, once you have many article you read, but sometimes not all the article kita baca kan, kita just jumpa tu and then kita save, jumpa kita save. Mendeley tu membantu dari segi pengurusan citation tu dalam kita punya article writing, tapi nak meningkatkan kualitas penulisan tu okay dari segi bentuk dia tu yes lah. Okay, nak formatkan bentuk APA ke Chicago tu yes, dia membantu. Tapi software yang lain pun banyak macam Grammarly. Okay, Grammarly ni tapi dia berbayar kan, berbayar. Tapi kalau yang yelah, kita pun pernah jadi student kan, bukan ada duit sangat, pakailah yang free tu. But yang free tu pun yang basic grammar tu pun membantu. Membantu. Dan masalah kita lagi satu ni, kita nak paraphrase kan, nak copy paste tak boleh, nanti plagiat pula. So kita nak paraphrase pun ada dia punya app, software yang membantu. Yang saya pakai biasanya Instatext. Okay, Instatext itu pada saya yang the best lah setakat ni yang kita pakai. And then lastly kita akan hantar proofread lah. Okay, proofread tu kalau di opsi kita ada peruntukan untuk satu jurnal tu proofread untuk bayar proofread. So itu sangat membantu. Kita bukannya pure English kan, memang ada banyak problem kat situ. So proofread tu sangat membantu. Cuma dia berbayar. So kalau ada kawan-kawan yang TESOL ke English tu kita boleh minta tolong. And then bayarlah sikit kan. Itu sangat membantu. Okay, unless kita buat seorang-seorang, short sendiri kan, so akan banyaklah masalah kat situ kan. That's a few way lah untuk tingkatkan kualiti penerbitan kita. Okay, ada soalan lagi? Okay, any ID from audience? Kalau ada soalan.
Okay, hello?
Okay.
I'm sorry, this is a lot of... Okay, so Mr. Reza, is it okay?
Mr.
or student?
Student
From student?
from UNESA.
From UNESA. That's good. So
Reza.
degree or magister or doctor?
Okay. Reza ada soalan ke?
Reza sarjana
mahasiswa saya itu, Bu.
Ya, benar.
And here also have a Professor Ramdan Pelana from UNJ. Welcome, Professor Ramdan.
Kalau iya, DBON ini sepakati bersama,
Okay.
Apa nanti?
You want to asking something, Mr. Ramdan? Prof. Ramdan?
Yang kedua,
Okay. Okay. So, it's busy like a Mr. Like a Prof. Aziz. Okay, any else question? Oh, usually Professor Abdul Khalid asking something. Okay. The time is enough. No more question. Why? What happened? Okay, so wait, because also at the time, I would like to give some recognition from our dean, sports science faculty. Okay, so thank you very much for giving excellent presentation about how to writing article to publish international journal. And so this is our program, the class professor 2021, sports science research application at 7 October. Thank you, Dr. Siti Muslihamat Rashid, PhD, and greeting from Professor Dr. Tandio Rahayu, MPD. Thank you very much.
Alright, thank you also, Dr. Professor Madya, Dr. Sri Sumartinsi, and everyone. I'm so happy to be part of this program. Hopefully, we can see face to face maybe one day.
Yeah, Amin.
Okay. Nice to meet you, and mohon ampun juga kalau ada kekurangannya, kalau ada tersilap bahasa, tersilap terkasar bahasa. Okay. Alright, Assalamualaikum. See you.
Waalaikumsalam. Mungkin bisa kolaborasi.
InsyaAllah.
Yeah.
Okay. Alright.
Okay, thank you very much. Yeah.
Yes, saya live dulu ya.
Waalaikumsalam warahmatullahi. Thank you. And we will have breaking istirahat 15 menit, 10 menit ya, sebelum Dr. Roni Lesmana from Indonesia, Pajajaran, yang saat ini publikasinya sangat banyak dan high index-nya 9, 5 apa 9 ya? Nanti kan 9, sekitar 9, nanti silahkan. Kita tunggu jam 12.30 atau silahkan kalau ada yang mau sholat, makan. Setelah ini kita bisa kembali bersama Dr. Associate Professor Roni Lesmana from Pajajaran. After that, from Polska, Dr. Michal Starweski, and then the last is Professor Ryu Nagahara. Profesor Ryu Nagahara ini dari Jepang, dan kebetulan lab-nya khusus di biomekanika itu sangat keren banget, dan hanya satu-satunya di dunia yang punya plate yang force plate itu sejauh 50 meter. Itu yang di Kanoya. Sedangkan paling banyak itu hanya 3 meter. 1 meter, 3 meter, dan di Kanoya itu sepanjang 50 meter untuk plate force. Silahkan nanti bisa tanya-tanya lebih lanjut, dan mungkin nanti bisa ke sana atau kolaborasi riset bareng. Oke, silakan saya kasih waktu untuk istirahat.
Iya, iya. Gunung sehat ya. Tahan. Ayo. Di Pak Jasmani itu loh. Udah jatah pasca sekali.
Okay, Dr. Ronnie, are you here?
Yes, I'm here. Thank you.
So we can starting now. Oh, wait. I think your background is still the
old one?
The old one.
Okay. Can you share with me with the new one?
Yes. Wait a minute.
Okay.
I'm not yet shared to you.
I don't think so.
Oh, yeah. I'm not yet. Tunggu Cia. Nali. Nalilai. Wah. Okay, that's good. Here. Around. And then. Okay, you got it? So I sent to your WhatsApp.
Just get it. Give me a second.
Yes, okay. So can I introduce yourself? I would like to introduce you first.
Very welcome. Please.
Okay. Bismillahirrahmanirrahim. Okay. We are coming again. Hello? Anyone still have a breakout? Okay. So the next, our speaker is very generous person. Here is Associate Professor Ronnie Lesmana, Doctor, MCAS, IFO, PhD. Oh, I'm sorry. And He's from University Pajajaran, and his education background is PhD in Gunma University, Japan. Gunma in Kobe. And his recognition in service, the Scopus have a 73 document, 360 citation, and H index is 9. And he also get Young Investigator Award of 2015 and 2019. And his specialization is about physiology, also sports science and exercise physiology. Please welcome Associate Professor Roni Lesmana, Dr. MKes PhD, MKes IFO PhD. The screen is yours.
Thank you so much. Very good afternoon. Salam sejahtera buat kita semua. I'm very honored to be invited here again with Dr. Titin. Thank you so much for your generosity, for your attention and giving us the opportunity to sharing what we have been done in past recent year. I'm very honored to be here, to be around and surrounded by many experts from various area in Indonesia, maybe for other country also. So allow me to share what we have been work. Pardon me, we will start to share screen. So today I've been asked to share about the sport science that have been done with the team in UNPAD. So this is the title that I want to share with all of you. Hopefully you can hear my voice quite clearly. I want to share about the combination of exercise and herbal medicine as a potential treatment for improving quality of life in aging. So I started with the first slide that, you know, aging, everybody cannot run away. We always getting old, right? So in that perspective, when we are become old, a lot of things happen. Give me a second, let me mute okay, already. Thank you. So being old, sometimes people can accept that changes. Sometimes people hard to accept the changes. Sometimes people need to adapt with the changes. Okay, and this is something will always happen to us in men and women. We only be able to delay the process. We cannot stop the process. So old age is an aspect of things that happen to men and women. So in this regard, people in the situation when they are live in modern country or in the country with a good facility definitely will be able to live longer in many aspects compared that we which not have a good facility or support system to make sure that we are good enough to keep our health. So in that perspective, we understand that in between 2000 and 2050, the number of the percentage of the population, aging population will be increased even more and in the significant number. So this is the distribution in 2015. Wherever we can see that 30% or more, there is population people with age more than 60 years old or older. So as you see over here, Japan still leading with the age population or aging population. They can support the aging population to live well in the old age. So this is one of the interesting factor that we should understand and study together. How we can deal with the aging process, how we can make a strategy to counter the adaptation process during aging. So when we understand what is happening during aging, aging itself means it's characterized by a progressive loss of physiological integrity. This leading to impaired function, increased vulnerability, and to death. Thus, if you see in the graphic at the right side, after certain age, we can see that function in our body is decreasing. Nerve conductivity and velocity will decrease following the age. Maximum heart rate will decrease following the age. The efficiency of kidney blood flow will decrease. The maximum breathing capacity will decrease. The maximum work rate or oxygen uptake will decrease. And the fertility, as we know that in the female, will become menopause at age 50 years old. So we can say, for instance, that aging involving all organ function changes in cardiovascular system, nervous system, immune system, reproductive system. There are also many theories about aging. So example for the skin aging, there are several major theories, including the oxidative stress theories, including the gene clock theories, and any others. But amongst those other theories, oxidative stress is mainly believe that this is a key of emerging impact causing aging and is unbeneficial effect happening in our body whenever we getting old. One of the reason why the oxidative stress is one of the issue during aging, one of the compartment in the cells called mitochondria, which has responsibility to creating energy for the cells, become inefficient to transfer the electron and causing leaking of the oxidative stress level or oxidant, which is cause the stress in the cells. In these cases, we understand that the theory of oxidative stress is main of the major theory that we believe behind the situation of decreasing physiological function in aging population. There is several aging theory. First, there is free radical theory. Second, there is neuroendocrine theory. Sorry for mistyping. There is telomerase theory aging. There is wear and tear theory. There is the rate of living theory. There is waste product accumulation theory. There is cross-linking theory. There is immune theory. There is theories of error and repairs. There is the order and disorder theory. But among all this one, the free radical theory or oxidant theory is the most common claim as the culprit of the aging process in our body. What is initiated during aging? There is oxidation, there is glycation, there is methylation, there is chronic inflammation, and hormonal deregulation. So if you see over here, the aging, there is a new report that what is happening based on that theory during aging. There is declining of adaptive homeostasis in aging. Aging in physiological perspective, we know that there is changes in cellular homeostasis mechanism. There is decrease in organ mass getting smaller, like muscle getting sarcopenic and the mass is getting smaller. Decline and loss of the function of the reserve of the body. If you see this picture, there is also shifted capability of adaptation whenever we getting old. So if you see over here, this is the physiological adaptation whenever we get stressor or stimulation due to some factors. The basal homeostatic range example, like pointed by the blue arrow, this range. So whenever there is something stimulated, there is transcriptional activation, the response is activated in a minute, and then there is translational activation forming the amino acid structure, and this is within 3-6 hours will occur, and then the response will be off whenever the product is ready or formatted, and this is occurring in 18 hours, and 18 to 30 hours is back to the basal homeostatic. So this is what is happening physiologically in the cells whenever there is stimulation. But whenever we getting aging, okay, there is change significantly the capability to modulate the dynamic of the response of our cells. So the range of homeostasis in the young, we have quite wide range and the response, but in aging, the response and the range getting smaller. Thus, a lot of function in aging has been changes. Okay, for instance, if you see the skin in our grandmother or grandfather, the skin tends to be dry, and they always complain sometimes it's itchy and it's not humid and then not fresh like we see the skin at the teenager or skin of young baby example. Thus, the skin also changed its character, and we need to treat with a special approaches also. So aging can be said, this is also be able to be translated as loss capability of adaptation. Loss adaptation will increase. One of the culprit is the loss production, and this is causes aging. As you see in the figure in the right side, there is several things, okay, can induce the ROS level in our body. There is a specific signaling genetic, there is hypoxia, high fat content diet, calorie restriction, external material, environment, and so on. And this can induce the ROS generation, and then this can cause the organelle function and signal transmitter will be disturbed. And at the end, it could induce the cell death. And we thought over that maybe this is not the only things that happen in our body. Our group has been published one of the journal about the possibility involvement of new mechanism, which is we call hypopathway, with the effector through YAP and TAS protein and its association. And this has happened during aging in the skeletal muscle. You be able to download the full article of our group research. So definitely I want to show you several figure only in this meeting. So aging, we know that this is connected with the physical inactivity, dysfunctional of the stem cell, dysfunctional of the factor signaling, and tissue stiffness, definitely. And those 4 factors is connected with the rule of the YAPTAS. So we thought possibly the physical inactivity will connect it with the level and low level of YAPTAS, which is this can control the myoblast. And maybe we also thought that both dysfunctional of stem cell and dysfunctional of growth factor signaling, will lead to the loss, quiescence, and growth inhibition of the cells. And we still don't know, honestly, for sure, how the YAPTAS influence in this situation. But both and plus 1 factor definitely will delay the slow muscle growth or delaying the muscle growth. Thus, this will explain why it's happening, the sarcopenic or loss of muscle mass in the aging. And also, aging will cause the tissue stiffness. And this is correlated with the high level of YAP in fibroblasts. And YAP protein, will have responsibility for fibrogenic conversion of muscle tissue and increase the fibrogenesis. For in advance, you see that there is a process phosphorylation for the from the MST and SAF to the LATS protein and MOP1, which is important for activation of YAP and TAS. YAP and TAS will be activated whenever it's phosphorylated. And after it's phosphorylated, it will move and then will do its function properly. Definitely in one situation, it could activate, and the other situation through the ubiquination and degradation, it will be stopped. And whenever it go to the nuclear compartment, it will connect it with TAD, and then YAP will connect it with TAD and induce the DNA transcription. And this will regulate the organ size. So this is the theory that we thought that in aging, maybe this is quite a new perspective, how the YAPTAS or hypopathway regulation can evolve during aging, and explain why the homeostasis physiologically may be altered and disturbed in aging. So we really understand that by understanding the mechanism, it gives us the new perspective. But we know that physiological change during aging is not only a myth, but this is a fact. We run several experiments with our group, and we know that there is correlation between physical activity and the energy balance and metabolic syndrome of physical fitness in elderly aging group or age group. So we found that there is significant decline of performance and capability as is reported in the previous slide that have been presented. And we also know that there is a linear correlation between subcutaneous fat and mass body index in the old age, and this has the connectivity with their performance or their capability in perform the activity. We know that to perform the exercise intensity itself cannot be only generic for every population or community with the same intensity or with the same duration. Thus, some of the researcher in the world also reported that exercise intensity is very important in controlling the unfolded protein response in skeletal muscle in rat, which is disease may connect it with the way how we thought that we be able to cleaning up the waste product in the aging, or we can increase the turnover of the protein to increase the performance of muscle itself, to enhancing or increasing the quality of life in aging population. And we know also there is reported in the journal by G. Naichen, aerobic exercise stimulated Cloto upregulation extend lifespan by attenuating the excess production of ROS in the brain and in the kidney. So we know there is several protein is include and affected in aging by exercise. And some of the researchers thought that exercise is very important to stimulate and to interfere to get the better quality of life for aging population. Ultimately, there is one report in PLOS ONE said that lifelong aerobic exercise protect against inflammation and cancer. Okay, so in these cases, we know that exercise even further. Sorry.
We are waiting Dr. Ronnie. He have a problem about the connection. So just waiting a few minutes.
Sorry, I
Okay, we have that's come back.
lost connection. I'm so sorry.
Okay. That's good.
Sorry.
Mhm.
Okay, so by seeing these three reports, we understand that aging we cannot avoid, okay? And one of the factor that we can modify is the way how we do the activity daily or routinely in order, in other words, we can say how we do our exercise or we do our training every day. So this exercise modulation will affect and give a good benefit for us to get better quality of life in aging population. So again, since we see the background like that, how to manage aging physiologically is first is we need to make a tailor specific exercise program. And maybe one of us or many of us asking why exercise? What mechanism is stimulated by exercise? What is connected with that? So first of all, by doing the exercise regularly, it will reducing the ER stress. How it reduce the ER stress is through controlling the CHOP apoptotic signal and reducing this ER stress by giving the proper intensity exercise training. Need to be very understood well that intensity of the training need to be specific. Okay, we cannot do the same exercise for every type of group because segmental of age population will have their own challenges whenever they perform activity of exercise. Someone with a limitation and with the background of diseases, specific diseases, they need specific prescription of the exercise to be utilized whenever they want to perform a training or exercise program. So our group has been found also. The second reason, not only reducing the ER stress, but exercise also modulates several important genes. In these cases, we found that it modulates the PGC1 alpha, HIF1 alpha, MyoD, FGF23, CLOTO, and NR2B. PGC1 alpha, we know very well that this is modulate the mitochondrial biogenesis. HIF1 alpha connected with the vascular endothelial growth, and MyoD for muscle regeneration. FGF23 is believed to converting and utilize the fat burn utilization, and also for the stimulation for growing and control the hormone. And CLOTO and NR2B. NR2B is connecting with the brain function, and CLOTO connected with the cardiac muscle performance. And we found also that in that article that we have been explore, like have been presented before, this is part of the article that we have been published about the CLOTO, GLU-NR2B, and FGF23. And we need to understand that this is a way how the exercise may modulate the good effect for our body. First is reducing ER stress. Second, modulates specific interests and important genes. And this is also important to know that exercise modulate the physiological function partly via the autophagy. This is maybe one of the mechanisms that we rarely to explore as a sports science. But as we know that our PhD student now become the lecturer and assistant professor in Maranatha Christian University, and our professor, Dr. Vita, we explore that specific intensity is very close related with the cardiac hypertrophy process. And this is through the autophagy modulation. And we also found that autophagy gene expression is induced differently by different intensity. Other researcher from part other of the world, Escobar, has been published the similar topic with us in the review that autophagy may correlate it with aging. How? By maintaining the proteome through the exercise and caloric restriction. Thus, per se, for instance, third point is exercise may modulate autophagy, which is very important to maintain function of the cells in our body. Modulates the autophagy. Maybe we're not familiar with the autophagy. Let me explain a little bit what is autophagy. Autophagy is a process for cleaning the cytosolic organelle or unwanted waste product in cells to be throwing up. There is three types of autophagy. There is macroautophagy, there is chaperone-mediated autophagy, there is microautophagy. When we're talking about the macroautophagy, it will initiate with formation of double membrane structure bilayer, and this is called by ATG8 or LC312, and then this is will surrounding the target protein, which is sequestered protein, and it will engulf in the circle and border that target protein. To be able to destroy this unwanted protein, it will bound with the lysosome. This lysosome will bound with the autophagosome, form the name structure autophagolysosome. Since the lysosome contain with the acid pH, it will destroy this unwanted protein and become residual body and will be exocytosis from the cells and throwing out. Or the other one, it could also be able, lysosome will form with a specific method called the chaperone-mediated autophagy and bring the substrate and the chaperone protein inside to the lysosome and the lysis in the lysosome area. Or microautophagy, which is this process which is the form through the lysosome response and forming and destroy the protein. What is important about autophagy? Why are we talking about autophagy? As you see over here, autophagy connected with many situations in our body, connected with the cancer, connected with the aging, connected with infectious disease and immunity, connected with lysosomal storage disorder, connected with neurodegeneration, connected with diabetes and obesity. So this process is connected with autophagy. So we never say that increased autophagy always good in our body, but balanced autophagy is the best. We should understand, because sometimes we need autophagy to be stimulated, sometimes we need autophagy to be inhibited. So due to condition and due to the situation, cells need in our body. So if you see more details, exercise connected not only with the macro autophagy, but it also connected with a specific process autophagy called the mitophagy. Okay, mitophagy is a process for chewing the mitochondria by part of formation autophagosome surrounding the mitochondria. So exercise, it believed and reported to stimulate 1, 2, 3, 4. It can stimulate the biogenesis, fusion, fission, and mitophagy itself. And the mitophagy and fission, this is the purposes to remove the damaged mitochondria and have enhance the metabolic function at the end or performance. But exercise also be able and reported to stimulate the fusion and biogenesis. Interesting paper is, since we talked in the beginning that aging is one of situation caused by inefficient performance of mitochondria causing high the oxidant level and cause the aging, we see the very interesting study from the Russian group. Okay, in here we can see that there is some check between comparing between young, old, and LLI. LLI is centenarian group. What is centenarian? Centenarian is people who live more than 100 years old, and they took the biopsy of the muscle and checked the form of mitochondria. Interestingly, there is no so much difference between young and old. Old in here means around 60 to 80 years old. So there is no so much different, nothing different so much. But whenever you compare young and LLI in ATP content is higher in the people who live more than 100 years old, or we call the centenarian. And in deeper, this group checking about the complex 2, complex 4, complex 3, complex 5, and see the protein content. Honestly speaking, not so many changes, but some of the protein in the LLI is decreased, especially is complex 1 and complex 4. So means this complex is important for electron transfer change. And then this is talking about the capability to creating the energy and reducing the oxidant level formation. So at the end of this paper, this group reporting very interesting report that if you see as a summary in their figure, this is young mitochondria, 27 to 31 years old. And as you see in the mitochondria is like this, okay? And then in the 70 to 75 years old, 60 to 80, so it's become fragmented mitochondria. It's happening like this. But there is a very different in the long living individual or centenarian, 90 to 100 years old and more, there is a hyperfused mitochondria. So in this regard, the number of mitochondria is getting smaller, but the performance is getting efficient. This is what they reported. So this is increase the mitochondrial mass, but maintains the bioenergetic competence of this mitochondria and reduce the potential side product of the oxidant. And also the number 4, other than we're talking about the autophagy. So last slide, we're still talking about the process of autophagy happening in the aging, and then how the exercise be able to modulate the autophagy. The factor number 4 is exercise modulate the interleukin. So we are working close with one of very good partner in Universitas Negeri Semarang, Dr. Siti Baitul. We published in one journal that we elaborate and study about the aquarobic training. So this is the training did by Dr. Siti Baitul, and we check the EL12 level, and this is connected with the training. So we have the specific control obesity group in UNPAD, and then we try to check the interleukin 12 based on the BMI. More higher or larger BMI, the interleukin 12 level is increased. However, we also found that whenever we perform this aquarobic training continuously and with intensity, specific intensity. So we found that after 12-week trainings, it can decrease the EL12. So potentially the interleukin-12 be able to be used as one of the target marker of the training for the metabolic disorder, potentially. It's come up to us whenever we understand that aging is always happen. We need something to be done to overcome the disadvantages of aging by exercise. And we know how the exercise, the modulation through the mechanism there is regulate the ER stress, regulate the genes interest related to the regeneration, and also the mitochondrial biogenesis, vascular growth, and we know that it modulate the autophagy, modulate the interleukins, and we need to know and understand how we set the program for this aging population. Honestly, it's not only for aging, but for every specific population, we need to set specific exercise program. As we always know that overload principle fit is one of the scheme and the protocols that we always use as sports scientists. First, we always do care about the frequency, and we hope that this is increases, working out more often, running 5 times a week instead 3 times a week. And the second, we're talking always about the intensity of increased intensity, running faster when you run, example, and time increase, duration we're talking about, and also we're talking about the type, honestly speaking. And then this is how we set the personal fitness for every specific age, as you always know also as the sports science and sport coach, how we do in Monday, how we do in Tuesday, how we do in Wednesday, Tuesday, and also Friday, and how we control and what we should see. We can make some simple chart like this to control and make the program exercise for every target person that we want to recommend and then want to follow up. But managed aging physiologically is not limited due to the exercise intervention only. We also believe that we need to tailor specific diet program. So diet and exercise, both factor cannot be divided. So this is come together as a package. So we need to know what kind of the specific diet we should consider. So, you know, there is a lot of information in internet or reported in the journal. There is many food connected with the aging. People say they eat avocados, eat blueberries, eat yogurt, watermelon, garlic, walnuts, leaf vegetable, green tea, and so on. But all those type of food or drink is always talking about the antioxidant content. Why? Because I already explained in the beginning that oxidant is one of the culprit that we believe causing the aging. So based on that information and knowledge, people try to make a platform for all the adult peoples, how they should eat cereal, example, reduce the higher fat content food and increase the other things, eat some herb and spices, and so on. And it always also recommended to do the exercise, as I've been taught in the beginning. Interestingly, our group also explore about the herbal modulation in aging. We have been published one paper with Professor Karel Stari about the potential nutmeg extract, which is contained by PPAR alpha and gamma, will be able to be used as anti-diabetic and anti-dyslipidemic properties after we throw away the saffron. So this one give us the opportunity to counter the negative risk factor, which is we always found in the aging population. There is interesting story about this study. Whenever we run this study, we accidentally found that the mass of the rat that we use is a bit bigger compared to the control. So we think, how if we treat this one in the aging rat models, then we try to develop rat aging model, and after reach 80 weeks, equal with 60 years old in human, we treat with the nutmeg extract for 12 weeks, and we compare the shape and the weight of the soleus muscle. So Dr. Yuni found that this old rat has a bigger soleus weight and mass, okay, soleus length, what I mean, and soleus weight, compare that old rat without treatment of nutmeg. Thus, we explore how it could be, whether this is true or not. And we found that nutmeg potentially induce PI3K AKT-mTOR pathway, which is this is with inhibit autophagy and increase the protein synthesis, and this is preserve the muscle mass. However, we cannot elucidate it whether this process is totally improve the quality of life and functional of the muscle or not. But as we observe physically, the rat is getting healthier and more active compared to that rat which is not treated by the nutmeg extract. So we elaborate even more to rechecking what is contained in the nutmeg extract. So we check one by one what it's contained, what is the phytochemical properties over there, and then how it reacted, and then what is activity, potential activity in the nutmeg itself, other than that we found it could be preserve the muscle mass. So by SPLC study, we found some interesting result. There is a spike in weight in the target mass, which is we thought this one is equal with target that we expected is hormone. Because we thought that if we able to induce, there is a possibility there is a structure or structure looks like hormone, which be able to induce the hormonal signaling pathway like the phytoestrogen. We found that there is a size, possibly, we cannot say for definite, we're still checking. This is a size as big with human growth hormone. And there is a size as big as the levothyroxine, which is this is thyroid hormone. And both of these hormone has capability to control the metabolism level and the growth of the tissue in our body. And you know, interestingly, the thyroid hormone is very close related with aging process. We also found that not only correlated with aging process, but our previous publication also show that thyroid hormone stimulation is very essential for mitochondrial biogenesis and its activity in skeletal muscle. Thus, if there is something inside the nutmeg content have the beneficial function to induce the mitochondrial performance and activity, and this is well accepted for the aging population, we do really expect it at the future or in the future, there is a new supplement which is be able to be used for treated or support the aging population in our country. As conclusion remarks, I just want to say like this: aging is a physiological process. It's a progressive failure of metabolic processes that every organ at different rate, and also tissue adaptation capability is decreases at the aging. So we need to find the method how to prevent or to improve the quality of life during aging. So anti-aging approaches is aimed to maintain or achieve this irrespective or chronological acts like exercise, eat healthy food, fruit and vegetables, and probably we need to add some additional nutraceutical supplement. We may need to enrich the diet with optimum dose of proven antioxidant example. We also be able to manage through the exercise as presented in the previous slide, how we do setting program intensity, durability, and many other. And then we also agree maybe after we presented the data that exercise may reduce the ER stress and probably delay aging by modulating autophagy in mitochondrial via fission and fission, probably. And we also maybe agree that some of nutraceutical supplement may be needed for improving the quality life during aging. Example, nutmeg in our study. And we also believe maybe there is some hormonal substance inside the nutraceutical supplement, which is have a very good beneficial function to stimulate this hormonal signaling. And this is my importance for improving the physiological function in our body. So none of the less, last but not least, I'm very thankful with all the professors that have been contribute to our work, give insight, give critics, advices, comment, and to our member in the lab that already working hardly for this project. So thank you so much. This is end of my presentation. Hopefully I can get a good questions and we can discuss. Thank you. Return back to you, Dr. Titin. You still muted, Dr. Titin?
Okay. I'm sorry. Wow, interesting topic about aging. So I think we don't want aging faster, right? Getting old faster. We want always still young. Okay, and we're going to the session about question and answer. So you can raise your hand or you can write in the chat box if any question. Dr. Ronnie, so it's interesting your topic about the aging, right?
Yes.
And how we prepare that for the public people, not for scientists, right? So how to prepare to getting older, so that we know when getting older, we usually have a dehydration.
Yeah.
For like my grandma, so get thinny and also the skin more
Correct.
like that. So what should we prepare for that?
So I try to share the idea with all the scientists in this room because I do believe that a lot of sports scientists join in this meeting this afternoon. We cannot work alone as a medical doctor. Definitely, we need to work together with you with the two aspects. First, all of the presentation that I will presented only talking about two big aspects. It's about exercise and about the nutrition of our diets. So we need to really prepare about the activity that we suggested to the person in the society. And we need to really care about what kind of food or diet they consume every day. It doesn't mean that we need to consume a high, expensive food or type of diet, but we need to eat the healthy diet type, and then need to eat the balanced type of diets. Thus, whenever we treat the athlete also per se, we need to really control the diet, right? So we do believe that not one, maybe many in this room working with the athletes, we know very well that we control the diet of the athletes with many reasons. So I just put another information that in the diets, in the vegetables and fruit that we eat, we need to remember it's not only a fiber, it's not only antioxidant over there, but there is a lot of other things that may have a beneficial impact and effect to our body. Like I just shared about the nutmeg, we never thought before that in the nutmeg that is might contain with the natural hormonal looks like structure, which is be able to induce the hormonal signaling. And then, as you know, before when we call about tempeh, okay,
Yes,
the soybean, people talking about the phytoestrogen. So this is quite similar with that, but we are in the process to prove the concept and the data. But how we prepare when we enter the aging age? First, control your activity. Second, control your diet. That's very instant. And
also
then
psychology.
psychology, correct. Definitely. Whenever you be able to balance the diet and the activity, definitely you are happy, quite happy. Because whenever you do exercise, we know that exercise releases the endorphin, and endorphin is very, very helpful to control your manner and behavior in some point, and also reducing stress level.
Yeah, that's good. Thank you very much. So I think now I'm getting older.
If you're older, then similar with me, right?
Yeah. Okay, so and then here have one question from Maulana Syahrul Habib. Okay, so this is our student from IKER. He asking about the aging. Okay, you Maulana, you can ask him directly using Indonesia, no problem, because Dr. Ron is from Indonesia, not from Japan.
Chili Maulana, welcome, very welcome.
Oh, I don't know. Maybe he's shy. Maulana, you're here? Okay. If not, I will reading for you. So he asking about aging. So this is alami atau tidak dapat dihindari. Lalu apa yang mempengaruhi orang itu tampak tua atau penurunan fungsi tubuh seperti orang tua?
Okay, that's very interesting questions. So Maulana, I think you the fans of Korean's movie, right? And Japanese movie. Oppa, okay? When you see that oppa or that beautiful lady in Korea or in Japan, sometimes it's not reflected their age. You know, I always miscounted the age whenever I met the Japanese people. They look younger. They look really younger. Rather than the age they used to reflect it, right? So in this point, we know that Japanese people really like to eat the healthy food.
Yes.
Corrected me if I'm wrong, because
Yes,
whenever
correct.
you see that they eat sushi, raw meat, without any the preservative and so on. And the type of the diet, like I told you, the type of the diet, the habits of the diet, that's the first thing. Diet is the matter. Second is about the activity. Look at their activity. They move and walk everywhere. They put the car far away from the class and the car park is far away. How about us? I park just 3 meters in front of our office.
Oh my God.
I had a very bad habit, but I thought it's not only me, but all the Indonesian should think over how we'll set over in our campus to force people to move. When we put the bus station far away from the campus, it will force direct or indirectly students to walk at least 1 kilometers from the classes. And daily means they will walk 2 kilometers. We force them to be healthy. So in Japan, you need to walk from one station to other station. In Japan, you need to walk from one bus station to another bus station. And you need to walk from the front main gate of the campus to the front of your office or your laboratory. I think similar Taiwan, Japan,
Yes, similar.
UK, it looks like that. Moreover, United States is very far. You need to have a car if you want to have a bit convenience transport way. But again, you know, this is natural or not? Answer: yes, aging is natural. You cannot avoid that. Nobody cannot avoid aging, but somebody can prevent and delay the aging process.
Yeah, that's good.
Okay? And then you need to put underline, somebody can delay and prevent the aging process. How? Answer only 2. Exercise, control diet, and healthy mind. Number 3. And Dr. Titin added already. So if you can feel happier, you do your exercise routinely, and you control your diet, logically, without any genetical problem, you will live longer.
Yes,
That's the answer.
yeah, that's good. I have also experienced walking from the bus stop to my campus. It's about 3-4 kilometers every day if I want going to
correct. And then
downtown.
earlier, right? Whenever we come back to Indonesia, we getting bigger,
Older.
fattier, not healthier, but fattier.
Yes, fattier. Oh, yes, you're right. In there, I just have a 48 kilogram, but I already have some fitness. But in here, 54 without do anything. Oh my God.
Yeah, I still remember at the very first time I met with Dr. Siti Baitul, I still like a thin pencil. Now I become a big marker, big speed marker.
Welcome to the fattier. Okay, that's good. So, any other question? Well, this is very good topic. We still have a 24 minutes. Hello. Any else? Oh, in here have a Dr. Nisa, you know?
I know her. Hi, Dr. Nisa.
Yeah, it's big fan of you.
very good friend and very good sister
Yes.
of me, Dr. Nisa. Hello, Dr. Nisa.
Maybe is he busy? Still in Papua.
Okay.
Okay. So, related with your before you study about you use something flavonoid that you extract something. What kind of walnut or something that you did before?
Nutmeg?
Nutmeg. What is this? It's Indonesian. Pala.
Pala, correct.
Pala. Ah.
So pala is a common spices, always
Yeah.
used for cooking. However, sometimes people did not realize that how many beneficial potential effect in
Mhm.
nutmeg extract. So what you need to be considered in nutmeg extract is there is a content we didn't want to use that, or we didn't wish that exists in our extract, called saffron and myristicin, because it have the hallucinogenic effect, and then we always want to throw that content. So in our extract for a study in aging rat, we throw and separated that content, and we using free saffron and myristicin for treating our rat. Thus, we can see the effect more clear without any disturbance for the other substance. Definitely, it's not pure compound; it's still extract, but we can say that this is quite applicable and did not really harmful the other function in our body.
Harmful.
Harmful mean
Yeah.
harmful,
Mhm.
negative effect, because saffron and myristicin can induce the hallucinogenic effect in our body.
Allergy.
Halogenic effect. So is you can deep anesthetize in some point because this has connecting with that mechanism.
Interesting. I remember when I was studying magister, I studied about pinahong. You know pinahong?
Yeah, I know Bihanahong.
Yeah,
Yes.
yeah. And there also have a flavonoid and saponin, but I'm not yet done again, doing again. Just last time is about the infiltration of fibroblast cell. How is when someone get injured and then we just put the pinahong in there. So what happens? Just about that one. I think I need to collaboration with you again to study about that.
Yeah, surely, definitely. It will be very interesting. I also working with Dr. Ronald Hamidi in University Education of Indonesia, UPI. He working a lot with moringa. Moringa is
Moringa.
a lot.
Yeah.
And then working also with curcumin, and created the curcumin bar for improving the mitochondrial performance and function. This is underlying his background study in Japan, checking the effect of curcumin to improving the muscle mitochondrial function. Very interesting. By elaborating the curcumin function, he doing more high-tech results about the curcumin and creating the nanocurcumin now. So hopefully the nanocurcumin be able to stimulate the performance of the athlete or improve the regeneration process after the injury example. This is come of the interest topic that he and us been developed for study.
Oh, that's good. Curcumin. Kunir.
Kunyit.
Yeah, kunyit.
Correct.
Okay. A Japanese have a life longer, right?
Yes, correct.
Yeah. I saw in Okinawa. I think it's about 124.
Yep, correct. There is some population or some person live until 124 years old, correct. But if you see the cut of age of Japanese people, definitely is higher. Like I show in the slide, it's higher than any other country in the world. So this is definitely connected with the type of the diet they consume every day and the way how they work. Honestly speaking, if you see how they work, it's very tiring. because they're really, really hard worker. So I don't know how they can feel happy in some point, but again, the fact is the fact. The data is the data. They are quite happy, and then they can live longer. So I
Wow.
believe one of the reason is about the diet and the activity.
Yes,
That's the answer.
I remember Professor Yuna Gahara that last time come to Indonesia. So he bring a lot of bottle mineral water, but mineral water from Japan to here. So because I'm scared with the food in here, also the drink in here.
Yeah, sometimes when you're talking about the foreign people, it's quite interesting. My professor, whenever he came to Indonesia, he intently want to eat at the corner of the street, and I'm nervous. He did not nervous at all, but I'm very nervous because the day after he should talk in the seminar. Something happened with him, then everybody will angry with me, right?
Yes.
Because I'm not sure that he will be okay or not by eating soto, soto
Yes,
Lamongan.
soto Lamongan.
In the corner of the street, and I'm not quite sure whether this is clean or not. If he getting something with his stomachs and have a complaint, and then I will be in trouble tomorrow morning. He cannot speak up and cannot present it the data, but fortunately everything okay.
Oh, that's good.
He said to me that don't worry, Ronnie, I always bring my medication. So he always bring kind of drug for gastrointestinal complaint that he face whenever he visit other country. That is interesting.
Yeah, interesting. Okay, this is have one question again from RTY Yusan. Yusan, this is from Korea. So he asking about diet. Is there any support the caloric restriction to plan the aging process? But if we restrict the diet, we tend to reduce activity level, induce exercise that benefit to reduce aging.
Okay, thank you, Yusan, for a very good questions. I never really 100% agree with restrict. I agree with the word balance. You need to balance the type of the diets you given to the aging people, and you need to know and control the level of the oxidant, or example, the type of the fruit. Eating all the fruit also not good for the aging. So you need to balance how many times or type of the food that you recommended for the aging people, and then type of the way how you cook the meat, or you recommended the beans, because in aging people sometimes they also have problem with their clearance in the kidney. So giving a high recommendation to always eat the peanuts, example, something like that, or the green vegetables if they have the uric acid problem, is also become contradictive at the end. Thus, I do believe that you need to balance, not to restrict one or two type of the diet, but you need to balance the diet and control and tailor one by one. So you cannot using the same pattern for Dr. Titin and give that pattern to me, because the background, the activity background, the genetic background, the habits not similar. Thus, we believe whenever you learn about the exercises medicine, exercise is specific, tailored for one by one. You need to see one by one and give the recommendation. Even you give the progressive training program, even you give to the same group of athlete, every athlete have their own specific properties. If you as a coaches or sports scientist could spot the specific point of each athlete, you can elaborate and enhance its performance, or their performance, sorry, not its performance, their performance optimally. And then when you say that tend to reduce the activity level, include exercise, depend on. Thus, I call that specific tailored exercise program. We call that VATT. So when you want to say reduce, yes, we did not give the high intensity, but we tend to give light or moderate, example like that. And we did not ask them to walk in the far distance. Moreover, if this aging population have problem in knees, example, rheumatoid arthritis, we will not. So thus you need to see a very specific your patient or your target condition, and you need to justify the FETT recommendation specific for this person. In order you to be able to recommend specifically, you need to understand and see the detail of this patient, right? Then after you can give a good recommendation. This is the answer.
Okay. Hello. Is it okay? Is it clear, Mr. Yusan? RT Yusan? Oh, where is he?
Yeah, here we go. He said, okay, thanks, doc. Surely welcome. Very welcome. You want to send me email, we can discuss. But again, thank you for your questions. Definitely, I do like to set not restrict to balance. I'm physiologist. I always like balance. You need to balance yin and yang. You need to balance.
Okay. Do you know for also your study before have also about the diet for diabetic?
Yes.
Yeah. So what did you do for the diabetic patients? So usually they are older, right? They are elderly people that no you found have a for younger. I think they always older.
Diabetes also need to be differentiated, Dr. Titin. There is a type 1 and a type 2 diabetes patient. Type 2 more connected to the metabolic syndrome and then the habit of eating diets. And then this is connected with the obesity, hypertension, and so on. So whenever you find those patients, definitely you also need to tailor specific diet program and tailor specific exercise program. So not all the type 2 diabetes have the apple-shaped body mass, right? So sometimes there's in the middle apple shape. There is a pear shape. What I mean is that not all the like the textbook tool looks like that. Thus, you need to really assess one by one details your patient. Whenever you find the apple shape, definitely you cannot be able just like that to recommend please walking aerobic for 10 kilometers a day, and then you will find that patient have trouble in their knees because biomechanically, how we learn as a sports scientist, the weight will be load at the knees, right? So this one will give the complaint even more to the patient. Whenever they do exercise, they not feel happy, but they feel frustrated. You need to change the type of exercise. Still aerobic, but you can use example static bicycle example. You can control the intense and also the load of the bicycle. So this is can be able adapt of efficiently of the type 2 diabetic patient who has the obesity example. This is the things that I try to address is we need to tailor one by one. Even though we know the theories, we can say that moderate aerobic exercise is fit in with the metabolic syndrome patient. Yes, it is, but you cannot just put like that the recommendation. You need to even see more detail and adjust a little bit and start it slowly and increase progress little by little, so the patient feel okay with you and the person who be trained with you feel okay with that, and you be able to achieve their optimal performance at the end. Similarly, if you also have the injured athlete person, you cannot really just implemented the exact protocol from the books. You may need to see one by one for every cases.
Okay, thank you very much, Dr. Lesmana. In here have Michal. Maybe you can say hello to him. Michal Starczewski from Poland.
Hey, Michal, how are you? Nice to meet you, Michal.
Yeah, nice to meet you too. Nice to see you. Good morning, everyone, because in Poland it's 8 a.m. already. So
Good morning. Good afternoon here. Nice to see you, Michal.
Yeah, you too.
Looks like sunny day over there.
Yeah, it is, but still it's not so hot. It's only 10 degrees, but yeah, but it's nice weather. Thank you.
It is good enough, but a bit cold, definitely.
Yeah, cool. Okay. So, any else question? before we have a closing. Not closing, for session for Dr. Ronnie. After that, Dr. Michal. Any other question? Leo, you want to ask him something? Oh, no. Okay. So I would like to give certificate appreciation from the Dean of Faculty Sports Science. Okay. Thank you, Associate Professor Dr. Ronnie Lesmana, MCAS I4 PhD, for being speaker in the World Class Professor Program 2021 about sports science research application. So I hope we can still collaboration, not only for guest lectures, so about research and publication also. And maybe can share about the facility for research. As you know, in UNES, for sports science, not yet have a good facility to do the research.
Thank you so much, Associate Professor Dr. Titin. Thank you.
Thank you.
Thank you so much for
Thank you, Dr.
inviting me and allowing me to share what we have been done in our group. So happy to be here today. Definitely, I'm very open for collaboration. I'm very happy to welcome all of you, even if you want to come directly to our laboratory or our schools, definitely welcome. Very happy.
Okay, so see you next time in the facility for sports science.
Sure, we'll be happy to share that, and we'll be happy to waiting for you, all of you, to come to our university.
Thank you very much. Sayonara. Sayonara. Right? Oh,
Thank you, Miko. Thank you. Bye bye.
Ronnie, I'm sorry that I'm late for your lecture. I'm sorry. I just wake up just quite late and I have the coffee already. So I'm sorry, but if Professor Titin can do a short meeting online in a later time, we can just discuss what we can do together. So
definitely,
yeah.
Miko. I'm very happy and looking forward to discuss with you. Definitely, I'm looking forward to come to Poland. Definitely.
Yeah, feel invited. Feel invited.
Thank you so much. So looking forward for the time arrangement from Dr. Titin, Professor Titin. Thank you. So we are waiting for another chance for meeting up all of the speakers. Maybe we can discuss about the potential collaboration for research or academics. And I'm happy for that. So again, Miko, don't worry. No worries. We can still talk in any times.
yeah.
Thank you.
Thank you very much. Sayonara.
Sayonara.
Arigatou gozaimashita.
Arigatou gozaimashita. Domo. Arigatou gozaimashita.
Domo.
Thank you. Makasih Bu Titin.
Oh, you're a good friend.
Thank you, Mbak Titi. Thank you.
Oke. Iya, makasih.
Okay, so we're going to the next agenda. Here already have our Georgia's speaker from Poland, Polandia, Polski. I never been there before, but he already in here in Zoom meeting. So, Nali. Here's Associate Professor Michal Starczewski, PhD. He's from Joseph Pilsudski University of Physical Education, Department of Physiotherapy, Warsaw, right? Warsaw, Poland. And his education background is PhD in sports science in Poland. And actually he has so many recognition in service, but I just put here just only two that I know about. Last time we are together, the alumni of NIFISA 2019 in Japan, Kanoya. Also, his scopus have a 13 document and 44 citation, and each index is 5. And his research specialization is about exercise physiology and also sport for disabled. Dr. Michals, the time is yours. Okay, you are unmute. Please mute. Unmute. Unmute, please. You still mute.
Yeah, I'm just starting. Hope you can hear me and yeah, share the screen. I'm sorry, it's always stressful moment if everything is working. So hopefully hopefully my internet and you can see my screen. You can see my screen?
Yeah, I can see.
Yeah, perfect. So thank you very much for inviting me for today's session. I hope we can discuss something together during this session. And if you have any question during that in each moment, just please ask, and we will try to explain some topics that can be very interesting for you. And thank you for invitation, and I will go forward. Just thank you for introducing me. So to add a few pictures to my person. So as my background, officially I'm an exercise physiologist still in Institute of Sport, but I moved to assistant professor at University of Physical Education. So it's my new position. So yeah, that's the start of new journey. Also, I'm coach developer and a lecturer in many of coach development courses. And as Professor Titin said, we met in Nifisa in Japan, and it was a very extraordinary program to can create collaboration together in area of sports sciences. Yeah, I had a PhD in sports science. I had master in physical education, so that's my primary background. Also I'm a physiotherapist, and I was a canoe coach and head coach of Polish para canoe team. And during my journey through sport, yeah, I had opportunity to be the head coach during Paralympic Games, during World Champs, European Champs, and that gave me an opportunity to apply directly sports science into real world situations, so into athletes that I worked with. And yeah, it was nice to see how implementation can be useful, how our work in the laboratory can be useful in developing athletes or developing high performance of athletes and achieving success in sport. So as I said, that yeah, it's the most important that it's not only will stay in the laboratory or not only in research papers, but also will have an application to a real world situation. So for today's session, I have a few objectives. So explain the role of multidisciplinary approach of sports science. Maybe not only of exercise physiology, but yeah, if you work in sports science, if you work in high performance sport, or in the physiotherapy, or even in sports club, so you need to have some knowledge from different areas of sports sciences, not only physiology, and you cannot be only focused on one topic. So yeah, so I will just try to explain how it's interchangeably our multidisciplinary approach is something that is needed to achieve success in the research area, but also in a sports in a sport industry. I will just remind some key terms that can be useful during writing or reading the papers. and we'll give you some ideas of research directions in sport physiology in connection with sport training and sport application that we've done in our laboratory. So let's start with some graphs that will show us what is needed to get a success in sport. And if you can just look around the circle, so there are plenty of indicators or plenty of variables that influence final outcome of the training, of the years of the training, or of the performance in sport. So as you can see, that is psychology, strength conditioning, Paralympic movement medicine, physiotherapy, research, development, performance, physiology, biomechanics, performance analysis. And if you consider each of them as a next circle, which have 20 or 30 different areas or even more, so that will give us an imagination, how much we don't know at the moment. That's what I can say. The more I know, my imagination is that there is much more to discover, or much more to learn, and much more to get from the other areas that can help achieve the success for athletes, for coaches, and for us as a support team, for for our national teams. As I can say, some introduction to that lecture, and some definitions. So what's sport physiology, homeostasis, biomechanics, sport nutrition, what VO2 max is, lactate, maximum heart rate, and power output, and the other ones which are probably known by you, but it's always good to have a look from the other perspective. Maybe you will find something that's new, or it's written in different language, or from different angle, and you can find something for you. What we can say, it is very important, or first definition about fatigue. So it's important area or topic of research that is needed to know how much we need to recovery after each training, or what kind of fatigue is caused by training intervention, or just by singular bout or singular drill that is given to the athlete, and how much time we will need to recovery, and we can perform once again with same outcome, or the better. Thermoregulation, it's a topic now, because I don't know if you are familiar with Nobel Prize. So the last Nobel Prize in physiology and medicine is in the area of thermoregulation of the sensor that in the sensors in our body, in our skin, that bring the effect of feeling the heat or feeling the cold. So that's the area where we have plenty to discover, and it was one of the main area for preparation to Tokyo Olympics and Paralympic Games, where we were expecting high dose of heat and humid. So the temperature probably were above 30 degrees and humidity was quite high because the climate of the Japan and Tokyo at this time of the year, and it was main challenge for people from Europe, as an example, as from Poland, where the temperature are not so high during the summer, and obviously we don't have so much humidity connected with high temperature, and yeah, how to deal with that, how to prepare athletes for that. Plenty of research in the last few years, 2-3 years, were conducted to fight the heat and to bring the best solution to acclimatization to that tropical climate, tropical for Polish or for European people climate that was expected in Japan in this year. As we talking about the multidisciplinary approach, we are probably all know that sports science, it's a lot of different areas that we need to know something. If we are specialized in sports sciences, you need to have some from psychology, some from biomechanics, some from physiology, from biochemistry, nutrition, from endocrinology, and the other areas that are somewhere around our human body. So yeah, so if you choose sports sciences as your main research area, so you need to know that you need to be multidisciplinary. At the moment, if we are preparing some research or papers, so it's not only in one area, so we cannot just check the physiological outcomes. It was checked for few times at least, and for sure it was few hundred times checked how human body react to the proposed physiological reaction to the proposed protocol or to the proposed exercise. So there is maybe not so much to discover, maybe not to discover, but not so much to discover new in one area. So we need to go cross the different sciences. So we need to, for example, add something from biomechanics. So we add some additional resistance, additional check of the joint angles. We can check for body movement in the three-dimensional, and then discover how much it is ergogenic. So how much energy we need to expand to pretend that movement or pretend in the other way. So if we will combine that these areas, so it have more impact. It is more. It have a more value to the real world, to the strength conditioning, or to the high performance sport. As well, my last project is about thermoregulation and immunology, how the temperature impacts immunological response of the body, and how different types of cooling techniques can affect immunological response in the heat. So there are plenty of approaches to one topic, just to give an answer to the very tiny question: what we need to do, or how we need to do to move forward with our research. And one thing that I would like to give you as an outcome if we are thinking about athletes or about patients in rehabilitation. So where are we as a researchers? So first of all, or that's one of approaches maybe. Well, first of all, there is an athlete or patient in the center of the whole process. Then we have coach or therapist who will work closest to the patient, closest to the athlete, and will support him or her in the daily situation. So we need to know that all that we are doing, all the research that we are conducting, need to have a purpose, need to go to application in a specific situation, in a specific environment, and that where we are based. We are researchers. We are coaches, researchers. We are someone who work at the universities. That to translate science through our research into application to the patient by coach who will then maybe do some improvements in protocol because he's the closest to the athlete or to the or to the patient, and he can react the fastest to the situation that he will apply, he will see during the real life. Because as you can think about, so we can propose the best protocol which will give the best outcomes to athletes. So for example, 3 series of 20 repetition with 78.5% of body mass load for that and that exercise, and from the research it will appear that we will have the best outcome during the training process. But in the real world, we need to know that athlete can be tired from the last day, can have some injury from work to the club, can have some problems in school or with girlfriend, and he cannot approach this best protocol. So yeah, from one side we can propose the best solutions or the best protocols, but from the other side we need to be we need to have an opportunity to change or to give some frames where the coach or the athlete need to move to get the best results from that, what is known and what can be applied. So in our mind, if you are conducting the research and you would like to apply it, so you need to know that at the end there's an athlete or there is a patient in the rehabilitation, and there's a kid or someone who will conduct these drills and who will need on who it will be tested. So yeah, so that we should have in mind just to go forward with our research, just to know if we are doing research for research or research for the people that are at the end of this journey. So if we think about athletes, so why we do the research? First of all, identify strengths and weakness in the athletes. So at the beginning of training process, we need to know what we need to work on, where are the best sides and where are the weaknesses of the athlete. What is the baseline and what will the outcome of our training program? or what will be the efficacy or efficiency of our program. We can evaluate health or fatigue level of the athletes after the training or after the training cycle, or it will be short cycle or after a week or after a month, or as I said, fatigue level after exposure to the high temperature and how the immunology system or psychomotoric system reacts to conducted environment. Ongoing monitoring and evaluation of the training status of the rehabilitation program assist in selection process. Is if we are talking about high performance athletes, yeah, it can be a selection process or talent identification to the sport. If the person who are coming to our club or to our lab have more dynamic, high power maximal in the anaerobic test, or is very talented in endurance sports. So we can just put the direction. You have a basket of the sports that you can take, for example, long distance running, cross country skiing, cycling, because you have very good, or you are talented in the endurance sport, or your physiology or physiological approach give you a chance to get the better results in the talent in the endurance sport rather than in speed or strength sport. That will give some ideas where to go, just to don't lose a time between, or just don't lose few years, or just don't lose a talent from the sport, and just to give some ideas at the beginning of the road where will be the best, or in the middle of the one sport, like example athletics, or you can be a short distance running or long distance runner. So just to give an opportunity to go through proper road to success, or to best results, or to the best results that he can achieve, and to give a chance to achieve the best results from that, what physiology gave to that person. During the one training, it can give also some motivational influence. So yeah, I improved a few watts in time trial. I can improve a few seconds in a time trial. So it gives some influence on the psychological point of view of the athlete. Developed knowledge about sporting events. So yeah, for example, we have cycling. We know where the course for world championships, from what championship will be. So we can go, for example, if it's known 1 year before, you can go 1 year before you can go through your bike, just or just by car, and just check all the necessary points, how much elevation, how much descending will be, how many hard turns will be, how much power athlete need to produce in a specific moment of the course, just to keep the performance which will give him the possibility to achieve good result. And at the end, you can create a profile of the track. You can about descending or inclination. You can create the profile of the cycling course by power meter in the bike. You can create profile of the track with some wind conditions, and after that you can create a training plan, just to know where the athlete need to push a bit to get some result, or to split the group, or where it is possible to get some headwind or backwind or something that can disturb. And on the other hand, you can create a specific environment to train to the specific competition, and that what the research can research can help to prepare for main competition. So if we look once again what we can do for our athletes, for our coaches, for preparation for the main event, yeah, there are plenty of possibilities. Just to add some specifics. So if you work in a high performance group and you are in the middle of the preparation, so everyone from each thing and will support coaches in one thing that he don't need to think about, but he has some specialists. It will give, and for example, if each variable, each person will add 1/10 of the seconds, 0.1 seconds on the 1 kilometer. So if you at least 2, 4, 6, 8, 10, 12 person will work, for example, from that slide, will add 0.1 seconds. So together it is 1.2. And if athlete will add add the same from his point of view during the training process, so it's 2.5 seconds and 2.5 seconds on the 1K. Yeah, it could be crucial if you are 10th or on the medal position. So yeah, so we need to know, or we need to have in mind that each person in the process will count, and each small changes in the outcome of performance will give a good result at the end of the final race. So what I can say that what I want to say that, yeah, we need to think about as a team to create a high performance community, and we need to surround the coach and an athlete just to create an opportunity to work and to grow. And also for patients that are in the physiotherapy process, so they are in the center, and we as a sports scientist, as a developers, coach developers, as a teachers, as an educationist, we can add something to create the proper environment, just to create opportunity to achieve results by the training or by the physiotherapy. Once again, something as a reminder, so what we need to consider before the research, so what we will measure, how we will measure, what test we will use, if it is objective, if it's repeatable, if it's reliable, if it's valid, specific, sensitive enough, or is it just a picture as a baseline and we will repeat the testing afterwards just to check the results of training, of process of rehabilitation, or just to check if intervention in our research brought some effects on the performance, on the quantity or quality of the outcomes that are from our research. Example of validity on the Wattbike power meter or Wattbike cycloergometer. So if we can see about what we can talk about this equipment, or so. If we are doing some, at what we need to consider when we are talking about results of after conducting some research on a watt bike, it's cycloergometer. So if you can see below 100 watts, the error is quite high because it's 6%, but it's still only 6 watts. So the measurement error will still be about 6 watts. But if we will go to 200 watts, it's only 2%. Until 500 watts, it's only 1.5%. Up above 500 watts, it's even less. So if we can say that validity is low in the lower level of power production during the test on the watt bike, but if we will have the higher numbers of absolute values of the power measurement, so we need to have that in mind when we are comparing the data. And for example, rider record, it's 425 watts plus minus 3 and 2 watts, because it goes from 1.5%. So the the improvement will need to be 4 to 5 plus 3 and 2, and if we know he will improve 1.5%, so he need to achieve 430 watts just to skip the measurement error and just to have the proper results from our testing. So always need to check on of the tests typical error before you are conducting the research, just to know if the results can be the effect of the error of measurement, or it is true result which is caused by the intervention that we were doing in that research. Sensitivity. So it depends what we are measuring, how much accurate data we need, how much or how frequent will be the sampling. So probably in biomechanical analysis, they are very, very high. And for example, in ergospirometry, we are using breath by breath method. And so if we are breathing 12 times per minute in the resting stage, it will be only 0.2 hertz. So it is quite low frequency, but still it is enough to measure gas exchange or oxygen consumption. But for example, in the counter movement jump, you need to have a much higher frequency just to create the curve and just to have proper outcomes of the measurement. So depends what we want to achieve, what is the methodology of the testing, what should be the results. So the sensitivity should be applied directly to that what we want to have. Even if we are talking about times in a sport, so for some sports are the second number after the point, but in some of them it's measurement to 1,000 or even further times of the second. So it depends how much precise we need to be just to give some specific outcome for the situation. Of course, we need to check the test repeatability, variability, and reliability. And we need to know how much error it can affect, how much repeatable it is, if it is a field test or if it is laboratory test. Laboratory tests are more repeatable. Field tests are less. Probably you know that because the environmental conditions will affect the result of the study. What we need to take under consideration when we perform the research, and we will do repeatable measurement. So same time of the day, equipment, same warm up. In the field test, maybe the same route, hydration or dietitian standards or coffee intake or other aspects that are common in the life of the person, and we need to can affect the results of our research. So we should take that into consideration when we plan our research, or when we are writing a proposal for research. Of course, well-rested participants before the test, the best is 1 or 2 days without training or with light training, just to give an opportunity to recover after last session. And what is worth to remind that if you cannot control something in your test, you can monitor that. So it always paper and pen, and you can always write some notes what can affect the outcome of the test of the person that is taking part in our research protocol. So that's what we need to consider if we will write a publication. So okay, there's always limitation section. So it's always something that we can add additionally, that we know that we did everything that we can, but still there were some points that we could not control. So that could affect a test result and could affect the conclusion from our study. So yeah, it is very important just to have a pen and a paper or some electronic devices when you can write your own notes, and you can later come back to that and create some additional report for further research, and just to create a probability to avoid that in the future. Yeah, so standard protocol, result template, record everything, accuracy. What I would like to say about at the end of this introduction, or this reminder about research. So you need to also think about if data makes sense. So as you see at the graph, if it has sense or not. So there is a correlation between number of pirates and global average temperature, but still if you see if that have a sense. So before conducting the research, yeah, it's always good to know to have some few minutes of thinking if that will have some additional input to the knowledge. We'll skip few things. So I will talk now what we are doing in our research lab. So it's part of the, I'm sorry for Polish language. I haven't seen that in that slide, so sorry for that. But here you can see the our laboratory, our physiology laboratory doing the coaching course. So we had some sessions where the tests were conducted on the cycloergometer, and we can discuss with coaches what they can see and how can they apply that test to their perspective. There were coaches from different sports, not from cycling only, but from different type of sports, and just to understand, give them the understand how the test is done, what can athlete feel during that, how he's tired, and what outcomes, as you can see on the wall, what outcomes the coach can have after this test. Also, we're doing some tests on the track in the field condition. We choose track cyclists because it's the condition on the track are very close to the laboratory condition. One, what we need to have under consideration that it's only about athlete if he can perform the proper velocity during all tests. So it depends on the athlete mostly what are the outcomes of the test, not the other environmental conditions are not so important during that. We do also some tests on arm crank ergometer. It's our Olympic medalist from Rio Games, and we do some anaerobic tests. We do some tests on water as well. So it's a part of my Paralympic team preparing for Rio Games. As you can see, we do some lactate testing and some biomechanical testing using power meters on the paddle shaft and some power meters on the boat, just to give some idea how much power they create and how much it is transferred to the boat to accelerate during the race. Also, some tests, ergospirometry tests, just in the field condition with the cross-country skiers, also used in our laboratory. In individual sports, also some tests in the field condition, but mostly on the ergs, just to create repeatability for the test of canoe athletes. Also, some monitoring during the competition on the fencing mat, in the pool, or just some skiing ergometer also in the field condition where we can adjust to the situation. But we have also quite good experience with Paralympic athletes. So if you work with Paralympic athletes in different sports, in cycling, canoeing mostly, but we are working with athletics, with rowing, with cross-country skiing, and many other disciplines. So I'm open for discussion. What are you using and how you can use it, and what equipment is the best, just to check the current performance or just to conduct some research in this area. Also, in team sports, we did some projects with ice hockey players, with volleyball team, or with football players, just to create an opportunity for the coaching teams to have information at the beginning of the preparation season or at the beginning of the season? What is the current state of performance of the athletes? Also using with our biomechanical department just some photo cells and just how the acceleration is going, deceleration, and what is what's the movement pattern. And at the end, or maybe not at the end of the last part of my today's talk, I will talk about 3 projects that we've done. So 3 maybe direction for future research. One, it's about CARDS method. It's method used in physiotherapy or also in the training. Total hemoglobin mass. It's something that we are using to establish how much hemoglobin is in the blood and if it has any impact on performance and how much has an impact on performance. And few words about inspiratory muscle training, as it's not so new, but still it have a lot to give to athletes or to coaches as an easy training method just to create opportunity to improve performance. KAATSU, maybe some of you know the method. It originally comes from Japan, and it is a method which use restricted blood flow. So you need to use some mankets. I don't know how it's not a belt. It's I just don't remember the names. It's mankets when you inflate the air and you create the restricted blood flow. What is important for that method? You can use low intensity. You don't need to have a very high rest. Extraordinary metabolic load, so it create outcome as a very high intensity or very high load training, and the effects are similar to the to the training with more resistance and immediate cell volumization. It is from the producer of this method. As you can see, it's restricted blood flow. It's not the stop of the blood flow like it is used in surgery. It's only restricted. So you are creating we are creating the pressure on the veins or arteries, and the blood flow or on the veins. The return of the blood from the working muscles is slower, and it creates metabolic effects. As you can see, it creates 2 mechanisms of vascular distension, emptying, and disturbance of homeostasis in exercise muscles, and it creates anabolic process like angiogenesis and muscle hypertrophy. And it is communicated to central nervous system and respond by reflex increases in heart rate and ventilation because the circulation is restricted. From the point of view of muscle recruitment, fiber type recruitment, with a low resistance training, fast twitch fibers are recruited to conduct the movement. What create a metabolic effects like with high load of the training, and it create accumulation of metabolites like lactic acid environment and growth hormone secretion. and it creates mTOR pathway activation, so protein synthesis. So there are some belts with different sizes. As I show you, you can put it on your lower or higher limbs. There are elastic wider on the legs, narrower on the arms. Can be removed from the device after inflation, so you don't need to keep it close to the device. So you can go somewhere in the gym and then create the or conduct the your drills, or you can even go on the water in canoeing and just do the training with those belts on your arms or on your legs. It depends what you want to what do you want to achieve, or in which body parts you want to have an effect. Yeah, it's set manually, and optimal SKIU set on the device. So that are units that are established on the device. And if you can see, there are very low intensity recommended by the manufacturer for to create effect of ergogenic or metabolic effect from the muscle. So probably if you are coaches or if you are athletes, so you know, just to increase body mass, or just to create, or just to conduct the training to increase body mass, so you need to use about 70% of 80% of body of one RM repetition max, just to have an effect of the training. And if you use that method, the effect will be the same if you will use half of the intensity. So if you can see different approaches to the training on the upper arms or on the upper limbs or lower limbs, and yeah, just to create some resisted blood flow. What we've done in our laboratory, we checked the acute effect of KAATSU application on hormonal status in 8 high performance canoe athletes, Olympic Games, world champions, medalists, and they were divided into 2 groups. So half of them did training with KAATSU, half of them without, and then were washout period, and the groups has changed. Both groups has similar training, but one used KAATSU, and that are training load. So there are series, there are repetition in the series with barbell push, barbell pull on the bench, and clean with barbell. So that was 3 drills and 5 series of the drills with some repetition. KAATSU group used 30% of 1 repetition maximal. Standard group, which done standard training with 70% of 1 RM. So that was our methodological approach, just to check if accumulation of metabolism will be the same in the group, if growth hormone secretion will be higher, if the KAATSU will occur, using KAATSU will occur the same effects as standard training, standard protocol. So if you can see that hormonal content before and after training, measure in the morning, at the day of the training and the day after training, the same hours, just to create the possibility to check if it's work. So if you can see before and after training, there were no changes in testosterone in KAATSU group. There were slightly lower values in a standard group. There were also the cortisol level were lower in both groups. Growth hormone was higher in the KAATSU group, but it wasn't in the standard one. EGF-1 alpha was higher in the KATSU group, but lower in the standard. What we can say from our research, that KATSU training brought increased the growth hormone factor, growth hormone after the training, and it was significantly different from the standard procedure. So this one experiment showed that the using of cuts of restricted blood flow can create metabolic effect, which is can create metabolic effect by use of lower resistance or lower intensity of the training than using the standard one, and even the changes were significantly different from the standard protocol group. We also checked creatine kinase and urea before and after the training. Sorry for Polish, I haven't realized that it's in Polish. So its general effect of the training, we see the increase in kinase, creatine kinase before and after. So it was morning in the day of the training and morning day after the training. Also urea rise in the KATSU group, but haven't in the standard one. So if we can see, there were almost significant differences in this group. Probably if the group will be higher, and with the numbers, the numbers of the group will be higher, so we will see the effect of urea, but it will need further research to confirm that observation. What we can say from that research, that the study confirmed the effect of the cuts on the increase of growth hormone after exercise. So the effect is visible even in high performance athletes, and the use of KATSU training can give additional support. So it can be also transferred to physiotherapy. As you know, after hypokinesis, so after lying down in the bed for a few months because of some surgery, you will have a decreased muscle strength. So if you would like to have a faster increase, so you can use that method even in the very small intensity. You will have effects like in high intensity training. So it will be also maybe not healthier, but it will be more secure for athletes with some diseases that they don't or can't use the high intensity because of higher blood pressure and other ones, just to create an opportunity to do some strength training. Also, what we observe, lack of physiological reaction, which may be caused by the low training load for them. KATSU does not cause negative side effects and can be used as additional training method in this high performance healthy group. We need to check it for the other groups, like for patients, if it's also if there will not be the side effects. So yeah, let's do it. Let's try it. It's one of the proposal. Second is a total hemoglobin mass. As you know, hemoglobin it's a part of the red blood cells which bind the oxygen and will transport it to the cells. And total hemoglobin mass is different from the content of hemoglobin of the blood. because it expressed in the absolute values in grams per body or relative grams per body mass. It isn't depend on the plasma volume in the blood. So you can always check how much hemoglobin do you have in your body, and it doesn't depend on the plasma volume or on the hydration of the patient. So what we can observe that in high performance athletes, endurance ones, there is a very high blood volume just to create high stroke volume, because it's an adaptation to the endurance sport, and the content of hemoglobin is on the lower level of the norm, and it is created by the high amount of the plasma volume, not on that the hemoglobin level is low, and that kind of investigation can give us an answer if athletes need to have some pharmaceutic support, some iron supplementation or other stuff supplementation, which will create higher hemoglobin content, or just if it is created by the volume of the blood. How it is done? It's based on the 2 minutes of breathing a mixture of oxygen with known volume of carboxylate. So it needs to be known volume. It needs to be safe for the athlete, and yeah, it is in the laboratory condition only, and it's determining of carboxyhemoglobin concentration in the blood before and after taking or breathing by a mixture of oxygen and carboxylate. After the 2 minutes of breathing, blood samples are taken. Before and after are taken just to check the content of carbohemoglobin in the blood. That's what I say. It's not dependent on plasma volume, and it gives a big advantage of hemoglobin mass over hematocrit or hemoglobin content, which are mostly used to check hematological status in athletes. In our experiment, we assessed the effect of 3-week low altitude training below 1100 meters, supported by normobaric hypoxia 2200 meters. So it was hypoxic room in one of our central preparation facility for high performance athletes for national teams, followed by 2-week near sea level training on hematological status and values of graded exercise test in female in the elite female cyclists. 22 endurance track road female cyclists took part in the study. There we ran semi-randomly. They were assigned to 3 groups. First, elevation below 1100 plus normobaric hypoxia, 8 athletes, 4 track and 4 road. Placebo group, which were living in the hypoxic rooms next to them, but doesn't have simulation of hypoxia in the rooms, and control group, which were living in the other facility, just to had some answer if the changes in hemoglobin was the effect of training or this additional hypoxia. They had 3-week training camp. The first 2 groups trained at altitude 7 to 1100 and were accommodated in hypoxic room, in which they were asked to spend at least 13 hours a day. So to have an effect, as from literature, it's at least 8 hours. So we ask them to spend at least 13 hours. So we count their sleep. So it's about 8 hours, 8 hours plus 4 hours during the day in the hypoxic rooms. What we can see, the changes in the total hemoglobin mass, all groups had in all groups total hemoglobin increased, but we cannot see the differences between groups. So even though if the group were in the hypoxic room or just train normally without hypoxic, or just train in the other facility, the total hemoglobin mass increased after the training. So we can say that was the training effect in the total hemoglobin mass, and the hypoxia, which should bring the effect of the on the hematological status, doesn't create that, and we haven't observed increase in maximal oxygen consumption. We just seen the effect in my maximal power output just increased because of the training, as a training effect, and the same power output at 4 millimole blood lactate threshold, anaerobic threshold 4 millimoles. As you can observe, there were different changes in total hemoglobin mass. Most of them had better results, and as you can see, this line show the measurement error in our laboratory from previous studies. That are some changes in peak power output, in power at anaerobic threshold. So yeah, mostly positive effects, but some athletes had reverse response. But what we can see that if we observe changes in the total hemoglobin mass from the start point, we can see that with the rise of the hemoglobin mass, also the changes in anaerobic threshold performance, which is very important from the point of view of endurance sport, also increased. So we can see some correlation R 0.5. We can see the correlation with increase of total hemoglobin mass and changes in performance measured by anaerobic threshold. And as a conclusion from the study, that regardless of the application of normobaric hypoxia, low altitude training followed by near sea level training might improve hematological status, and especially for athletes who has low initial values. So what we can see that it was not only the effect of hypoxia, which were suspected or assumed at the beginning of the investigation, but mostly it was training effect that brought increase in total hemoglobin or adaptation to anaerobic training. I will skip that about inspiratory muscle training because we are close to the end, and sorry for that. And at the end, I would like to say that, yeah, we have explained the role and I hope I explained the role and multidisciplinary approach of sports science, and you have more or higher vision of the using of sports science in your research job. I just discussed a few topics about the new topics about sports science and give you an idea about maybe 2 new possibilities of application of sports science in high performance sports. And I would like to thank you for that. And if anyone has any question, I will give the word to Professor Titin. I don't know how to do it. Stop share. Okay.
I'm not yet professor, still associate. Okay, thank you very much for your excellent presentation, Dr. Michelle. In here, I already have a Professor Ryu also from Japan. Okay, so have any question from participant? Okay, so if not, I will asking something. Oh, Henry, Mr. Henry. Okay, please, you can directly ask to Dr. Michelle. You can unmute yourself.
Moment.
Okay, pardon?
This is interesting to explain about Katsu exercise. It can enlarge muscle in the short time or short term. But I want to know what is the negative impact of this Katsu exercise for the long term?
What is the negative? What I can say, I don't have experience. Maybe we haven't provide any research on the long time effect of the Katsu, but still there are some restriction to use it, so you haven't used it for longer than 20 minutes because it can cause too much concentration of metabolic end effect in your muscles, so it can cause some effect on your on the muscles on the or accumulation of the end products of metabolic pathways. But sorry, I don't have answer for everything, and it needs some research for that. We use it only for we did only two short research. One was acute effect that I present you, and second one, it was effect of 4 weeks of training, and it also creates some positive effects of on the training outcomes in those girls. But it was also not only Katsu training; it was additional part of the training that they done in the last series with low resistance, just to create some more effect on metabolic and to increase growth hormone production. So sorry, I cannot answer you. Maybe I don't know if you have any experience with Katsu. Maybe you can just share with us, because I'm also very curious about.
Okay. Yeah, thank you. I'm remember about Armstrong. Armstrong is the cyclist from USA. Is it? He actually put blood to her body, and then this is illegal. What is this? Illegal
doping.
Yeah.
Support.
Yeah. for the athlete. Yeah.
Yeah.
Thank you. Thank you.
Thank you.
Okay, that's good. So is it okay, Dr. Harry? Okay, now the time is going to up. So I would like to give some appreciation from Professor Tandio Rahayu, that our Dean Faculty of Sports Science. Okay. The link certificate. So, Associate Professor Michelle Stars, Swiski, PhD. Thank you very much for speaker in the World Class Professor Program 2021 in Sports Science Research Application. Thank you. So we hope we can collaborate again, not only for guest lecture, also about research and publication for the next future.
Thank you very much for having me here today. I hope we will see us soon. And yeah, I'm open for discussion or for emails. So if you have any questions, or just you can go through Professor Titin, or we can go direct to me, and we can try to find some solution, or maybe try to find some new research ideas to create some joint projects, and yeah, just to have some nice outcomes with athletes. Thank you very much.
Thank you, Dr. Michelle. Maybe you can say hello to Professor Ryu, already in here, that our Sifu.
Where is he? Oh,
in here.
Hi.
Hi.
Hi. Hello. I leave you the stage. So have a nice day with the guy, with all the audience, and yeah, they are warm up, and I think they have plenty of questions to your topic. So have a nice chat.
Yeah.
Okay. Thank you, Dr. Michelle. You can still in here, no problem, if we don't have something to do. So we can study together and see what Professor Ryu will be present. Thank you. Okay, now we're going to the next session. It's about biomechanics. So in here already have a Professor Ryu Nagahara from Kanoya, Japan. And he have so many publications about biomechanics. Okay. Yeah. Okay. Okay, now. Okay. I'm sorry, I don't have so many information about him. So I just know he's as a Professor Ryu Nagahara PhD. Now the institution is in Kanoya, Nifis, Japan. And his education background is PhD Sports Science. And the recognition in service in Scopus have a 53 document and 520 citation, and its index is 13. And his specialization research is about biomechanics, also sport performance. Professor Ryu Nagahara, the screen is yours.
Okay, thank you for your introduction, Titin. And I will share the screen. Can you see it? Is it working? Okay. Okay. Thank you for inviting me to this opportunity. I was not sure who is the audience, so I made the slides for students or not the expert in biomechanics. So it's possibly boring for a biomechanist, but please enjoy my talk. Okay. First, I'd like to introduce you our university. The National Institute of Fitness Sports in Kanoya is an only public sports university in Japan. Our university is located at here, the south part of Japan, in Kagoshima Prefecture. This is a picture of our university, so I'm at around here. Okay. This figure shows categories of my sprint researches. As you know, I studied sprinting from the biomechanical perspective, but not only the biomechanics, but also other aspects of sprinting I have been investigated. So, and today I will talk about these 4 topics. So one is biomechanical features of sprinting. The second is biomechanical determinants of sprint acceleration performance. And the third one is a strength determinants of sprint acceleration performance. And the last one is an example of the contribution of sports sciences on the actual performance. This figure shows running speed. during the acceleration phase of the 100-meter race. The maximum running speed during the race appears around here at the 40 to 50 meter mark. This is highly correlated with the goal time of the race. And the duration while human can accelerate is limited to 5 to 7 seconds. So human can only accelerate for 5 to 7 seconds. And these figures on the right side show the relationship of 100-meter race time on the horizontal direction, and with a maximal speed during the race on the left side, and on the time to maximal speed on the right side. So as you can see, the figures clearly show that the time to maximal speed on the right side does not relate to the maximal speed, the race time, so the performance. But the maximal speed during the race is highly correlated with the goal time. So regardless of the acceleration time, the maximal speed is highly important and should be prioritized to improve the 100-meter race performance. And in other words, the duration of the acceleration cannot be prolonged, so it cannot be lengthened to improve the sprint performance. So to increase the maximal speed through the better acceleration is important for 100-meter race performance. So we should prioritize to improve the sprint acceleration performance, to improve the entire sprint performance for 100-meter race. And this is the reason why I study accelerated sprinting. As another background of my research is,
Así manténme monótono, okay?
Do you have any question?
No.
Is that okay? Okay. So as another background of my research is, from the practical perspective, it has been mentioned that there are sections during the sprint acceleration. And it has been said that to recognize the sections is important for better sprint performance. Moreover, it was sometimes mentioned that there is a transition between the sections during sprint acceleration. It's like shifting gears during the driving a car. So, however, there was no clear evidence of the sections as a difference in biomechanical features. So to investigate whether there are sections and transitions during the sprint acceleration, step-to-step approaches were necessary, as a location where the transition happened did not know. So I have investigated the sprint acceleration step to step for the entire acceleration phase. So to do that, I have used multiple devices to investigate the step-to-step changes in kinematic features. When I was a doctoral student, I investigated kinematics using the 60 infrared cameras, like a Vicon, probably some of you know. And these small dot indicates the cameras. So the running for 50 meter long running track was surrounded by the many cameras. So this is one of the methods I have used to investigate the kinematics of the sprint acceleration. And this stick figure shows the changes in sprinting motion during the entire acceleration phase, from the start to the 50 meter mark. And when I finished my PhD journey, I was keen to collect ground reaction force during the anti-acceleration phase. But collecting ground reaction force, probably some of you knows, for the anti-acceleration phase is like a dream. So it was impossible dream, but the dream came true for me. The former president of our university, the Professor Tetsuo Fukunaga, his picture on here, made a crazy facility, including a long force platform system on here, as shown here. This can measure the ground reaction force for 50 meters long. I was not involved in at that time, but joined in 2015. Actually, the Professor Fukunaga is one of the legends in biomechanics, known as a pioneer of the muscle architecture researches. But he did some sprint researches in 40 years ago. So to measure the ground reaction force for the entire acceleration phase is also his dream. So he made it, and I joined ownership. So finally, we can measure the ground reaction force and running motion simultaneously. Compared to the single-step research, collecting and analyzing, as well as making a story of the study, are not easy, as there are normally 25 steps during the sprint acceleration phase. But we could find some unique aspect of the sprint acceleration. So I will talk about what we found in a recent 5 or 6, 7 years. So the first topic is biomechanical features of sprinting. Understanding a structure of specific sports is of great importance for considering the techniques and training programs for improving the performance. So I just show you the biomechanical features, and it doesn't relate to the performance, but to understand the structure, how we sprint and what is changed is important to understand for considering the training and improving the performance. Okay, these stick figures on the left side shows changes in running motion from the first step to 25th step. The motion looks smoothly changed, and it looks no transitions and sections. However, as shown in a figure on the right side, there are unique changes in variables. This figure shows serial changes in whole body center of mass height during the sprint acceleration for 2 trials from 1 sprinter. As you can see, at around the 5 and 25 meter marks, there are 2 distinctive points of changes in center of mass height, and the magnitude of elevating center of mass changes at these spots. This characteristic feature could be seen for the most of sprinters, so we decided to use the center of mass height as a criterion for detecting the transition step. This figure on the left side shows step-to-step changes in center of mass height for 12 sprinters, and the black line indicates the average of all sprinters. As you can see, the figure can be there can be 2 breakpoints and the breakpoints for each sprinter could be detected. So we call these breakpoint steps as transition steps. The average step number and distance for the first transition was 4.4 and approximately the 5 meter mark. For the second transition, the average step number and distance was 14.1 and approximately 22 meter mark. Based on these transition steps, the acceleration phase could be divided into 3 sections, and we call this as the initial, middle, and final acceleration sections. The breakpoints during the sprint acceleration has been confirmed in the other previous studies after I published the first paper. And there can be some abrupt changes during the sprint acceleration. The figure on the right side shows the changes in hip joint height and vertical distance between the center of mass and hip joints. Looking at the changes in variables across the first transition step around here, the magnitude of elevating hip joint became small at the next step of the transition step. So the legs are considered to be responsible for the center of mass elevation across the first transition step. For the second transition around here, the distance between center of mass and hip joints were maintained after the breakpoint step. So the upper body are considered to be responsible for the center of mass elevation across the second transition. Okay, next is a kinematic feature across the first transition. These figures show the average contribution of the rotating and lengthening reverse pendulum model during the support phase. Although the components for horizontal velocity did not show characteristic changes across the first transition step, at the fourth step, the upward contribution of the lengthening components, shown here, started to decrease, while the downward components of the rotating components started to decrease. So around here. This can indicate that the whole leg action during the initial acceleration section is more linear, emphasizing the extending motion than that during the middle acceleration section. The figure on the right side shows the changes in knee joint angle during the support phase from 2 steps before to 3 steps after the detected first transition step. Until the transition step, the knee joint did not flex during the support phase and only extended. So extending knee and hip, only extend knee and hip during the support phase. However, at the next step of the transition step, the knee joint started to flex during the first half of the support phase, and then afterward, knee extends. And this can be seen after the first transition step for all the subsequent steps. This also indicates the abrupt adaptation of the human locomotor system at the next step of the transition step. The figure on the bottom shows the foot contact location in relation to the center of mass and step frequency. At the first transition step, the foot contact location is behind the center of mass. So the sprinter contact the foot behind the center of mass until the first transition step. But the foot contact location becomes in front of the center of mass after the transition step. Moreover, the step frequency rapidly increases until the first transition step, but then levels off at the next step of the transition step. In summary, the leg and knee joint knee extension are kept to the first transition step, but and the foot contact location, knee joint action, and contribution of the model components abruptly change at the next step of the first transition step. In terms of the ground action force, there are also specific changes in variables across the first transition step. Although the vertical impulse smoothly changes, there can be specific changes when the vertical force is divided into 2 phases, during the braking phase and during propulsive phase. The figure on the right side shows the step-to-step changes in effective vertical impulse during the braking phase on the left and during the propulsive phase on the right. So this shed area indicates the braking phase. So we calculated the impulse during this shed phase and plotted on the left. Okay. The vertical impulse during the braking phase is initially negative. So it indicates that the body accelerated downward and the vertical force is smaller than the gravitational force. However, it abruptly becomes positive and increases from the sixth step during the accelerated sprinting. At the same step, the vertical impulse during the propulsive phase started to decrease. This can be considered as a phenomenon across the first transition step. The figure on the bottom left shows the ground reaction force signals before and after the transition step. This is the anterior posterior ground reaction force, and this is the vertical ground reaction force. Until the transition step, there was no second braking phase, but it appears at the next step of the transition step. And this second braking phase is the cause of the abrupt increase in vertical impulse during the braking phase across the first transition. Based on the previous findings regarding the contribution of the joint moment to the ground reaction force, the knee extension moment is a possible source of the second braking phase. The knee extension moment contribute braking at around here. So this probably made the second braking phase. As the knee flexion during the initial support phase appears at the next step of the transition, as shown in a previous slide, increase in knee extension moment through the eccentric force production could alter the force production pattern during the support phase across the first transition step. Okay. So this video shows the joint torque during the entire acceleration phase. Actually, this is the ongoing project, so I just show you the preliminary results to consider what is the cause of the first transition in terms of the joint kinetics. Okay, this figure on the left shows the center of mass height for the typical sprinter. Changes in magnitude of elevation can be found as a first transition step. The magnitude of hip flexion during the support phase largely increases at the next step of the detected step. When looking at the step frequency, this was the step frequency. The rapid increase was not maintained at the next step of the detected in transition step. The effective vertical impulse shown as a blue line during the braking phase started rapidly increase at the next step of the transition step. In terms of the joint kinetics, the mean hip extension moment shown as a red line during the support phase reaches its maximum at here. And then it decreases thereafter. Taking these into account, the limits of hip extension moment during the support phase can be a cause of the abrupt changes in variables. As a summary of the possible context, at the transition step, there are no knee flexion during the support phase and no upward acceleration during the no knee flexion during the support phase and no upward acceleration of the center of mass during the braking phase. Moreover, the hip extension moment during the support phase reaches its maximum. And this limits increase in step frequency. In addition, the rapid center of mass elevation through the extension across extending action also reaches its limit. At the next step of the transition step, the foot strike location becomes in front of the center of mass, and the knee flexes before extending during the support phase. And center of mass is accelerated upward during the braking phase. As the knee flexion starts, there can be negative knee joint power during the initial support phase and the next step of the transition step. Taken all together, the possible trigger of the first transition is that the extending action through the hip extension becomes its limit, and the attractor of the cyclic movement possibly causes the abrupt alteration of the human learning modality. Okay, the next is the characteristics of second transition. Okay, actually the second transition happens smoothly compared to the first transition. The figures on the left side shows the thorax and pelvis joint angles during the anti-acceleration phase. As you can see on these figures, this is the average angle during the anti-acceleration phase. The magnitude of changes in both angles alter around the second transition at the 14th step, around here. This indicates the stable applied trunk. The trunk angle leans during the initial acceleration, but it becomes applied around the 14th step. And this applied trunk have some meanings on the sprinting. The figure on the right side shows the step-to-step changes in support hip mean extension velocity and range of hip extension and flexion. So this is the hip extension angular velocity during the support phase, and this is the range of hip extension and flexion. Both hip kinetic variables start to decrease from the second transition step as a characteristics of second transition. In terms of ground action force, this is the same variables shown in explained for the first transition. The effective vertical impulse during the braking phase and propulsive phase showed changes in magnitude of decrease and increase, respectively, across the second transition step. Okay. The figure on the bottom bottom right shows the ground actions for signals before and after the second transition step. At the transition step, the first propulsive phase disappears, and this disappearance of the first propulsive phase at here is maintained during the anti-acceleration phase. And this causes the abrupt changes in effective vertical impulse during the braking and propulsive phases. Okay. In terms of joint kinetics, this is also the preliminary results. So it's not published finding, but I will show you some aspects of transition. The mean absolute joint moment of the hip extension and flexion during the support phase decrease to the 15th step and increase thereafter here. Moreover, the hip flexion mean moment continues to increase during the final acceleration section. In addition, the mean hip extension moment started to level off across the second transition step. As running speed increases, the muscles become difficult to maintain the same force production. However, the hip joint torque maintains or increase across the second transition step. So this stop decreasing shows changes in the usage of the muscles across the hip joint across the second transition step. As a summary of possible context across the second transition, before the transition step, the trunk angle increases and center of mass is elevated. Moreover, the hip range of motion and extension velocity during the support phase increases, while the hip extension moment during the support phase decreases. After the second transition, the trunk becomes stable applied posture and center of mass height is maintained. Moreover, the hip range of motion and extension velocity during the support phase decreases, while the hip extension and flexion moment during the support phase increases. As sprinters needs to raise their heavy trunk and head during the middle acceleration section, the roll of legs possibly changes with stable upright posture of the trunk across the second transition. So the sprinter needs to raise their trunk during the middle acceleration phase. So the legs have a role, have a function to raise the trunk, but the hip does not need to maintain the role after the trunk becomes upright position. So the stable upright trunk posture is a possible trigger for inducing the different running modality. Okay. Okay, the next topic is the determinants of sprint acceleration. So this is much more interesting for many of you. The important aspects of sprinting also changes with increasing the running speed. The first is the special temporal variables for the sprint acceleration. The figure on the left shows correlation coefficient of the acceleration with ratio of changes in step length and frequency. In general, the acceleration was correlated with increment of step frequency during the initial acceleration section, but with the step length during the middle acceleration section, and with step length or frequency during the later acceleration sections. Based on changes in relationship of acceleration with step length or frequency, the entire acceleration phase can be divided into 3 sections at the 4th and 15th step. So these results also supports the concept of the 3 acceleration sections. The figures on the right side shows the changes in correlation coefficient of maximal speed with step-to-step acceleration and maximal acceleration and running speed. So the maximal speed is highly correlated to the goal time, as I shown at the first 3 slides or something. So the maximal speed can be represents the performance, the goal time. So I would like to show which section is most important during the acceleration phase. The results show that the maximal speed is correlated with every step running speed. Sorry, the running speed at every step was correlated with the maximal speed. So the faster sprinter is already fast at the initial step. On the other hand, the correlation coefficient between the maximal speed and acceleration increased to 6th step and then maintained and decreased from the 15th step. These results indicate that the higher maximal speed is more rely on the acceleration performance during the middle acceleration section. Actually, the phenomena of the 2 transition does not relate to itself to the running performance, but taking into account the sections of the acceleration would be important for better training and race strategies. So the middle acceleration is most important section during the entire acceleration phase. The next is ground reaction force variables. This figure shows step-to-step changes in anterior-posterior ground reaction force curves during the entire acceleration phase. During the initial acceleration section, the anterior-posterior force production during the mid to late support phase, shown by the red background, was positively associated with acceleration performance. However, as the athletes progressed through the acceleration from the 13th step, this positive association with performance shifted toward early phases of the contact. So the red colored area shifted toward the earlier support phase. So the important phase during the support phase shift from the later support phase to early support phase during the as running speed increases during the acceleration phase. This highlights the broad kinetic requirements of sprinting and conceivable need for the athletes to target the improvements in the different phases separately with demand-specific exercise. So the specific training is necessary for initial acceleration and later acceleration phase. Okay, so during the initial acceleration, greater propulsion is necessary and important. But when approaching to the maximal speed, attenuating braking force is important for improving the sprint acceleration performance. In terms of kinematics, we investigated the relationship of leg segment angular velocity during the support phase with the running speed at each step using a statistical parametric analysis. Actually, this is very complicated study, so please don't mind if it is very difficult to understand. And the figures on the left side shows the serial changes in segment angular velocity for the thigh, shank, and foot. And these figures on the right side are the example of average profile of segment angular velocity and SPM T-curve. So this is the thigh segment angular velocity during the support phase, and shank angular velocity during the support phase, and the foot angular velocity during the support phase. And we tested the relationship of these angular velocity and the landing speed at each step using the SPM analysis. And this shed area indicates the significant correlation. So for the shank angular velocity at the A step, the significant correlation found during the first 20% of the support phase. So greater shank angular velocity during the initial support phase is important for better sprint acceleration, sprint running at the A step. Okay, and I summarize the results like this. So I divided the acceleration phase based on the breakpoints. So we have 3 sections. And I summarized the results based on these 3 sections. And the higher running speed during the initial acceleration section was associated with faster forward rotation of the thigh during the middle acceleration section and later acceleration, later support phases and middle support phases, and of the shank during the middle support phase. So rotating shank and thigh during the middle acceleration and thigh during the latest acceleration section is important for better acceleration in terms of kinematics. During the middle acceleration section, higher running speed was associated with faster forward rotation of the shank during the initial support phase, and of the thigh during the middle support phase, and of the foot during the later support phase. In addition, higher running speed was associated with slower forward rotation of the thigh during the initial support phase. This indicates that the faster thigh rotation just after the foot slide is advantageous for higher running speed during the middle acceleration section. So this is because the fast thigh rotation canceled the fast forward rotation of the shank. So this induced the knee extension, and that is not good for superior acceleration. and that increases the upward acceleration of the center of mass. During the final acceleration section, the higher running speed is associated with faster forward rotation of the shank during the middle support phase, and of the foot during the later support phase. Taken all together, it can be said that important leg kinematic features for higher running speed shift across the acceleration phase. For the initial acceleration section, the shank forward rotation during the middle support phase and side forward rotation during the middle and the later support phase are key kinematic features on here for higher speed. For the middle acceleration section, the shank forward rotation just after the foot slide, side forward rotation during the middle support phase, and foot forward rotation during the later support phase are likely essential for higher speed. For the final acceleration section, the shank forward rotation during the middle support phase is for the middle support phase, and foot forward rotation during the later support phase are likely important feature for higher speed. So these are the kinematic feature for the better acceleration, better running speed during the acceleration phase. Actually, we have 10 minutes left, so I skip this slide. Okay, so these are the kinetic feature of the better acceleration performance. Okay, I move to the strength determinants of the acceleration performance. In this study, I employed these for vertical jumps, squat jump, rebound jump, and counter movement jump, and ankle continence jump. These jumps can measure the different type of leg strengths. So I used these and tested with a relationship with the acceleration. The ankle continence vertical jump is not popular, so I just show you what is the ankle continence jump. She is the national champion in 3 years ago, and sorry, this is the preparation jump. So this is not the ankle continence jump, but he starts ankle continence jump right now, and the ankle continence jump is a jump only performed with the ankle plantar flexion without knee flexion and extension. So this vertical jump can measure the ankle stiffness, okay? And as a result, squat jump and counter movement jump height was significantly correlated with acceleration from the 5th to 11th step. While an index, the values of the jump height divided by the contact time of the ankle continence jump was correlated with acceleration from the 14th to 19th step. These results indicate that the different jump modalities can predict the sprint acceleration performance in the different section of the entire acceleration phase. Moreover, it is probable that to improve the sprint acceleration performance, developing sprint strength power capability of the whole leg and reactive strength power capability whole leg, and the reactive strength power capability at ankle joint is also essential for middle and final accelerations, respectively. So in terms of strength power capability, the different strengths power capabilities are required for the different acceleration sections. Okay, the last topic is a contribution of sports sciences on an actual performance. The contents are not from my studies, but I show you the contribution of the research findings on the actual sprint acceleration performance in Japan. At first, please let me talk about the sprinters in Japan. Currently, there are 3 sub-10 seconds sprinters in Japan. Moreover, Japanese 400-meter relay teams got the medals in recent 3 World Championships and Olympic Games. But unfortunately, we couldn't get the medals in the Tokyo Olympic Games. So we shamed that, but we got 3 medals in other recent World Championships and Olympic Games. These achievements have been made, of course, by their efforts. However, to improve the sprint techniques, a lot of scientific knowledge has been used. In 1980s, coaches gave sprinters advices based on their experience. For example, those were to lift higher during the to lift thigh higher during the swing phase, to extend the knee at the end of the stance, and to bend knee during the swing phase. To confirm whether their advice are scientifically correct or not, Japanese Association of Athletic Federation performed a project to collect the data in a World Championship in 1991 in Tokyo. It's almost 30 years ago. These are the results of the project. The figure on the left side shows the relationship of the running speed at the maximal speed phase with a hip, knee, and ankle joint extension velocity during the support phase. The hip extension velocity at here shows weak relationship with running speed, but it is important. Looking at the figure on the middle at here, interestingly, the knee extension velocity have negative relationship with running speed, indicating that the fastest sprinter did not extend the support leg knee quickly. So we need to suppress knee extension during the support phase. This was contradicted to the coach's advice, and the knee joint angle is one of the technical indicator for better sprinter performance. The figure on the right side, these 3 figures, show the relationship of the running speed with the maximal hip extension, maximal knee flexion, and maximal leg angular velocity, leg angle during the swing phase. The results indicate that the maximal hip flexion angle, so this indicates the thigh lift angle during the support during the swing phase, does not relate to the running speed. So the results indicate the maximal hip flexion angle is not important for their performance. And this contradicted to the coach's intuition. And the other interesting finding was that faster sprinters run with greater maximal knee flexion angle. This means that the faster sprinters did not flex the knee largely during the swing phase. This is also not consistent to the coach's advice. Sorry. Okay. As explained, the knowledge gained by the project has contributed to the practice, and the same results have been found in many studies in Japan. The illustration on the left show why smaller knee extension during the support phase produce the greater running speed. So suppressed knee joints can make the greater distance of the ankle. So with extending knee, the distal end of the leg does not move large, but suppressed knee extension can make the greater horizontal transfer of the end of the leg. So this is the explanation of why suppressed knee extension is important. So finally, based on using these technical advice, there are 3 sub-10 second sprinters. Okay. So let's move on to the conclusion. There are 3 conclusions, very short. Okay, one is that there are transitions and sections during the inter-acceleration phase. And there are different determinants of the sprint performance among the sections in terms of spatial temporal variables, joint kinematics, and leg strengths. Okay, and the research on sprinting improves sprint performance in Japan. So the sports science research can contribute to the actual performance. Okay, I finished my talk.
Okay, thank you very much, Professor Yunagara, for excellent presentation. And this is new knowledge for us about the acceleration, also about the platform. In Indonesia, we don't have about 50 meters. Maybe if have just one university, maybe in Surabaya, just 1 meter or 3 meters, Surabaya or Jakarta, about the platform. I think you already have been to Jakarta before. And okay, now we're going to the session of question and answer. In here, we already have many questions from Dr. Agus Irwanto. It's about how to train the muscle, the thigh muscle for children under 10 years old.
Okay, it's not my area of expertise, but yeah, some studies recommend to do some exercise, including the stretch shortening cycle. So that is one of the possible choice, but we need to be careful because there is probably some of you know, there is peak height velocity. It appears from the 9 to 12 years old.
Mm-hmm.
During that age, the bone rapidly lengthen. So the standing height accelerates to be high. So during that age, we don't need so excessive stress on the bone will impair the lengthening of the bone. So we should be careful to instruct the training to the kids during that age. But before the 9 years old, the acceleration doesn't happen. So the jump exercise possibly be a good exercise, but excessive training is also not good probably. So it should be carefully apply the training programs for them.
Okay, so what is the proper exercise for the children under 10 years old? What do you think about that? For maybe just running, not running, or maybe just doing jogging or something? Based on your study. no.
Actually,
you don't have that.
I don't have a study regarding the exercise type.
Mm-hmm.
So, but in my knowledge, so many types of exercise should be employed for kids. So not focus on specific sports. Okay, so not only running, but also jumping and slowing and swimming should be included for the exercise. And one important thing is that in Japan, the children, there is no place to do that, to pray in a
Public area?
Especially the big town. So there is no park and only the room, a small room to do the exercise. So the important thing is for them to keep the large amount of volume for the exercise. So for recently, the kids cannot do the exercise enough amount of volume. So in Japan, we encourage them to keep the large amount of exercise volume. So that is one of the important things. So normally the kids is lack of exercise volume in Japan. So we encourage them to move more and run more and jump more. Okay, so that is possibly different problem in Indonesia, but we advise them to do the multiple tasks, large number of exercises, and the enough amount of exercise volume. That's all.
Regarding your mention before about peak height velocity, so this is the time that the children can give the training program. You said that like that, or would you pardon your information better?
I'm not good at knowledge for what we should during that age, but during that age, this is just my opinion. There is no evidence, but during the peak height velocity, there is adjacent awkwardness. That is during that age, the children, the ability to run is impaired by the lengthening bone. So there is a lack of muscle volume during that age. So the children's performance decrease during that age. That is called adjacent awkwardness. Sorry, my pronunciation is not good, but the exercise ability is impaired during that age. So we need to carefully test the kids. The children naturally impairs the sprint performance during that age. So I'm not sure what we should apply as an exercise for them, but we should. I just can say I'm not sure what type of exercise is best, but during that age, not only the sprint performance, but also the other function is impaired. So we carefully evaluate the performance during that age and carefully apply the exercise for them during that age. Because the bone is lengthening and there is lack of muscle volume. So the performance is naturally impaired, decrease. So my advice is just wait, because during that age, the children, some children feel not good during the exercise. They hurts the knee or other parts of body. So do not insist them to do the exercise during that age. That is only I can say for them
That's good. So what is your recommendation for a kid can do exercise training? The age.
For kids.
Yeah, I mean for the age. so they can begin to starting to exercise. Yeah.
Actually, in terms of exercise,
yeah,
they should in every age, but for the strength training, they should not start before 12 years old or 13 years old.
12. Okay, so
Okay,
in the
but-
big height procedure.
Yeah, but the kids should keep the training volume during the younger ages. So in Japan, there is a lack of exercise volume for children. So we advise their parents to increase the volume of exercise for their health and for the yeah, actually the exercise is important for studying, for the brain can be better.
Ya, makasih bro.
Okay. Is that okay?
Okay. Okay. So that's very good answer. And okay, thank you, Professor Rio. This is also answer from question Dr. Abdul Khalid, Dr. Abdul, that asking Sim about for the kid exercise. And this is have okay, Dr. Henry say, is it the katsu from Japan exercise could be applied to children?
Actually, I'm not sure. Yeah, katsu is using some bands on the proximal ends of the segment, so that restrict the blood flow. But I have no idea regarding that. Yeah, sorry, I'm not sure, but actually for me, I don't have evidence regarding katsu is better or not for kids, for children, but for children, I recommend them to do the training with not the special training, just run around the house or park and swim in the river or sea. So I feel not the coach should provide them the situation they can do the exercise. So not specific special training is necessary for them, but the important thing is that training the exercise volume. So, and the many types of exercise they should do. Okay, sorry, not a good answer, but
Okay, thank you, Professor Liu. And then this is a question from Mr. Yusan. He asking about what impact on real world or tournament of your research. Are there a lecture to athlete about the body position to achieve the best results? And then he asking also about, is there any association between tight muscle strength to the size and length circumference of the muscle, and the tight muscle size with the acceleration?
I'm not sure what is asking from the first question.
Okay, I think he asking about your research before and what the impact to the athlete, the performance in athlete that you said already have a 3 gold medal, right? And so you give some give recommendation to athletes, so you train them what should they do, so what the biomechanic position when they running. Did you do that?
Okay. So I use the knowledge from my study I actually do the coach. So I coach sprinters. So I use the knowledge, what I found by my research. And so actually one of the answer, the body position is the trunk angle should be forward lean position. More forward lean position is better during the middle acceleration section. So I advise them, and actually it's very difficult to evaluate how advice is working on their performance because there are so many advices. Some advice is based on the research findings and the other is not based on my coaching experience. So actually it's very difficult, but my research investigated the training technique, influence of training technique on the actual performance, revealed that some training technique is useful for the actual sprint acceleration performance. So that is working. Okay, this is the answer to the first question. And
second question.
Okay, second question is actually this is not my research, but some researchers found that the muscle volume of the thigh is correlated with sprint performance, but they didn't investigate the relationship at the acceleration phase. So normally the sprint performance is the entire goal time or the maximal running speed. So to my knowledge, there is no study investigated the relationship between the thigh muscle size or thigh muscle size and acceleration performance. So you can find studies investigated each muscle size with the sprint performance. So you can find many studies investigating the relationship between hamstrings muscles, quadriceps muscle size, and sprint performance.
Okay, but how about the leg length?
Length?
The leg length. This is also have a.
Actually, the leg length does not have influence on the sprint performance. Because, yeah, but the leg lengths have an influence on the combination of step length and frequency. So
step length.
Longer leg lengths sprinter run with longer step lengths, but lower step frequency, and vice versa. So the shortest sprinter run with higher step frequency, but their step length is short. So, but the leg length does not influence on the sprint performance.
Oh, I see. I'm sorry.
But actually, the foot length, not the length, the leg length is from the total chanter to the ankle or something. That does not relate to the sprint performance. But the foot length from the toe to the heel, the foot length is actually positively correlated with sprint performance. So longer foot length is better for sprint performance.
Pardon, longer
foot length.
Foot length.
Foot length.
Oh, okay, I see. When I saw the sprinter, usually they touch the ground. It's like not like touch the ground. So how about the ground, force the ground? The sprinter, is it they also touch the ground, but so fast, so it's like not touching the ground?
Yeah, actually, the sprinter touches only the forefoot. So forefoot,
Uh-uh.
the fore part of the foot. So they don't touch the heel on the ground. So yeah, so the strength of the foot finger is also related to the sprint performance. So the foot muscles are very important for sprinting. Not only the thigh and shank muscles, but also foot intrinsic muscles are also important to improve the sprint performance.
Okay, thank you. In your study, also you study about which muscle in the thigh muscle have a dominant contraction?
Actually, there are many important muscles for thigh muscles. Actually, rectus femoris is one of the important muscle for high speed sprinting, and also the biceps femoris, long head, have been found to be important for sprint performance. And I forgot the name, but the medial side of hamstrings muscles. I forgot the name. Sorry, but the hamstring muscles, there are 4 muscles. All these 4 muscles are important for better sprint performance.
Femoris,
Biceps femoris, and
then lateral, vastus medialis.
yeah.
Oh no, vastus in the quadricep.
Vastus, not the vastus lateralis. That is not found to be important. So these are the important muscles. So do not focus on the vastus lateralis or vastus medialis or something, but only the rectus femoris is important. Only the rectus femoris is important muscle for the front side muscles.
How many percentage when people are doing sprinting, so the contraction, the dominance?
I don't remember how strong the relationship. Sorry, I can't say how much.
It's okay. It's interesting. Okay, because it's important, right, about the running. Also, when the people can start running exercise, I mean, for being to be athlete, based on your study.
So I couldn't understand what you're.
I mean, what is the best training for the athlete? Yeah, the best start.
It depends on the situation. Yeah, there are so many training methods and training techniques. So it depends on the situation. When you target to improve the maximal speed, and before 1 week before the competition, so in that situation, the assisted sprint training can be important, can be useful. So that is the sprinter pulled by the other athlete from in front of them. So that can be important training. But when the competition is not close to the resisted sprint training can be one of the option to improve the sprint acceleration performance. So for the initial acceleration, the resisted sprint towing the sled can be important for the initial acceleration, but that cannot be important, cannot be useful for high maximal speed training. That makes sense?
Okay, thank you. And this is have any question again about okay, about the application software maybe. So this is from Isyani Undigma. She asking about the recommendation for the software to analyze the biomechanic movement, to analyze biomechanic in sport. What usually you use?
Actually, this is also depends on the situation.
Mm-hmm.
In the laboratory, if you have a motion capture system and it's perfect, but in the actual training session or competition situation, like a video analysis could be better. And recently, some device using the inertial measurement unit can be possibly used in a training field. And I'm not sure the application means the software or the device, or so it depends on the question. The application means so analyzing biomechanics data. I use the MATLAB for coding. So I recommend to use the MATLAB for analyzing data processing purpose.
Okay, but your facility is expensive facility, right?
Yeah.
Yeah.
I think so.
The only one in the world have a 50-meter of a platforms. And how about the camera? Is how many camera in there? I remember, I think more than 50. It's
Actually,
1 meter.
Recently, the number was increased. So now we have approximately 50.
50.
50.
Yeah. Oh, yeah, 50.
Cameras we have.
High-speed camera.
Actually, the motion capture infrared cameras.
Mm.
You know, the like a Bicon.
I don't know because I don't have.
Okay, but yeah, we have 50 infrared cameras, not the normal high-speed camera.
Mm-hmm. Oh, I see. So it's very good topic. So any other question? Hello? Oh, in here, that's good. Still have a 100 more, 102% in here. Still following your presentation.
Okay.
Any more question? Okay. Okay. Mr. Yusan say arigato.
No worries. My pleasure.
Okay. And any else question? Okay. So is it also applicable in for football? Yeah, acceleration, because sometimes football have like running, not running so fast. Also, the direction is different. But they also needing something like how to catch the ball. So how to train them to make better?
Actually, basically, they should train like pure sprinters. But they don't need to run around the maximal speed. So the important ability is to accelerate for the short distance. So the soccer players should focus on the acceleration performance for the short distance. And then from that aspect, I recommend them to do some resisted sprint training, pulling the sled, towing the sled, and also I don't know, but I recommend to do some parametric training. The parametric training is not only to improve the leg strength or reactive strength performance, but also used for improving the technique, force application technique on the ground. So that is possible training. Actually, but for the first, the soccer player do not care the sprinting technique. Okay, so the first thing we should do is that the sprint they need to understand the sprinting is technique. Okay, so they don't care the technique for sprinting. They care about the technique of kicking or dribbling or soccer strategy, but they should understand if they want to sprint fast, they should understand sprinting is a technical task, not only the talent. So that can be improved by the training. So that is the first thing they should do for the training.
Okay, thank you. Is it okay?
If you do I have some time?
Yeah. Okay.
So if I have some time, I show you some example.
Mm-hmm.
Can you see the
Yes, I see.
slide?
Yes.
Okay. So I said, because there was I didn't have a time. I didn't say how should we train for these ankle reactive performance. So the important thing is that this jump is performed within 0.12 seconds. Okay, so normally the reactive jump, like a hurdle jump or box jump or drop jump, the contact time is longer than 0.15 seconds. That is too long to perform the force. So to improve this kind of jump performance and also the sprint performance, the jump training should be performed with shorter contact time. During the sprinting, the good sprinter contact to the ground less than 0.1 seconds. So very short. So the jump training should be performed with very, very short contact time. So the normal hurdle jump or some exercise, the contact time is too long to improve actual sprint performance. So that is one advice from me for the strength training. Okay, that is what I wanted to say.
Okay, thank you very much, Professor Ryo Nakahara. Excellent presentation. And I think we're going to the last session. So any last question Professor Fatur Rahman, you want asking something? Okay, not yet. Okay, so in here also still have Dr. Stella Hayu, who is the coordinator program of
Enough.
physical
Thank you.
education, and Professor Sugianto and Professor Sugiharto, that from Sports Science Department. Here, Professor Dr. Setio Rahayu. Okay, okay, we're going to the last session. Is about certificate. Yeah. Certificate appreciation from our dean, and she said greeting for you, and now she said sorry because cannot say directly to you because now she is at Papua for sport event.
Oh, that's good.
Yeah, in Papua. So in the west of Indonesia. West, yeah, I think. And thank you very much, Professor Ryuna Gahara, PhD, for your time and for your excellent contribution and presentation to support this program, the World Class Professor 2021, with the topic Sports Science Research Application from 9 a.m. until 4:11 p.m. I think now it's more than 15. So Professor Tanya Rahayu said thank you. And Dr. Setia Rahayu, you want to say something to Professor Yu? He is my advisor when I was bachelor degree, and now he is a coordinator program of physical education.
Okay, thank you very much, Professor Ryu. Yeah. I think this is a good moment for the collaboration in lecture, and maybe next time we can continue with other collaboration, maybe in research or publication. Okay, thank you very much.
Yeah, thank you.
Nice presentation.
Thank you for inviting me. I was happy to talk about my research at here.
And here also have the coordinator program of sports science, but he's still on driving, going to home. So, and he say everything to you. Thank you very much for your excellent time to share with us. And could we all take a picture together for the last moment before we close? Okay.
Okay. I'm not sure. What should I just keep it?
Yeah. Wait a moment. Taisa. Where is my my student already go home? Oh, wait a minute.
Should I need
Okay. Please turn on your camera for participants so we can take picture together.
Just wait.
Yeah.
Yep.
Okay. You can make up to make prettier or handsome. Oh, that's good.
I just added the light.
Yeah. Oh, this is Hapsil, Professor Sugianto in here. Okay. Okay. Are you ready? One slide. Here are Santis. Give smile, the big smile. Smile. Okay, wait a minute. Second. Nalina. a second. So this is from at 9 have a 286 participants, now going to 76. So here is the man strongly student. Okay, and the third, okay, they don't want to show up. I don't know why. Maybe they're outside. And the fourth. And the fourth system. Okay, that's good. Okay. Oh, here the participant asking, can they get your presentation? Also here have a greeting from Professor Fatur Rahman Kaprawi from Sport Science, UNESA Surabaya. Okay, thank you. So anyone want to say something to Professor Ryu? Professor Sugianto, you are still here, right? Oh, already. Yeah. Okay, maybe you have something to do. Okay, thank you very much, Professor Ryu Nagahara. So I hope we will have collaboration in the near time about research or publication. And actually, I'm studying about now, going to study about PHV, peak height velocity in children, is about 10 to 13 years old in the club, football club. So just comparing about the time, frequency of time. So maybe we can collaboration about how to writing the manuscript and publish. And okay, I don't see Professor Sugianto. Okay, so thank you.
Hi, thank you.
And I hope we can meet in the different time and
Yeah,
different occasion.
in a face-to-face.
Yes.
In a near future.
And keep healthy and keep happy.
Yeah.
How is Kanoya right now?
Actually, in Kagoshima Prefecture, we have 1 or 0 or 1 or 2 cases recently for the COVID-19.
Oh,
so only 1 or 2 or 3 cases recently we have. So it's very safe, and we do normal.
So no mask or no
actually, we wear the masks. Yeah, but there is no restriction.
Okay.
Yeah.
You did also vaccine?
Yeah, I'm vaccinated. Yep.
What is you use in there? Is usually used for vaccine?
Pfizer,
Moderna?
Yeah, and Moderna.
So only one time?
2 times.
Oh, 2 times.
2 shots. Yep.
Okay. Thank you, Prof. Ryu. So see you next time.
Yeah.
So we
Bye-bye.
are closing now. Alhamdulillah Rabbil Alamin.
Amin.
We are already finished for all activity from 9 p.m. to 4:30 p.m. Thank you very much for your excellent contribution, for your excellent participation to support this program, World Class Professor Program 2021. I hope all participants always healthy and happy and keep always success in everything that you do.
Amin, amin, amin.
So see you in another occasion. Bye-bye.
Thank you, Bu Titi.
Teman-teman semuanya.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih Pak Kolik.
Nggih, sami-sami Bu, nggih.
Salam sehat.
Sehat, amin, amin,
Makasih
amin.
panitia UNES, luar
Ya,
biasa.
siap.
Luar biasa Bu Titin.
Luar
ini.
biasa UNES.
Kita
Seharian
pagi sampai sore Kak.
penuh ndak beranjak ini Bu Sri ini.
Nggih, ya. Enggak peduli sama sekali nih.
Pergi
Salut
Pak
ya,
tadi
Bebe.
ke belakang Pak.
Iya, iya.
Nanti tiga di
Sehat
UNES.
selalu, Titin. Sehat selalu, nggih. Sehat semua, ya.
Ya, sehat.
Amin, amin,
Jangan
amin.
lupa diisi ya Bapak untuk link
Nggih.
sertifikatnya.
Iya, Bu.
Aha, jangan lupa dan nanti make sure untuk tulisannya namanya benar dan emailnya benar agar bisa langsung masuk ke email.
Bu, bisa diulang lagi, Bu, untuk linknya, Bu. Karena
Oke,
tadi,
linknya ya.
nggih, Bu.
Oke.
Tadi terlambat. Sudah masuk, tapi khawatir nggak masuk lagi.
Ya, enggak apa-apa. Buat yang banyak, Pak.
Nggih,
Ini saya
bikin
baik
lagi.
hati, jadi
Iya, iya,
it's
iya.
okay.
Semoga terusnya baik hati sama kita-kita.
Amin. Ini ada apa kok dari Pak Kajur nih. Pak Kajur ngucapin terima kasih. Makasih Pak Kajur. Selamat dan sukses. Terima kasih Pak Abdul Khalid. Pak Abdul Khalid di Surabaya ya?
Betul, Bu. Nggih, saya di Surabaya terus, Bu.
Maksudnya di Universitas
PGRI di Buana, Bu.
Oh, nggih. Oh, yang di jurnal itu nggih, Pak nggih.
Nggih, Bu, nggih.
Oh, siap-siap. Kayaknya nanti bisa kolaborasi itu ya, Pak.
Amin, amin, Bu,
publikasinya.
ya, ya.
Benar.
Saya harapan itu, Bu, biar cepat saya ikut jenengan, Bu.
Apa?
Biar cepat ikut jenengan saya.
Ikut saya kemana, Pak?
Ya, apa, Skopus apa-apa gitu loh, Bu. Yang lainnya, biar
Saya
cepat.
skopusnya sedikit kok, Pak Masian. Tadi
Ya, ya,
yang presentasi banyak-banyak semua. Yang paling bagus tadi Prof. Kuo.
Iya, iya, iya. Mudah-mudahan, Bu, kita bisa komunikasi, bisa kolaborasi, Bu, ya.
Amin, amin.
Ya, terus, nggih. Masih, Bu.
Sama-sama.
Nggih,
Sehat terus, panjang umur.
Amin, 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 amin. Nggih.
Oke. Thank you. So, Pak Sugiarto, saya izin ini ditutup nggak Pak Sugiarto? Mas, kalau ada yang masih kesulitan untuk menuliskan sertifikat, tolong langsung diinformasikan.
Ibu nggak apa-apa Bu pakai
makasih.
email yang student UNES Bu.
It's okay, no problem. Karena nanti akan masuk ke emailnya langsung. Jadi pastikan nama yang kamu tulis.
Dari
itu
mana,
benar.
sayangku?
Oke.
Ngaji pinter.
Oke, ada lagi? Oke, nggak ada ya. Nggak ada yang tanya lagi ya. Saya close ya.
Iya,
Yang
Bu.
Oke, Fitriana Bella Jaya ini dari Bella Jaya Negara. Kayak pernah dengar namanya.
Ini
Ini Mas.
Bu, yang apa? Penjas A3, kelas A3 Bu.
Ah, ya, 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 ya. Bella Jaya Negara. Oke, oke. Yang sudah.
Ingat Bu. Oke Bu, terima kasih Bu.
Ya.
Terima kasih Bu Titin.
Ya, terima kasih kakakku, kakak kelasku.
Belum ketemu, nanti kapan-kapan ketemuan ya.
Siap.
Siap.
Kita sambil makan apa, bakso atau kakoi gitu.
Iya, di Pasca.
Oh, ya, ini ada Trias juga. Terima kasih. Ini sekarang di mana nih Mbak Luciana?
Mas, saya di
Unwahas. Unwahas atau di mana?
Di Unwahas di CKR Semarang.
Oh, that's good. Jadi bisa ketemu ini.
Iya, bisa, sangat-sangat bisa. Ayo rencanakan.
Ini angkatannya Pak Sugiarto enggak?
Mbak Lucy, halo.
Halo Mas.
Lama gak ketemu.
Ketemunya di dunia maya, padahal deket ya.
Mbak Lucy enggak
Tahun ya,
dibuka
Mbak, ya.
kameranya.
Saya
lagi penyetir. Baru sampai.
Oke.
Sehat ya Mbak Lucy ya.
Ya. Kabar ya Mas Sugiarto.
Gimana?
Minta nomor WA-nya. Mbak Titin, minta nomor WA-nya Mas Sugiarto.
Oh, oke. Aku punya nomornya Mbak Lucy ya? Punya enggak ya?
Iya, ada di grup.
Siap, siap. Terima kasih Mas Trias. Ini sudah dari Persatuan apa namanya Rumah Difabel. Thank you very much. Salam buat yang lainnya.
Ya Bu Titin, terima kasih. Tadi nyimak aja.
Oke. Semoga bisa nambah ilmu ya. Nanti olahraga bareng. Ayo ubah, ayo gerak. Yang penting kita sehat. Yuk.
Siap.
Oke, makasih ya. Saya izin untuk off ya. Saya izin end ya. Oke, bismillahirrahmanirrahim. Assalamualaikum.